Uh, hey Peanuts, could you please add additional 4 minutes to the countdown timer? Really? You want me to do that again? What? You want me to add another 4 minutes? There you go.
I uh,
There's your 4 minutes.
don't do that.
There's Timbo's. Timbo's out there. Hey Peanuts. What's this?
Oh, I gotta mute
So,
myself.
and I've got a mute over there. I think. Where am I?
Yep.
Trying to figure.
Oh, you added the 4 minutes.
Well, that's what he said.
Uh,
He said, "Could you please add another 4 minutes?" It didn't say we had to mute ourselves.
oh, so they can still hear us.
Yeah.
We're just doing
Yeah.
more countdown. Nice.
Okay, what's going on? Try Thinking's changed his thing to West Coast Surfer and the Hillbilly have a chat about horizontal. They still going? What's that one? Is that the same live stream I'm looking at? I'll just check. What one's that one? Or is that the old one? No, it says live. Oh, it's finished. But I rewound it that way.
Okay.
Yeah, I rewound it. That's the old live stream. But I do have.
Did you see Bev's $500 debate challenge?
No, where did he say that on that live stream?
I don't know. Mandelbrot posted a picture of it in Tunes server, so I'll post it in yours.
Yeah.
Uh,
What are you doing, Timbo?
point two is my favorite.
I see Timbo there.
G'day, mate. Can you
With
hear
a
me?
big T.
Yeah, I can't. I'm at work technically, so I can't really
Yeah.
Oh, okay.
can't do the full thing today.
No,
but I
that's
can
okay.
listen in and
That's okay.
chat. Yeah.
Yeah,
Just
this
so you know.
is not really a thing. It's
No,
just
I know.
it's early morning. Blue did his live stream earlier today. I was over there in the live chat afterwards in Discord, and I don't know. We'll just discuss whatever we find. I'm actually over in Beb's server right now, muted, so
All right.
I can unmute that one.
That's fun.
Yeah, I do that now and again. Where am I? I'll just open it up. They can't hear us.
No. Okay.
We just listen to what they go on about.
Oh God, they're so stupid. No, it's level at every point.
Well, Modo.
You know what? I wasn't thinking. I'll be right back. I need to go get myself some alcohol.
What, this time of night? Oh, hi, John.
It's just.
Oh, Lindsay. Oh, I don't know if we're going to have Lindsay this time of morning. Yeah, Beb sounded everywhere. We can't hear it.
That's just
Yeah?
so wrong.
Yeah.
Oh, just because I do a lot of hydraulic design as well. Water's just not level. It just even if the Earth is flat, it's still not level.
What's the
All
technical words you use for when you're getting the actual normal water level that I've used from one point to another? I'm just I used to remember the name.
not quite sure what you're
All right.
referring to.
There's a word.
So what I can tell you is that if you measure in a river or a lake or something or other,
Mm.
it's actually very rare that a big body of water is perfectly level from one end to the other, because usually there's a slope. So rivers, a good example. Rivers obviously fall downhill.
Yep.
So even when they're in a slow thing, over say for a few hundred meters, you'll have a different level from one end to the other. So when they're talking about a flood or something like that, yeah, obviously at a building, it may seem like they're the same. And you couldn't measure it anyway because it'd be so variable because of the surges. But if you go over a few hundred meters, or good example, say Lismore, when that flooded, from one end of Lismore to the other, you'd have maybe a drop of at least 50 mil to 100 mil on the surface of the water from one end of the town to the other. Because water has to fall downhill, and having to fall downhill, the surface of the level is different. And same with lakes. Lakes is much smaller. It only might be a few mil from one end to the other of a lake, but it's still falling downhill. That's why all the pressure is on the dam. Like, let's say you've got a dam wall, all the pressure is going to be on the dam wall. Obviously, there's got to be something that's forcing it out at that end. So it's just reality. But that's just beyond them. That doesn't matter whether it's the Earth is a curve or flat. That's just how hydraulics works. Are you able to hear me okay with this microphone?
Yeah, sound fine.
That's good. It wasn't working so good. This is not my good microphone. It's just my headset.
Okay, the $500 challenge is spreading fast. Okay, we're going to have to look at this. I'll just put back on the live over Discord thing for now while I grab that challenge.
I would almost bet he's tied in somewhere. I would be willing to bet he's Freemason or one of those type groups.
Yeah,
I would be willing to bet. I mean, how he acts, the way he's so arrogant, and he
I was reading
say
this challenge that I posted,
bro.
and it might not
Doesn't
be
even blink
from
an
Bev.
eye.
It might be to Bev.
Calls you a
Bev.
lot.
Oh, okay.
Like because of what
because
you're
of how
trying to
some of the
explain,
stuff is worded, which
just
makes a little bit
tactic,
more sense.
You know, straight
but
up
still, it's funny.
tactic, right?
Come out pretty
He's
small.
telling his audience.
I can't get it.
You know,
why is it so small?
I'm blue, right? I'm your father.
Oh, no wonder.
This guy's a liar.
25%.
Don't believe
I better
anything
put
he
it up
says
a
from
bit
this
bigger.
point forward. That's just a tactic. That's not.
25%
is
in
he causing the
Google when
live
it
stream
opened up,
curse?
and I went, why is it so small?
what's that? Who was that?
That might have been a hot mic.
It was me. I was
Oh.
wondering who Terry is
Oh.
and why he's broadcasting you on his YouTube channel.
Oh, Terry, you got caught.
Oh, he's broadcasting us right now? Terry's been around before, huh?
Yeah, I'm just doing a bit of a live stream in general because Blue did a live stream earlier from his channel, and I'm going to replay a bit of that and whatever, just a bit here and a bit there.
Nice. How well do you think he did?
I don't know. That's why we're just going to watch it raw. I'm going to do it raw without any bias to it that way.
Right. So you've not watched any of it?
No. That's what I've just gone live just a little while ago, and I'm just going to start playing it and have a listen to it.
Are you gonna comment on it as you go, or are you just gonna play it?
Usually we just stop it now and again when things are said. Yeah.
Cool. All right. Cool. Good deal.
Sweet. It's a long one.
Yeah.
I know. I was looking at it and I went, oh no, I might have to jump through it a bit. I don't think I'm going to be here for that long. Usually my streams go for about 4 hours. So.
You don't want to miss all the best bits.
Yeah, that's it.
You might could play it in 2x speed. That ain't too bad.
Yeah, get past the blue bit. Yeah.
Yeah. Good deal. Good luck.
Yeah. Make sure you catch all of the contradictions.
Okay.
Or actually, no, they're on Blue's side. Try and skip past all of the contradictions that Blue makes. Only focus on the Mobius stuff.
All right then. You know I'm not a flat earth. You know I'm not a flat earther, Bev.
Yeah.
Good.
Is anyone a flat earther?
That'd be plumb stupid. I'm driving up and down hills right now on the 2D
yeah,
surface of Earth.
the Earth's not flat. You got hills and valleys. What are you going on about?
Mm-hmm.
It's tough to measure flat, I can tell you that. It's very tough. You got to get out on that static water to do that. And then I would say it's horizontal. I wouldn't say it's flat.
How could you measure it though out on the water?
It's tough, ain't it?
Because you don't use a theodolite over the water or an auto level. That'd be fucking ridiculous.
What,
And you
what
don't
did
get
Blue
on a
say earlier?
boat and do it on the boat either.
What did Blue say? He said impossible to detect at working ranges. Anyway, you got to get out past where you even have a chance of detecting it. To
Yeah, you don't want to be one of those concrete workers. Yeah, it's one of them ones that can't measure the curve. You want to be one of them non-local surveyors.
You don't want to be the guy that sets a horizontal every day of his life
Geodetic.
and then measures down the different surfaces. You don't want to do that. You want to get out beyond the working point where, get out into that atmosphere a little bit and let some light do whatever it does. Who the
so I'm
hell
wondering
wants
about
to
like
do it?
those block walls when they're setting the block wall against a taut string to keep the wall straight. Like, do they build up past that string or do they slope down to keep it straight if they want to make it straight? Because he said that the straight ones are actually curved.
Well, yeah, if you want to follow the curvature of the earth, the middle has to go up. Each end, depending on, and if you add on to the wall, you're just freaking screwed, man. You got to tear half of it down.
And a vertical
start
would
over.
definitely curve,
Start in the
wouldn't it?
middle. I mean, think about it. Okay, you run a line and it's horizontal, and you build a wall.
If you want to jump in for
Take
something,
your line
Timbo, at any
and move
time,
it out a little further.
I'll get him
Right,
to
that's
stop
still
talking, and you
horizontal.
can ask
Then
him
move
a
it out a little
question or whatever.
further. Right, that's the top of the wall.
I
the
would,
whole
but I'm
time.
working,
Oh,
so I
That's
thought
still
I'd
horizontal.
get,
Now take your string
working.
down and put it half.
You
Oh,
can always,
no, I don't
down
want
and
to.
move it
you can always type
in
the
any
question out
direction.
for
You
me.
go the one way or the other, and extend that wall a little more.
Oh,
That's still
okay.
horizontal.
I don't want to deal with
They
that
won't
level of
What
understand.
stupid.
point would
They
that
can't hear
start
us,
to
right?
curve?
No. I
Okay.
wouldn't have said that
I would say never.
if I was
I mean, if
unmuted.
you did it right. So in their model, it would just extend into outer space. And if you did it over water, your wall would have to get.
Yeah.
No, I'm just saying, if you work within a project that's at less than 5 kilometers long, then you're never going to have to worry about the curvature there.
Yeah, that's what I've always thought. Why do they always talk about it when it's under?
So
What
when
distances?
you're talking about buildings and stuff like that, it's not even going to
Yeah,
be coming
building
to
doesn't matter.
as a
Swimming
problem.
pool doesn't matter. Garage doesn't matter.
No. So
Like,
it's about 5 kilometers. Then you
what
start
about a
to think
bridge?
about
What
it.
about a bridge, like a really long bridge, like a Golden Gate Bridge, or a bridge?
Well, the Golden Gate Bridge you would, but Sydney Harbour Bridge, it's a little bit, but not really. There's bigger issues as say a bridge like Sydney. You got the temperature differentials, probably a bigger problem than the curvature of the Earth. So where they built Sydney Harbour, it's big, 2 hinges, right, one on either side of the harbour. So it's basically a big hinge in the middle. So when they built out to the centre and were trying to line up the 2 structures, the temperatures were slightly different, so the expansion was wrong. So it took a little bit of time to get the temperature till the temperatures were set. Then they could actually join the 2 bridge halves together. That was more of a problem than the probably 10 mil difference in the curvature of the Earth over that distance.
My mum baked cakes. No, deck don't matter. I can't just say it in a Kiwi accent.
No. So that's for the sort of stuff they're talking about. No, that's why they never encounter problems with the curvature. Got to become a geodetic surveyor or start doing huge distances. Then you start to notice the spherical excess issues. And
Yeah.
you're not going to get. So I think generally it's about 5 to 10K that becomes a problem.
Well, I mean, yeah, it's always, it comes down to scale. They don't realize how big the Earth is and how slight that curvature is, right? Like that.
I've even
Yeah.
tried to even said to him, what if you're an ant? What difference does that make compared to us? Does an ant see curvature?
No. Well, even if you asked them to draw it out, you know how big we say the radius is.
Hmm.
Pick a scale at which you can actually draw it and see the difference. So if you said,
Which
okay,
has been done. We've
I
done
mean,
that for him.
oh yeah, yeah. But even Gibson, with his map, his reference suggestion was 40 inches. 40 inches is pretty big to try and draw as a radius. And he said that, and even at that scale, it's a pretty big piece of paper.
Yeah, you need one of those big architecture pieces of paper. What's that,
Yeah, I mean, you're better
A5 or
off.
something?
Yeah, you're better off using. They wouldn't have anything access to things like railway curves and stuff like that, which is what we. If you're designing a railway, because a railway, obviously the two lines have to be parallel. So when we're designing a road, we just design the center line and then we run everything off that. But when you're designing a railway line, the two lines have to be perfectly the same distance apart when they're going around a curve.
Yeah.
So it's a little bit more important that you get the curves correct. So back in the old days, before CAD, because the curves were so big on the plan, you'd use a thing called the railway curves, which are basically a whole lot of plastic templates with different radiuses set in. So you pick the curve that matched the radius you were trying to draw, so that you get the exact curve when you're plotting it. And that's the sort of tool they would need if they're doing it manually, to sort of try and draw something even close to scale on a piece of paper that you could manage. So they won't have access to that.
Yeah. Well, and then when building the railway, from what I remember seeing, is they had like a piece of wood or something that's cut to like the space in between, so that they could make sure that as they're going down the line, that there's no small imperfections that are adding up too much over time, because that kind of thing is how you get trains going off the tracks.
I mean, yeah, they have a calibrated measure at some point, but most of the time, nowadays, almost all the sleepers are precast with the blocks in place, so they know pretty much where the rail has to go, because all the sleepers are the same spacing, and the holes for the rails are all set in the same spot, so they can get it pretty close. They got, obviously, level is a bit of an issue, because obviously they also got to be level. It's like the same surface level across the top between the two rails, except when they get around the curve, sometimes they put a slight camber on that curve so that the rail tilts slightly, but generally not, because just the way the pressure works on that it can push in on one side more than the other. So the rail lines are a little bit more interesting. When they do the ones in the city, I don't know if you guys have seen Parramatta. So say, for example, when they did the light rail in Sydney, they've done light rail recently here in Canberra as well. Those actually have to be a little bit more accurate than the rails out in the country, because they're usually pouring concrete and road slabs around them. If they're out by 5 or 10 mil, they don't work, and the glue doesn't set, and they're getting all sorts of problems. So I know they had the same problem in Sydney, and they had this problem in Canberra, and they had to relay the track about 4 times just because they kept getting it wrong. Expensive stuff.
Oh, they've all dropped out of over there, so I can drop out of that Discord now.
They probably didn't like that you were recording them.
No, I was muted anyway, deafened, so they wouldn't. They once I do that, nothing's coming through.
That's true.
Raki has gone down to Earth Awakenings anyway. Oh, he was down there.
He's not. They're not on our YouTube, are they? Listening? Not that I mind. But
No. Oh no, they can hear
I
us
don't have
out there,
YouTube.
out in YouTube.
Yeah, I can't hear. I just don't have YouTube up, so I can't see who's there at the moment.
Oh, okay. No, there's nothing.
Yeah.
Nothing's happening over there yet.
I flick back to the computer.
I'll duck
Oh,
into
it's not
Earth
that one.
Awakenings as well. See what they're talking about for now. Then I'll play a bit of Blue Stream. His after
Yeah,
show.
I was gonna say I don't see any flat earthers in YouTube, but I mean like they could be lurking. So
Yeah. Oh, we usually they got spanners. Gary Wybanger, he drops in once in a blue moon.
Yeah.
He doesn't really talk much.
Sorry, I just had a reply on one of telling me that you can't travel past the 60th parallel to get to Antarctica.
Oh no, yeah, we can't do that. Man, they've got a video. They've got a video of a boat going down in the ocean, and it's getting pushed
They got
away.
a
told to
video.
go away. You know that video?
Yeah, they've got a video of some guys in Bass Strait.
Yeah,
fishing.
Bass Strait of all places.
And they get too close to a battleship, and the battleship says,
"Go away!
Don't go around us. Go away."
Yeah, but they use that as the one for the Antarctica one.
Yeah, and the guys are sitting. The guys are in t-shirts and shorts, and they're supposedly on the 6th.
Yeah.
And they're on the 60th parallel.
Yeah, that's it. You're too close to Antarctica.
I need to plan.
Imagine going across Bass Strait in the ship that we have going from Melbourne to Tasmania, and the Navy ship blocks it and says, "Sorry, you can't come any further."
And the thing is, they're supposedly in they're in a bit of it's a bit bigger than a tinny, but they're supposedly
little tiny boat. Yeah, it's only a small one.
To get down to that's like what I can't remember how far it is, but it's like distance from Melbourne to Brisbane.
Mm. So it's well over 1,000 kilometres.
Yeah. So it's about 1,500 kilometres or something like that.
So they've got a lot of fuel on it.
With one little tank.
Yeah.
Yeah. And I don't know, the seas, once you get down that way, are a little bit less calm than that one. So, yeah, just come on.
Yeah, I know. I thought that was a laugh, that one, when we found out that there was in Bass Strait. I thought, really?
Well, yeah, it's just, that was the guys in the fishing boat said. The guys in the boat said, what are you talking about? That's Grant.
I don't know. You have to change your name if you don't want that. We'll find out who it is in a minute.
Yeah. They're scary.
Hello?
Hello.
Hello? My mum.
Oh, okay.
Is it my mum baked cake?
It's my mum.
So we've got no thumbnail, so we've got no idea who it is.
Not your mom, my mom.
Yeah, we've got no thumbnail, so we didn't know who it was.
It's my mum bakes cakes.
Yeah. Yeah, but where's ours? You haven't been on for a while.
I didn't want to give my real name out there. So there you go.
You did before.
Sorry.
Yeah, if I'd have known it when I'd seen it, I should have waited and I put you in the other special room.
That's all right. No worries.
Special work waiting room.
I don't think it showed up on the stream. So
that's all right. No, doesn't matter. I mean, look, I was listening to the shit show with Mobius and Blue. I mean, for fuck's sake, Blue's telling him 4 fucking times the same thing over and over and over and over again, and it's like, bang, 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 bang. You still didn't get it. It's freaking ridiculous.
Yeah, we're going to be watching
and
it.
Bev still thinks Mobius won.
Yeah, we're going to be reviewing that one in a minute. A bit of that.
I mean, all these first need to do is go actually ask the surveyors who actually built the actual LIGO or Lego for Flurfs. Go and ask the people who actually built the Lake Pontchartrain Bridge how they actually built it. But that's called research. They keep telling us to do our research. We do our research, and we find every time the world is a globe.
You can't trust the people who built it because obviously they're in on it. And so, of course, they're going to lie to you. So then the next step would be measuring it yourself, but no Flurf knows how to take a measurement. So
you got to use a level. You got to have a level. What is this water level? Having one level, a water level at one point, and then have another water level at another point. And if you connect them to get together, what do you get? A level? I mean, what the heck was he on about?
Yeah, we get it. It's level all the way across, but that doesn't mean that that it doesn't curve.
Yeah, that's it. I've used water levels plenty of times for certain specific jobs that I've done, but yeah, I can't understand what they're trying to do.
And Terry, like we use a water level. We use a water level in Australia. When a person uses a water level in America, is our water level upside down?
Yeah, how do they keep the water in?
Yeah. So when we set up our water level up here, then yours pours out. But if ours is set up first and you put yours down, then ours pours out. It's a whole mess.
Yeah,
there's a lot of like talking that has to be done.
and we're still on. We're still on the debate of who's on top, because we always say we're on top.
So if I had a water level here, and I put the water level on my desk and it's level, and then I drew a straight line all the way from here to Texas, Houston, or wherever you live in America, would that be a straight line to where you are? And if it was, the distance would be a certain distance, but it'd be shorter than it would be over the curve. It doesn't make sense. I don't know.
Oh, there's so many things. First of all, yes, we should be on top because Australia and Antarctica are much older than the rest of the world. So, in theory.
Oh yeah, we never thought of that. The tectonic plate shift. Yeah, yeah, we come from. Yeah,
but secondly, secondly, in the industry, I haven't used a water level at all. 8 years surveying and nearly whatever years of road construction. Never used a water level. We haven't used one for, it's ancient technology. We don't even consider it.
Well, I found it was the easiest thing to use to do roller doors and tilter doors to get them level.
Yeah, you did. I understand what you're just saying.
Yeah, that's what I used. That's all I did.
Industry point of view. From a construction industry, road design, we never. Why would we use a water level? If you're doing 5 kilometers of road, what use is a water level?
And the other job I did with it is I went from the garage slab to the house, because we're on a slight slope over the other house, and I wanted to know how high up at the house, because I was building a veranda and a ramp and cementing that area there, and I wanted to I was figuring out what drop I was going to have for the slab, so yeah, it come in handy.
Now was that the guy who's talking about the roads there? You're saying, in Australia we have timber. Timber. Yeah. In Australia we have curved roads for the water to run off. I mean, here's proof of the globe on our roads. It's curved.
Yeah,
we have those curved roads in America too. So that's.
Are you sure?
Yeah, bank corners too.
No, no. No, in America they flatten out the roads, relatively speaking. No, you're right. You still have curved roads, but it's when I started, we did a lot of subdivision work, and we compared our work to what goes on. There's a lot more. Let's make things nice, flat, and level out in the US than there is in Australia. We don't get this.
Well, it also depends on where you're at, how much rain they get, and other factors too. That because America, like Australia, is a big place, so it's not all the same weather everywhere.
Is it the same distance from coast to coast as Australia? Because Australia here is a lot bigger on the planet Earth.
It's similar, but there's a lot more topography in America than is here. So if you looked at America, about so if you started from the east and going west, about 2/3 is almost flat, and then it gets really hilly for the next.
Australia's wider on a flat Earth. You know that, right?
Yeah, 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 yeah.
Oh yeah. You have a look at my video.
You guys
and
get
can see
stretched
that
out
one.
like a hot dog.
That's it.
Have you seen my video on the flat Earth? On Australia,
We've
if you
been
look
going
on-
through your video, so I don't know if we've watched that one yet, or have we?
Yeah, show them that one. The one on the Australia, how a flat Earth is hate Australia. Yeah. That covers that one.
I think I saw
While
that.
I'm
yes.
looking for that,
Yeah.
I'll play
And,
a bit of, which one was it?
So on the Gibson map, it's about I think it's twice as wide as it should be, roughly.
Is that the
little bit
Mel
more,
Gibson
maybe.
map?
The Mel Gibson map, yeah, that's
No.
it.
Yeah, different Gibson, Alex Gibson.
Well, see, we've got the technology to change the odometers on our vehicles from travelling north to south to east to west.
Must do.
Yeah, as soon as
Must
it
do.
orientates
Yeah.
to north, it
Took it-
reduces, and then when we go travel
It's-
east to west,
it's
it expands and draws out the
It's
distance.
an anti Coriolis effect. Yes.
Yeah, but somehow it does it.
They
It's
change.
built into the speedo.
Terry,
But
did you
the
say that
only thing- but
Morbius
the
was
only thing's
Australian?
Time.
Sorry.
But the only thing is the time. That's the only thing I can't work out. How it changes time. Anyway, sorry, I digress.
Yeah, that's right.
Yeah. Did you say that Morbius was Australian?
No, that Mobius bloke's not Australian.
Oh, sorry. Oh, that's good to hear. we have enough with Mitchell of Australia. I mean, he's bad enough.
Oh, that
Yeah.
Mitchell of Australia cakes. Did you hear that was just round the corner from me, the science place where Mitchell went to.
Yeah. Mm-hmm.
So I'm waiting to hear from if he ever goes to do that again. I'll see if I can
He
get
won't
it.
do
I
that
think
again. He won't do that
I
again.
don't
There's a
think he
chicken.
actually believe. I don't believe he actually thinks the Earth is flat. I think he just worked out that he could get more money if he hooked on to those other guys. Because I pointed out, even from his very first video, he talks in miles and feet and all American.
Yeah, miles and feet.
And
We don't
only
talk in
Australian.
miles
No,
and feet.
Australian. If you're Australian, you would not have even.
You wouldn't have
you would been
mentioned it.
talking.
Yeah, so he's actually parodying
would've been-
something that he's heard.
No, he's saying it to cater for that audience.
Ah,
So-
okay, that too. Yeah.
So and that's what I reckon anyway, and that he doesn't actually believe it. He just knows that I get better YouTube money if I go down this track. Maybe.
See, I've even got another hypothesis that he went to that museum, found out that was only a static display, and it wasn't actually a real functioning one because the height of the pendulum wasn't high enough, for what we've seen.
Yeah.
And then he's mentioned that to him, and then I don't know why they've stopped the display there. That's what I can't work out. Why would they have?
Well, they realised that. Well, they stopped it because it wasn't working. It wasn't doing what I thought
What it's supposed
what
to.
it was meant to do.
Yeah. But
Yeah,
it wasn't.
so my
It wasn't
understanding
meant
is
to
the
do
kicker,
that.
'cause-
It was only just for a kid's display to show them what it is.
I think it was meant to turn. That's why they have the little dominoes on it, so that as it turns, it knocks the dominoes on.
Mm.
But the kicker, which is because there's no way you're going to get a pendulum to be perpetually swinging,
Not that.
so it
sharp.
has to have a kicker at the top.
Mm.
Yeah, it's a little kicker up in the top of the string to make it keep moving.
Yeah.
And I believe the kicker broke or malfunctioned because obviously if it's wrong, it's going to.
But what mechanism would they
interfere
use
with the?
that's not actually a contact one that would affect it? It'll have to be like a magnet, wouldn't
I'm
it?
not.
Like a repelling magnet.
I'm not sure. I think there's different.
Hmm.
I'm not sure what they is.
Yeah.
There are different. If you look into it, there are different kickers and different music. I don't know what they were using. I have no idea. But
Yeah.
it's called. I know it's called a kicker.
Yeah.
Because basically it just gives it a little bit of a push.
I still
but
can't
I'm
understand
not
why
sure.
it costs $150 to get in there because I can go to university
Oh,
in the
no,
city where
it
I live
doesn't.
No, that
and it's
wasn't-
free, you know.
No, what it was is it
No.
was like a family deal. If you like a parent and a
Ah, I
child,
see.
it was,
It was-
$20,
it was-
$30.
It was meant to be petrol, food,
Yeah,
the kids getting in,
his time,
and
his time.
his time. Yeah. So I think all up, I looked at it. I think yeah, it's probably only costing him about $60 to $80, depending what he eats. And
Oh, we can go on their website and have a look at their admission fees.
yeah, that's. I had a look. That's why I know that the price was. So,
Yeah.
but I think the funny thing is, on the second time around, he didn't actually go in. So he didn't actually pay for the tickets on the second time. So
Oh, the one where you
He
can
must
see
have
him
gone
on the
in because
outside. Because the second one he was on the outside filming himself.
no, he
Yeah,
took
that's
a
right.
picture of the actual poster that was posted on the display saying this pendulum is out of action.
Yeah, I've seen
but it's
that.
still
No, he
proof.
had
That they, you know.
I think he had a picture. I don't think he
Oh.
personally took it.
Okay.
But I could be wrong.
Yeah.
Because he didn't bother filming inside. Because why would you go in and take a picture and not film?
Yeah.
So that's what I found a bit that I don't think he actually went in. And
Yeah,
that's
you
why he
wouldn't have
filmed
gone
on the
paid to
outside,
get
so
in and
What-
see it.
You must have
But
got to pay for what? Yeah.
But even the picture he took of the actual poster, which said the machine's not operating, even that said that it's a curved Earth. So every time a Earth demonstrates anything to prove they're flat Earth, they prove the globe every time.
It's a bit hard not to.
We'll do a bit of another jump to another server. We'll see what they're saying over here.
Design is huge. I envision this being on like the inside of a whole room at best, or being like the exterior of your house or something like that big. Like this is like a big. This isn't going to fit in your car or anything.
Okay.
People always want to make that circle, so because the circle ones, you can put that in a car and a cell phone. You can put that circle one anywhere. It's easy. It's small. But it's not
Give you
easy.
another thing to think about, Jeremy. If you get it working, then you got to think about torque, getting power out of it. It's a whole different thing.
That's easy. That's the easy part. Yo, you get this thing going up and down these hills nonstop, getting the power out of it's the easy part. You could do something as simple as putting a turbine up. You're talking about magnets on the thing. You could put some copper wires on the downward part. There's all kinds of ways.
What are they talking about?
Don't know yet. I'm just trying to pick up on
First
that.
thing you got to do is just get it to go up and down the ramps nonstop.
Yeah.
And I mean, you would have to get it to go up high enough so that it had enough force to go back into the ramp, the next ramp, and get the electricity out of it. Yeah, so.
Are they talking some sort of experiment?
It's one thing to get it rolling smoothly, but then to apply force friction on it, that's a whole different ball of wax there.
Like some sort of.
Yeah, that's why you do get the power when it's going down, right? When it's falling. And that downward kind of curve thing we got. You do just put a little turbine and make something move, and just a little bit of tension. That's why you got to make it go up high enough so that it can hit a turbine or generate a little bit of electricity, and still have enough momentum or power or force or whatever to get into the next track that's going to lead upwards when it gets down to the bottom of that ramp.
Just a little turbine.
No, I still haven't figured out what they're talking about yet.
There's only one way. Make it to
It's
scale if you can and see. Talking about it, it's hard to judge where the snags are going to be, where the,
Yeah, it sounds like some sort of cart that's going up and down hills and generating some sort of power, but the amount of power that you're going to generate is less than. So it sounds like they're just trying to generate enough to make
I
it
spent
back up the
hours trying
hill
to
of
get that
equal
thing
height.
going, and no chance. Same problem.
Well, yeah, that's basic physics. That's why the first drop on a roller coaster is the highest.
Have you ever tried it, Jeremy?
Gravity.
Your perpetual motion, possibly.
Been some damage to the
Or
Oh, those screen protectors work good. Nice. Yeah, I tried it before. I couldn't get it. You need some kind of engineering, architectural skills.
No, but you know the snag that I'm talking about, right?
You need skills, and SC doesn't have any.
In the rotary one, you understand what I'm talking about? That it comes to a point where they just attract each other and stop.
Yeah, Ryan, exactly. Weren't we going to watch some of Blue?
Other way.
I know it was Blue with a side of derp, but at least Blue helps, make the derp go down easy.
Well, at least it's better. At least it's a lot better than anything that Lindsay has to say or anything that Mobius has to say. I tell you.
Yeah. Oh, yeah. Way better.
I mean, Lindsay's hilarious, but Mobius, oh, for fuck's sake, I tell you, it's amazing. The derp. Man, well, only reason we like listen to flat earthers is to make us laugh because they're so stupid.
That's true.
Here we go. Lego for FE dummies. What they're going to go there? What Flip's going to go there and actually do a measurement of some kind? At one point.
Blue mentioned something like that. I don't think there's any chance that LIGO's going to let him near the tubes.
Isn't there another one somewhere? I've heard. There's two.
There's two.
Yeah.
Yeah,
there's two.
There's two LIGOs.
Yeah.
That's kind of how they work, is so that they're on opposite side. Well, pretty close to opposite sides of the Earth, from what I understand, and so that they can get kind of different detection. Are they both in America? I thought there was another one.
I could be wrong. I could be wrong, but I'm pretty sure when I looked into it, there's two. Hang on.
You're thinking of CERN?
No, well, there's CERN, but I'm not thinking CERN. I thought there was another LIGO in well, I guess that wouldn't be the other side of the Earth, but still like Europe or somewhere like that.
It wouldn't be called. I don't think it's called LIGO. There's the same. Another. No, but LIGO has two sites, I believe. LIGO being the Laser Interferometer Gravitational Wave Observatory, and I only know that because I've got it on the screen in front of me.
Another gravitational wave observatory, though, not necessarily LIGO.
But it's got the word gravitation in it. Does that mean it's got gravity in it? Another question is, if there's two LIGOs and you connect the two together with a straight line, is it level or is it straight? Or is it flat?
No,
it's horizontal.
So where are we? Sorry.
Oh, there's one in Washington and one in LA. Okay.
Yeah,
I could have sworn there was another observatory that does a similar.
I'm sure there is.
But it's somewhere else.
Probably not called LIGO.
Jared's on the ball out there.
Yeah, he generally is.
WA and LA. What's WA?
Oh, Washington.
Washington.
Oh, yeah, the state. Not so they're both on the West Coast. So one's in somewhere in Washington, and the other one is in LA, California. So I think the one in Washington is no. They're both West Coast, but it's one's northern, one's southern.
Is Washington State on the West Coast?
Yeah, northwest.
Oh,
northwest coast.
For some reason, I always thought Washington State was on the other side.
Yeah, I know.
You're probably thinking Washington DC.
DC, yeah.
Yeah, I know Washington DC is, but for some reason, I just had that it was somewhere over that way.
But, do you want me to get
Google? WA here.
Do you want me to get Google Earth out for you?
There we go. There he's got it.
That.
There are detectors in Italy. That's probably the one that I'm thinking of.
Oh, okay.
So still not. Louisiana, not
LA.
Okay.
Wouldn't that be LO
that's
for short?
You would think. Apparently, it's LA. I did not realize that.
Or what's short
If
for
you-
Los Angeles then?
LA.
Hello.
LA.
I used to
I-
say
I guess-
WA.
I guess it makes sense in context though, because we were talking states and not cities.
Yeah, but use Americans
Yeah.
have a problem with everything like Arkansas and places like that.
I don't know what you're talking about.
Yeah, why do you got a Kansas
Yeah.
and an Arkansas?
Taking Indian names. Yeah, white people taking different tribe Indian names. That's
like
the short explanation.
Terry, it's like how we use the Aboriginal name for Western Australia.
Do we?
Western Australia, that's Western Australia.
You've got Western Australia, South Australia, Northern Territory because it's a territory in the north. And then we've got a Queensland.
And you do get
why is Queensland?
Queensland,
Why
New South
is it
Wales.
Queensland?
Why isn't it
Because
Northern Australia?
Yeah, it should be North Australia.
Northern
yeah.
Territory.
Yeah, Northern Territory.
That's Northern Territory because it's not a state.
Yeah.
Why
isn't it not a state?
Then we've got Wales.
Same as
that's the new one, the South Wales.
New South Wales.
Yeah, South Wales.
Yeah, South Wales.
It's Wales, but it's South and it's new.
So it's New South Wales.
Yeah.
No, but they named New South Wales because it looked like South Wales. Well, Sydney did, but then they got more than a few kilometres away and realised it didn't look anything like.
Yeah, they went into the wrong bay, didn't they? And they went, oh no, this is no good.
Yeah.
We'll try another one. Oh, this one looks better.
And we've got Tasmania.
Yeah, I don't know how that came about.
Yeah, that's
still like the dag on the end of
Tasmania.
the sheet.
Well, the Tasmania is actually the Van Diemen's Land was what it was called first, and then they decided to call it Tasmania instead.
Oh, okay. This is
comes...
a one for the Americans. How did Melbourne get its name? Keep mute. Yeah, think about it.
Named Melbourne. I have no idea.
If you think about it, that's an actual name.
Yeah.
So is it the first person that landed there?
It's to do with a person.
Well, sort of, yeah. Not he didn't personally land there, no.
No.
Was it a king or something?
No.
I have no idea.
I know that, and the name of it was before that. It escapes my memory all the time because it was a name before.
Oh, Melbourne. Before it was Melbourne.
Yeah.
Yeah, it had another colony name. I can't remember that one. Sorry.
Yeah.
But you better put them out of their misery. They won't guess it, I'm afraid. Tell
Mel Gibson was born there.
Nah.
Lord Melbourne.
Okay, but who is Lord Melbourne?
He was a lord.
Well,
He was a lord.
Yeah.
I think he was in charge of the Admiralty at the time. But anyway.
Oh, okay. I mean, just saying that it's Lord Melbourne. Okay, yeah, we figured out that it was a person, and obviously he's going to be somebody important. But what made him important?
Well, look, we're being a flirt. You got to do your own research.
Yeah.
Okay, fine.
I got to admit, I was thinking, Terry, that was a bit rough. I was trying to work out where you were heading. I don't think they would have any clue. Do they know what the capital of Australia is? That's a good one.
Oh yeah, they always don't know that one.
It's Sydney. Sydney.
It's
Sydney.
I was going to say, I know it's not Sydney. Not off the top of my head. I want to say
it's where I'm living at the moment. It's where I'm living.
It's in the middle of
It's
New
where I'm
South
living,
Wales.
and
I probably will have no clue then.
it's halfway between Sydney and Melbourne.
Yeah.
There you go. Roughly halfway between Sydney and Melbourne.
Do you want me to get Google Maps out again?
Sure. Hey, look, we can get AT2 and a few other Americans in here, and we can do this in reverse and
Oh,
start
yeah.
picking
Well,
out random places in America.
Yeah, it'll be war. There we go.
Yeah, except I think we know the capital of America.
Yes.
You might know our capital, but do you know the capital of every state?
We probably know more than the capitals of our states.
That's granted, since I know 0.
And since you got 50 of them, and I could probably name maybe 5, so that gives me a good,
Yeah.
What's that? 1%, 10%. So, no. So our capital city is halfway between Sydney and Melbourne, because obviously when they were going to position the capital, Sydney and Melbourne were both arguing over who wanted to be capital.
Fighting over it. Yeah. No,
so
we
they
want it. No, you have it. No. Old Buggy is. We'll figure this out. Threw a dart at the map and went right in the middle.
They picked this spot. Yeah, well, close to, not quite a dart. It was about
They used the Flurf map to place it.
Yeah. And Terry, we have a coast. Did you know we have in the ACT?
A coast? What sort of coast?
Yeah. That Jarvis Bay is part of the ACT.
I did not know that. I'll get rid of those stupid lines.
So Jarvis Bay is on the coast, but because our capital's inland, and it was placed inland so that the French couldn't attack us. But because it had to have a coastal port, so we have a little tiny bit of
down
coast,
here,
which is a part of it. Yeah, Jarvis Bay. Yeah.
Oh, that's Bateman's.
We also do have
okay, so it's not connected. They just claimed that coast.
There's Bateman's Bay.
It's
Where's
part
Jarvis
of.
Bay?
It's not part of New South Wales. North of Bateman's Bay.
Not Huskisson?
I think it's south of Huskisson. I'll have to pull up a map. Hang on.
Yeah, I'm on the map now. I'm sharing.
South of Huskisson. No, obviously I'm not looking because I'm working.
Oh, you're not looking.
I'm trying to.
Okay.
Yeah, there's Jarvis Bay. Yes, zoom in again. Back up where you were. Below Narrow. See the boundary line on that coast? See the white boundary
the white
cuts
bit,
off that peninsula there? Yeah, that's Jervis Bay. If you zoom in, you'll see it says Jervis Bay. Eventually, there you go. That is part of the ACT.
There we go, Jervis Bay.
White is the boundary. So that white line to the bottom of the screen.
Yeah, I can see that.
Is the boundary. Yeah.
Wow. I never knew that.
Right.
Yeah.
But Canberra's all the way over here.
Yeah. So that's our capital. And
Canberra.
the city is pretty much just up in the very top, tucked up in the top corner.
Top corner up here, yeah.
And and then the rest is mostly national park. But it's great lake, man-made lake, Lake Burley Griffin.
Lake Burley Griffin.
Well, there's a
Somebody
LIGO in
actually lives
India.
there.
Thanks, Rodent.
And that's right in the center, of course, is the Parliament House.
Yeah, we've seen that. You can see that down there.
Yes. When you zoom in.
Where is it?
That big circle to the right. Right, that big building is the Parliament House.
I think
on Capitol Hill, funny enough.
That's the old one there.
You're in Pro. If you dump onto Street View, you can get a 3D view of that. So.
See, Terry's using the Google Maps, which is the favorite flat Earth tool.
No, he's using Google Earth.
Google Earth, sorry.
Close enough. No, so if you dump the little man, Terry, grab your little man and drop him anywhere in there, you'll actually exit Street View. And you'll see that's actually three-dimensional. If you pan around, you'll see all the trees are in there and everything. So
now, how come there is no flat Earth Google map?
Well, there is. They
There is?
claim this as their Google is flat.
Oh.
Well, first they would have to have a map that they all agree on,
Yeah.
which
Oh,
Well,
yeah.
I forget who it was. Was it wasn't Whitsett? It was one of the guys said that the flat Google is the flat Earth map, and people pointed out that it's a globe, and they said no, that's just how it's presented. That they project the flat map onto a globe,
of course.
and then you say, but that doesn't work.
Wagga Wagga would have been more funnier than for a capital.
Wagga Wagga.
Yeah, Wagga Wagga. Yeah.
Actually, there was a site over near Wagga Wagga. You know what Wagga Wagga stands for, don't you?
Nah.
Oh.
Wagga, in Aboriginal language, or at least that one, anything which is duplicated is a plural. So Wagga stands for crows. So that means place of many crows.
Oh, okay.
There you go.
Well, you know how
So
kangaroo.
any-
You know how
Just
time you see
explain it
an
and
Aboriginal
ruin all the fun.
Yeah, and you know kangaroo is
So
not.
that's it.
Anytime you
You know kangaroo's not a kangaroo.
kangaroo,
Yeah.
yeah. The myth is, and it's a myth, is that it actually means, isn't it something along the line of I don't know?
Yes, that was it.
That
Yeah.
they
Yeah, or
asked
I
them-
don't understand
they
you or
pointed-
something
Yeah,
like
yeah,
that. Yeah.
and they just repeated it, but it doesn't actually mean that. But no, kangaroo has different. Aboriginals call it kangaroo differently in different parts. There's some, I forget how many Aboriginal tribes there is, or would it be? There's not as many now. But,
Oh, murder. There's a murder of crows.
Yeah. Yeah.
Yeah,
Wagga
better
Wagga
yeah,
Wagga Wagga is a murder.
that's a plural.
Mm.
Yeah, that's right. Group of crows.
We're learning a lot today.
Yes.
Where were we?
You were going to show us a debate, I think.
All right,
Yeah, let's play, Derry. Let's play.
Yeah.
We
Okay, here
keep
we
going
go.
down sidetracks.
Yeah, here's Lindsay. I mean, sorry, not Lindsay.
Oh God, not Lindsay.
No, not Lindsay.
Though that might be better.
I'll play it from the start where he first introduces him and gets the conversation going. I think we've got all the things pressed so they can hear it out there.
Hello, everybody.
Oh, blue's a bit soft. So
Welcome
I
to Blue Marble. Just me and
Blue sounds
Mobius. But now going back to what we're talking about, yes, when I was practicing up or trying to figure out how to do live streams, honestly, because I never had done one. That particular day, Bev had a stream going on, and I put out a little bit of it, not much, for no reason really. And Bev.
Oh, I thought it's happened.
And Bev got very, very upset with me for doing that. And I have never done it again, and I wouldn't. But I see today he's planning on live streaming my YouTube live stream, exactly the thing he complained about. So if that's
No, he didn't say he was planning on it. This is me asking you if that would be cool, but he said that he wouldn't be, probably wouldn't be able to. It would be pointless to ask you. And I told him, well, I just want to ask just so that I know, It had nothing to do with Bev. He wasn't asking me anything to do anything or ask you anything.
Yeah,
that was all on me.
Okay, yeah. He put an announcement up. That's all I know. That's what I saw. It came through on my announcements.
Well,
but whatever. That's not a problem.
All right.
I'm okay with that.
So anyway, what did you want to talk about with LIGO? Like, what specifically did you have? Anything particular? Or?
Well, I think this started so long ago, Mobius.
Yeah.
As I recall, you're the one that wanted to do the talking about LIGO and why I've been wrong about it. And
well,
I was
What
hoping
do you
maybe you
think?
could help me out here.
What do you think I'm saying you're wrong about? Because I don't remember ever saying that you're wrong about anything.
Well, I think I've shown, at least in one video, that the shape of the pads that the beam tubes sit on are not straight lines in free space.
All right, so
they're curved.
So I know, is, in your opinion, or do you know if the tubes are straight?
Yeah, as far as I know, they are advertised as being perfectly straight.
All
Of the straightest things we know of. Now, people exaggerate to a bit at times and say, "Oh, they're the straightest thing in the universe." Well, I never heard anybody actually say that, but they are and have been measured to be very, very straight. Yes.
And then so I assume your opinion is that the laser that's being used in LIGO is shooting straight, right?
Yeah, I don't think it has any choice because LIGO is operating at about a 10 to the minus ninth vacuum, so there's no atmosphere in there to cause any refraction.
And just for shits and giggles, does gravity have an effect on light in a vacuum?
Well, gravity has an effect on everything.
John would have to correct us on that urban myth.
Far too small to have any.
We like the urban myth better, John.
So you're saying that there would be no deviation. This is just the side point. I'm just asking questions. Are you saying that there would be no side or downward pull on a light in a vacuum?
Yes, but very slight.
Certainly nothing that.
The photons, the amount of photons in that light, gravity would barely affect it at all, if not none.
Yeah. I mean it would have an effect, but it would be so slight that like that and they'd be able to tell like that, okay, a normal when normally shooting it down, it's always hitting this point that is whatever, fraction of a millimeter, whatever off. So
but it wouldn't affect when they shoot it. It still wouldn't affect its distance because of the minuscule amount that it's doing it.
Yeah.
And I don't even know the structure, not the structure, the topography or the what do they call it underneath the ground?
Like the material composition or whatever.
Yeah, the ground underneath
like if there's a bunch of iron and stuff like that.
Or whatever, what's underneath the surface to affect gravity. Because you know how, like the Chaldean experiment, where they used a big mountain to show how gravity is affected by mass.
Yeah. I mean, I'm pretty sure that they picked a location that it's going to be fairly constant beneath it because, of the accuracy of the measurements.
That's what I said, Jared. Jeez. Repeating what I said.
Yeah, exactly. Yeah. I think that's the point that we're all trying to get to. Is that
measuring now.
Well, I mean, LIGO is supposed to be measuring to within like 1/50th of the width of a proton.
Bit bigger than
that. I'm sorry, 1/50,000th of the width of a proton. Something ridiculous.
Oh,
right?
Space Matt. Yeah. What are you doing up this time?
So you're saying that device wouldn't be able to
if
measure
you're awake, you can drop
a deviation from straight from like with the effect of gravity on light in a vacuum?
Well,
I think their documents
are
even
okay.
say something
You're just
about
saying it out loud.
Something like that, but whatever. Like I said, that's beside the point.
Well, what it's measuring is the length of those tubes, right?
Yeah.
Not the height of the beam. It's measuring the length of the tube.
Right, and the mirrors go back and forth to adjust.
Drop in for a minute.
Harmonics, right? The frequencies to make sure that they're able to capture, and it's a complicated system. I mean, it's pretty complex. Yeah.
Very complex, and I don't pretend at all
to be
that's all right. An expert on that interferometer.
You'd probably wake
I
other
understand
people
the
up if
basics
you were
of it.
talking.
It's a Michelson interferometer, period. You know.
Right.
But it's measuring it's literally measuring a differential in the lengths of those two tubes.
There we
If you're
go. If
right
a beam of
angles to each
light
other.
were to pass right over
So
a
any
So are you-
surface,
gravitational
it
wave
would
that
be
comes
bent
through
by
is going to affect one of them,
point
and not the
zero
other one
zero
in terms of
zero
its length.
6 arc seconds.
But I mean, the thing does
Exactly.
detect like, or it's alleged that it detects, minute vibrations like miles
Yeah, but that's
away.
with
right?
atmosphere, John. This is
Oh, it's
in a
possible that it
vacuum.
can, yeah, which is why they've got two of these things.
I mean, they say that it detects like a crow walking on the concrete enclosure.
I'm sure that's written down someplace or the other, Mobius.
They
And
detect
it
the one-way
probably
speed of light yet?
would have the sensitivity to do a thing like that.
No.
But the reason
Oh,
No,
yeah,
we
that,
don't.
yeah,
We
I
don't
heard
have
that
the
one.
one-way speed of light.
And separated by a fair distance is so they can rule out these anomalies that are caused by, the truck going down the highway or the crow jumping.
What's
down
that
on the
in
sidewalk
squee
or whatever.
moils?
Because now you're in a situation where you've got to have an equal crow jumping up and down in sync, at both locations, and that's pretty far fetched. So that's how they're able to sort out an actual gravitational wave from just noise that's inherent in any kind of measuring system.
Yeah. And I mean, you got to admit though that a broken clock is right twice a day. So
What? I've got
No,
no idea
it's
what
not
that
like it's
analogy. What analogy
unfounded
means.
or unheard of that things can happen simultaneously that would give the impression of something, right? Especially when you're looking so closely for that thing that you're detecting.
Yeah, that's true. Absolutely. True that all of those things probably
Possible,
have
but
to be
not
considered, and I'm
likely.
sure have been considered. But
Yeah. So
I'll
just
leave
so
that-
we're clear, like within this conversation, I'm not trying to debate you on what LIGO does or what it accomplishes or what it's meant for or anything like that. It's like my whole thing that I wanted to talk to you about is the geometry of the structure, the whatever. If it does what it says it does, great, whatever. But that's not what we're talking about.
Exactly.
That's not my okay. So like all the technical stuff, and I mean it's interesting, but as far as like how many mirrors, they're pendulums, right? They're pendular mirrors.
Yeah, it's a fairly complicated pendulum arrangement. It's actually four pendulums in series.
Yeah, I'm quite aware.
Yeah.
Yeah, the quad as they refer to it.
Right.
Are you aware of the strands, the fused silica strands that they use to support those things?
Oh yeah, that's amazing. That is amazing stuff. Well, and they do that because it's got a very favorable, very, very low coefficient of thermal expansion.
Right. And the harmonics, it doesn't what do they call it, violin, like it doesn't resonate. Right. Also, I mean, the tensile strength of that stuff is like extremely strong, but the side strain of it, which, any kind of like side to side motion, or if you were to angle, put any bending strain on those things, I mean, they're super fragile. It's like a piece of glass, like,
well, it is glass.
Well, I know, but I mean, it's a piece. Okay, it's a piece of glass. It's thinner than like a half of a human hair or something like that, right?
Yeah. Yeah, and in certain directions, glass is extremely strong. If you keep it in tension, pure tension, or you keep it in pure compression, it's very strong.
Right. So my point,
it doesn't take any shear load.
My question is, or my point, or whatever, my quandary is that these things are hanging, so the tensile strength will be sufficient, but the side to side or any bending of that that silica glass, it's not gonna hold up.
Right. Yeah, I doubt you could even touch one of those things without having it break.
Yeah. Well, I mean, I've seen documentaries and stuff where they do touch them, but it's not with any like strain on them. They're just kind of like loosely laid in somebody's hand just to show you the thinness of it, I guess.
Yeah, I'm thinking about with a mirror actually hanging from four of those strands. I wouldn't dare touch one of them.
Right.
If it's loaded, I would not touch it. I think you could cause it to fail very, very quickly. But again, all of that's quite interesting, but that's not what we're really talking about, right?
Well, I mean, the fact that it's a pendulum, I mean, you don't see that is problematic.
In terms of the shape of the machine, no, I don't. Why would it be?
Well, if over 4 kilometers,
Princeton Rupert
and
drops
also the mid station,
I've seen them,
that has mirrors where they have the fibro, I might be saying that wrong, the cavity where they bounce the laser back and forth before it returns to the source and then splits to the
yeah, you're talking about all that stuff there at the vertex, right?
No, this is at the end of the arms. It bounces back and forth and then it comes back.
Oh, you're probably aware of details about this thing. I don't even know. I haven't studied all
talking
of
about
that.
the mirror assembly.
Rupert drops are awesome.
All right. Well, I mean, it's not just
I've seen
the
a few of
splitter and 2 mirrors. It's
I know that.
You've seen the one where they put it in resin?
Yeah, there's a lot of mirrors and
get
a lot of equipment inside.
Yeah, yeah.
That was a good one.
So over 4 kilometers, if there's 2 mirrors facing each other and they're on pendulums, bless you, and they're bouncing a laser back and forth between the 2, there can't be any deflection, right?
Yeah, well, I have to say I don't know whether to agree or disagree with that because I'm not pretending to be an expert on that interferometer and all the inner workings of it.
Okay.
The actual laser itself, we went,
in the shape of that,
wasn't really the argument
of that tube and the concrete pad it sits on.
in the beginning.
Okay,
Yeah,
geometrically,
he stated
like
that,
the-
and then he
the
keeps
mirrors would
talking
have to
about
be
the device.
perpendicular to that straight laser.
It's the structure of
Yeah, they'd have to be
the actual
perpendicular to the
LIGO
axis of that tube.
itself that's what was in contention.
And then
Over
so
a
the
curved
tube
surface.
itself, you said is straight. Now the concrete pad, are you saying that the concrete pad is straight also?
Yes, in reality,
Slightly.
the concrete pad is
Slightly.
straight also.
There were minor
So
adjustments.
They don't have any adjusters on.
Yeah, there was minor adjustments made to each individual pylon to get it as straight as possible. That was after they put the pylons in and everything and laid the tubes on it. Then they had to adjust it.
Well, yeah, well, and you've got to account for things like that because obviously you have tectonic movement and earthquakes and whatever different things that are going to cause shifts in the ground and whatnot over time. So you want to keep it perfectly straight. So you're not going to just like set it and leave it.
Yeah, they had to settle and everything had to dry, and once all that was done, it could have been out by 0.5 mil or whatever.
Yeah.
On the sections of tube to lift it up or down or tilt it up or down.
Oh,
Yeah, I've got images of those pylon adjustments things
allowed
somewhere here.
So that they could calibrate it and force it to be perfectly straight. Oh yeah, that's
the
all
tube,
inclusive,
right?
Yeah, that's all inclusive in there. Sure.
All right, because the LIGO as-builts that we've discussed before, that is the concrete slab, right? Not the tube itself.
That's the concrete slab, exactly.
All right.
Exactly.
And the tube can be adjusted up or down from that concrete slab.
Yeah,
Okay.
that would be possible, and I know where you're going with that.
Okay.
Yes, it would be possible that you could pour a level slab out there and put a straight tube on top of it, and then just take up the change with a bunch of adjusters. But that's not what they did. They built the concrete slab to be straight, not level.
Well, how do you know that?
Well, by looking at the elevation data. The elevation data shows it.
So when they poured the concrete,
Mhm.
like you've done construction before, right?
Yeah.
Like the steps involved and stuff. And I know Effie Dogma talks about his vast experience in construction and stuff too, but they move dirt before they lay any concrete, right? Especially if it's got like tons of reinforcement steel in it.
Oh yeah, of course they do. Yeah.
Right.
There's a whole lot of steps that you go through.
So when when they were measuring out this area to be straight, what's your take on how they did it?
Oh no, yes, this is still here.
What on how they
put the two
physically?
You mumbled? Did I hear somebody mumble?
Sorry, mate. That was my wife had come in. I forgot that I was on mic.
That's okay. If you want to interject, just blurt something out, and I'll pause it or whatever.
Yeah, sorry about
did
that.
That's
like
all right.
how they started, yeah, like the physical, like the guys on the ground, like the guys in the field doing the work.
Oh, there's a multitude of steps that they would have to go through. Quite obviously.
No, I mean like the first step. What do you think that?
Well, they would have surveyed it
that
first.
Well, the first step was to survey that site and find out where all the elevations are.
Well, how did I guess that before Blue said it?
Right.
You have to start with that, and then set an elevation
I could nearly answer his questions for Blue.
benchmark that you're going to use, that you're going to work off of, and and just go from there. It's a series of steps, all involving surveyors, right? Because they're going to have to give you grade elevations all along the length of that tube as they work through the process of either
And I do have
cutting
that.
down the hills, which they did a lot of at Hanford, or building up areas, and that gets even more complicated because now you've got fill dirt and you're going to have to take lots of steps to compact that properly.
Yeah,
so
I mean, I haven't
settle, you know.
Admittedly, I didn't do a whole lot of research on the Hanford facility because, well, frankly,
Shocking
I
surprise.
read somewhere that they pretty much did a different method. They used a different method for establishing their straight lines in the Louisiana facility versus the Hanford.
I mean, the terrain's different, so
there were some
that could make
differences
sense.
in the way the two sites were handled, I think. But
did he say?
There's also administration changes too during that whole thing.
Or-
But whatever, that might be.
Oh, I
part
can
of it.
actually.
I don't
well,
know.
yeah, it went on for a long time, didn't
Where
it?
is it?
Yeah.
I mean, I think from the inception of
Did he
it,
actually say
which is
Freemasons?
kind of a funny story. It was almost misleading.
Oh. I need to rewind it a
Sorry,
bit.
did he? No, you're right. Did he actually say Freemasons have a different method? Was that he said? Masons have a
No,
different
I
method?
think he said the Louisiana one versus the other one used a different method for getting.
No, but I'm sure that I thought he said in his thing that the Masons used a different method, and I'm saying what? And then he went on to say in the Louisiana one. No, he didn't say that. It was just I misheard. Okay,
Yeah.
that's right.
That's not the way I heard it, but I mean, I could be wrong. I wouldn't be surprised.
Okay, Terry, we've got to go back about.
Yeah, I'm going
30
back.
seconds.
Yeah, I've got to go back just to resolve this. There we go. Have a listen.
Fill dirt, and you're going to have to take lots of steps to compact that properly.
Yeah,
So that
I mean,
the
I
stuff doesn't
haven't.
settle, you know.
Admittedly, I didn't do a whole lot of research on the Hanford facility because, well, frankly, I heard or I read somewhere that they pretty much did a different method. They used a different method for establishing their straight lines in the Louisiana facility versus the Hanford.
I think
I'm not sure.
right.
There were some differences in the way the two sites were handled, I think, but
there's
at
also
the end-
administration changes too during that whole thing. But whatever, that might be part of it.
What's
I
that
don't
well,
know.
yeah, it went on for a long time, didn't it?
Yeah.
I mean, I think from the inception of it, which that's kind of a funny story. It was almost misleading the way they went about doing it.
So I mean, if they're not too terribly different, you know, my research, I guess, was more based on the Louisiana facility. So if you know, if you bring up the Hanford as far as like any kind of like specific differences, you know, feel free. But I might not be as familiar.
Well, I don't know if anything in terms of the end result is significant. I think they did some different. I've seen reference to minor differences in the way they mounted the GPS antennas and stuff like that from one site to the other. But some of that was just going through the learning curve on whichever one they did first. I don't remember which one it was. One was in front of the other one, you know. So when you learn something that it's going to work better, yeah, you're going to do differently at the other site. That happens.
But both sites have the concrete slab, and then they've got the tube that
Yep.
is adjustable on top of it, right?
Yeah, right.
Okay. And so you're saying that the concrete is a straight line, and that's based on the as-built drawings?
Yeah, based on what the as-built show you.
So when they laid the concrete, how, like from a horizontal reference, because like would you agree that any change in elevation from a horizontal reference would be a vertical change, like up or down?
Yeah, a change in elevation is a vertical change. That's by definition.
Okay, so if you're at, say, one location and you're looking horizontally to another location, any change up or down would be a different, right? I don't mean to be, beating a dead horse here. I just want to clarify that that's what we're talking about.
Yeah, it is.
All right.
Let's see.
So when when they're laying that concrete,
So I've got the images up
Um,
on the screen of the
how do you think that they
west arm
might
and
have,
east
like,
arm, and you can see the
I
elevation
don't know, have you ever laid
changes
concrete?
in the centre section
Personally, a
there.
few times, but yeah,
How it deviates.
I've watched it done a lot. Yeah.
I'm just wondering how they would finish the concrete, like to have such minute differences in elevation.
Pads
Well,
are pads.
yeah,
they're
I'll
not
be
full
honest.
length.
I don't know. I wasn't there and,
Not with
and didn't
string
watch it,
lines.
and
No,
haven't typically
Brian,
been
they wouldn't
around
have used
watching
string
that sort of
lines.
thing. And so, precisely who said what to who and how, what equipment they had out there
Yeah,
to set those things. I know what
but they're concrete
what
pads.
we
they're not.
what we can do
It's not
with
one
a
length.
concrete slab, for instance. A lot of the concrete contractors will
What's
use
that?
laser screeds these days to get the elevations right.
It's a concrete pad. It's not
I don't know
a
that they
full
were
length.
using anything like that.
So they only
I
put
have no
pads
idea
at each
what technique
support.
they went through, but I know it's a
So
very
they only have to level it at
elaborate
the
system when
support,
you look at the
not
amount of rebar that they
for
put
the
in that
full
thing,
length.
and the
That's
number
where
of
he's getting
control
mixed
joints
up.
and
So
control joints
they wouldn't have poured.
that they've
Yeah, I
got.
imagine
I
that
think
place
what is it?
It's
1 kilometer,
amazing.
4 kilometers
Slip
long.
joints
What
and
is it?
stuff that you won't
I've got it
normally
It's
see
not
in
one.
any normal construction.
Should be written on here.
How
Where they've
old
got-
is that place?
I think they
It's
started
30 years now or
from
something?
start to finish. Yeah, it goes back probably close to 30 years or so.
They used a
Oh,
4
okay.
kilometer long
Imagine the
water
concrete.
level.
I don't know. They probably didn't have
That's-
rebar back then. It might not have even been.
But I think it's either 1 or 4.
thought
It doesn't really matter.
I actually
Yeah,
have
4
seen
But
that
they
kilometres
didn't
seems
pour.
a picture somewhere.
Yeah, they
of
didn't
one of those
pour
pads while it was
one
under construction,
slab that
and
length.
rebar looks like it was
They
No.
just
loaded.
pour a slab at each
like
support
it was.
for the tube.
Yeah, because I know once that
So
rebar gets
where
any
he's
kind of
what
moisture,
he's trying to
it's,
infer is that how did
it'll break
they
down and cause all
finish
kinds
a
of
nice,
cracks.
smooth,
Havoc.
curved shape? Well, they wouldn't have had to
Well, they've
because
had
they
problems
only
with
have
that
to
in,
do
in
it
building
at
construction.
each support.
Yeah.
High
So they
rises
only
that have had some
they
serious
get the level
problems
at that
because of it.
support, and then they do it a flat perpendicular slab at that point, and then
Again, I
the
don't know that
supports
really
go
makes
off
any
that.
difference to
No, they weren't
So
plate
what the shape of
finishing
the
the
don't
whole
have to-
the whole length of it.
or the shape of that pad. I won't even
Yeah.
say the shape of the
So
tube.
they're not
Well,
going to be
we know the tube
having
is
to
straight.
deal with
The
what
question
he's
is
talking
whether or
about
not,
for the whole length of it.
And
it's a fair
they're
level
also
each
not
back-
fair
curved
point.
because
Can
the
the
point is
tube
that
be
it's
straight and the concrete
straight,
under it
so
not be
it
straight and take all that up as
deviates
adjusters?
from the
Yeah,
Earth's
it could be.
curvature.
In theory, I don't
Well,
see any reason why
technically,
it couldn't
they
be.
are curved
But the real question
in
is, why
reference
go?
to each other. So they're vertical at that point, the supports, but the tube itself isn't vertical. Actually, maybe they could. Well, the plan I saw, they still had vertical supports relative to the Earth, but the tube was obviously slung on the support. In other words, it hung off it, so
Yeah.
it wasn't fixed to the support. It sort of it swung on the top of it, so that way the curvature of the Earth didn't affect the direction of the tube. If that makes any
Okay.
sense.
Yeah.
Because you wouldn't, if you're trying to do that, you wouldn't fix the tube to the vertical support because the calculations and the tolerances would be painful. So you just make the tube self straighten, if you like.
Yeah. I was thinking more that to get it so that you're only having to have it self straighten a little bit instead of like,
Oh yeah, well,
too
it
much,
still is. I mean,
especially at the end.
you're only talking a
Terry-
few degrees at the end, so
Yeah,
Yeah.
that's fair.
Terry,
Yeah.
like, go on, Terry. Bye.
in that picture, you've got kilometers instead of miles because that's in America.
You mean it's got miles instead of kilometers? In that
No,
picture.
in the picture,
in
you've
that
got
picture. This picture.
No, in the one on the screen, which is LIGO, it says 4 kilometers.
The one you had previously had 4 kilometers.
Yeah.
Not miles.
Yeah, so it's 4 kilometers long.
Yeah, I'm just saying that this America should have miles.
Saying that?
We used both.
The previous one.
The previous one.
Yeah.
That
Yeah,
one.
previous one.
No.
Previous one.
Where are we?
I'm just being
So,
pedantic.
That one.
That
you
one.
mean? Oh,
Yeah.
That one, yeah.
Ah, jeez. Trying to confuse me.
I am, yeah. I'm thinking Perth.
So that's the live stream that we're watching. Yes, it's on that. Right. Now I get you.
Pad. I won't even say the shape of the tube anymore. We know the tube is straight. The question is whether or not, and it's a fair question. You make a fair point. Can the tube be straight and the concrete under it not be straight and take all of that up with adjusters? Yeah, it could be. In theory, I don't see any reason why it couldn't be. But the real question is, why go to all of the obvious trouble and torment of pouring a pad to the shape that it is if all you needed to do was just make some adjusters?
Well, that leads me to the question, like, why do you think that it was any different than laying any other kind of pad? Like, I know that the literature and stuff like that and the pamphlets and, part of the sell on the place was that it, it had to. It's 4 kilometers long, right? How could they say that it's not taking earth curve into account? I mean, that would be a big blunder, wouldn't it?
Man, well, a lot of people would have been asking a lot of questions if they would have said that. You're right. Because we know the earth's curved. We know that.
Well,
we know that you can't follow level and not especially over 2.5 miles without introducing a 1-foot sagitta in the center of that thing. It's not possible.
So you're saying that if you did leveling from, like, I don't know, how long are the sections of that tube? Do you remember
4
how long
kilometers.
the sections are? I know FE Dogma's probably got it memorized, but
the tube itself.
No, the sections that they put in place and bolted to each section, like the individual sections.
Oh, the
not
spacings.
the entirety, just
the
Okay,
spacings.
yeah, the individual sections, I think, I don't know, we're in the range of 40 feet or 60 feet or something like that.
Something like that. And
it was
they
done
used the
as
coincidence bubble levels to level them.
Actually, they didn't.
No, they wouldn't have used a level.
Well, they didn't.
On the cart, they use.
They're not accurate enough.
Methods to.
The spirit level is not
determine.
accurate enough, not for what they're doing.
Can you see my screen?
No.
I'm looking at the.
You can imagine how far out they'd be if they used a spirit level at each pier, and over what that would have done, and that wouldn't have achieved anything. They would have been out by 8.
Why do you think they use surveyors?
But Terry, what kind of spirit is in the spirit level? Is it vodka, whiskey, or rum?
I don't know.
It's, methylated. It's actually methylated spirits or something very similar to it.
Yeah, similar to methylated spirit stuff. So if you grab a heap, well, I was going to say if it did have proper alcohol in it.
So you can drink it. It's just, it's not a lot of it.
I'm leveling some spirits.
Yeah, you are.
No, YouTube, you can do it there. Just click on my live thing.
Yeah,
here in Discord.
I've got that somewhere, but I can't remember what I put it.
Yeah.
With all these images.
They're not leveling the tube. They're leveling the antenna.
Yeah, do you see that K and E plumb liner bracket?
Yeah.
With the coincidence level?
Uh-huh. And that's
They use
leveling
that
that.
too.
That's not leveling the tube. That's leveling the GPS antenna.
Cart.
The
It's
GPS
leveling the
antenna.
cart. Yeah.
Yeah.
So you're saying that they didn't cite?
Yeah.
The tube?
No, they didn't. The tube is not. It was not leveled with a coincidence bubble level. That's just that was simply used for the GPS system. That's all.
For the cart. What about the surveyors before they started leveling the ground? Do you think they used optical tools or?
Oh, I think they could have. Sure, you've got benchmarks that you can work from.
Yeah, and then after the tube was in place and they fired this thing up, how do you think they determined where that laser was shooting?
Oh, I wouldn't be able to comment on that. How they actually centered the laser beam in the tube. I don't know.
I think they called it first contact, kind of like the movie. but they shot a laser to align it.
Yeah, but you're talking about aligning the laser with the center line of the tube. We're not talking about changing the level of the tube.
Yeah, I don't know if the laser is center line with the tube or not. I don't know if it deviates to, you know, anywhere within that tube in its
Brian
path.
posted something.
Well, the tube was set.
Can someone grab that link and put it in
the elevation of the tube to make it straight, to make it run in a straight line in all axes? That was done by GPS.
TikTok videos, I think that goes in.
All right, so let me ask you about this coincidence level, because
Gotcha.
I wanted to.
Yeah, anytime anyone
It's
posts
a
anything
document.
like a document or
Say about it, like
or any information like that, I always throw it in there.
Was just for the cart, was
Yeah.
Yep.
So when you move a level, right? Like if you take a level, a carpenter's level, and you're say you're checking the top of your table, right?
Yeah.
It's going to be the same if the table is
this should be it.
equal dimensions throughout. Say it's like 2 inches thick or whatever. You put it on the bottom of the table, it's going to be the same. It's going to show you the same, right? The bubble is going to be the same spot.
Yeah.
So if that cart is moving up and down, it's just keeping it from tilting, right?
Did you see what page it was on? The number?
Keeping what from tilting?
I have to go
the
back.
antenna?
No, well, yeah, the antenna or the table, the cart that it's on.
I can't read what page it's
fixed
on
to the cart
in
to
the
make sure
live
that
stream.
the antenna is
Yeah, you
horizontal,
got
right?
Yeah, you got to keep the antenna.
Did not check. I can see if I can find it.
Just so, you know,
I can see numbers there.
And you're trying to hit an elevation.
I can't see what number it is.
Very precisely.
I can't read
and
it.
that means that's like not holding your rod if you're just out making sidewalks or curbing or something. That's like not, you want the rod man to be holding that damn rod perfectly plumb, and that's all that coincidence level is doing. It's ensuring that the GPS antenna remains perfectly plumb.
Just trying to bring up the same image.
Its receiver is up there at the top.
I don't think that image is from this document.
Oh.
Yeah, I think this is just talking about
I'm glad
the
you brought
process.
that up. I wasn't going to go there just yet, but that part about the rod being plumb, like they even sell little attachments for the rod.
Maybe page 11.
Little center bubble level, so that the rodman can look at it to make sure that it is, plumb, right?
Yeah, good rods come with that. That's right.
Well, yeah, good ones do, and I'm sure some digital ones with
12
accelerometers and stuff like that. But I'm talking about just the principle, not necessarily the tools or how expensive or how fancy the tools are. I'm just talking about the basic principle involved.
Yeah, by leaning the rod toward you or away from you, you'll actually change your reading slightly.
Right.
And if you're looking through the headlights, you're going to get a slightly different elevation that way.
It's a good document, though.
If you've got a target mounted on that thing and using
laser not a lot, Blue.
You're going to get a wrong distance too. So, yeah, it's very important to keep all that stuff plumb. And that's all that coincidence level was used for.
So, speaking of the rod and the instrument, and just not to get off of the topic of GPS because I wanted to go into that too, but just to touch on the principle of it, you've got a horizontal line that you're establishing with your level so that you can determine a rise or drop in the vertical at the location of your rodman, right?
Are we talking about LIGO now or a construction site?
I'm talking about the basic
Terry?
principle.
Yeah.
For a second. Just does Blue actually know that they use GPS? Because I would actually doubt they'd use GPS for LIGO.
Yeah, I didn't think that they would.
For the precision.
Yeah, for the precision.
The precision they need, GPS wouldn't be accurate enough.
No.
It
only goes to
use it to
only goes to about 4 what is it? 4 meters or something, or is that?
No, well, you can create a local one. You can get down to about 50 mil, but even 50 mil is not good enough for LIGO. So, yeah, I actually suspect that for LIGO they didn't use GPS to set out the a lot of it. They might have used it to create some reference points.
Yeah, I think they might have just used it for the location, that sort of stuff.
Yeah.
Yeah.
So if you put a reference point at the start and another one at the end, at the two ends, you can use a different. There's another higher level method of using GPS, but basically let it sit there for quite some time, and it measures as many possible satellites. So rather than the usual 3, it might measure like 200 satellite measurements to be able to work out exactly where it is. That takes a bit of time. It's not, you can't do that real time. So usually let it sit there for a while. So they could have done something like that and then got the marks, and then they would have done local surveying after that. Because to get the sort of accuracies they're talking about, they would have had to use a physical tape at the very end, because even the lasers and stuff aren't accurate enough.
But wasn't this the whole argument about, I think it was Bev using some sort of tool or rod in his argument with Blue before?
Well, they are. That's part of why I'm sort of thinking that they're talking about, because I keep referring back to what you would do on a building site, right? Which is, with a builder, we'll use a rod or a staff. So they're going back to very, unsophisticated equipment. And when you compare it to, using the latest total stations and theodolites, etc., what they use on the building site is not extremely accurate in comparison. It's accurate enough for buildings, but and in a local area it would be fine. But in terms of
accurate enough to build a deck as well, correct?
Yeah, correct. Yeah, but in terms of setting out something over 4 kilometres, you're probably not going to use one of those.
Unless it's a 4 kilometre deck.
No, so you'll get a surveyor who'll use something far more accurate to set out local control points. Then the builders could use something a little less expensive, basically, to settle something closer. But,
My mum, leave the deck out of it.
4 kilometres.
Sorry.
Yeah. So yes,
hey, Terry,
the deck
just play.
It is a whole lot of decks, by the way. It's because each pad you could call a deck. So it's probably about 15 decks, wasn't it?
Did they use any caulk?
They would use caulking, yeah.
We're talking about the geometric principles that lead up to your conclusion, and I don't think that we've come to any kind of agreement yet how those geometric principles apply in reality.
What geometric principles are you?
Yeah, what are you talking about? What are you talking about?
We've got a horizontal plane of reference.
Perpendicularity, for one.
We've got a horizontal plane of reference, and we've got an object that we're looking at in the distance, which is clearly dropped by 100 feet. What has happened?
Okay, so would you say that horizontal bends?
No, horizontal didn't bend.
Horizontal doesn't bend. But it's perpendicular. It's perpendicular to vertical.
At the auto level, yeah.
What about at the Rodman?
Trying to catch him in a.
Again, if you move away from the point,
you're about 60 miles, about 1 degree, you'd be holding
distance at all.
Vertical
is going to deviate from the vertical that you had at the instrument.
And again,
actually very much doubt they've got a Rodman, to be honest with you.
Have they got a rod that you could use at 60 odd mile for the 1 degree?
They wouldn't use a Rodman. They, as he calls them, or instrument man, or a field hand, as we would call them. Those sort of precise, accurate, they'd actually set up another tripod to measure to. They wouldn't have somebody there with their.
We were arguing about this the other day. We were watching this the other day about the line of sight that he had with the theodolite to that tower that was in the background.
Yeah.
As well.
So they wouldn't have Bev standing out there with a giant rod?
Yeah, that's the one I was talking about.
Not for those distances. Not for those distances.
I'm just surprised that Bev actually went outside and did an experiment, even though he got it wrong.
He wasn't wrong. He just didn't understand it.
Oh, there you go. All right.
Yeah, that's the problem with Bev. Is he's gone and measured something with a water level and a staff, and yes, everything he's saying is true, but he doesn't understand the greater ramifications of what Blue was trying to tell him. I mean, doesn't even know what the stadia lines are on his order level. So
do you think like asking a flirt how to use a sextant? Sorry.
Do you think he did that on purpose by having that tower in the background? Because he said he used it
Oh, they did.
Yeah, I reckon he did, but
Yeah,
not for the reason that we realised what we could do.
Yeah, I don't think he realised that it doesn't help his case. I think somehow they thought, oh, this just proves that, you know, we can see a tower in the background, so therefore, you know, it's all level. And it's all like, well, to realise that it actually shows that it's not level. But anyway.
exactly.
But he wouldn't have a clue of that. So.
No.
Without leading up with the geometrical principles to back you up, you're making a conclusion that is based on your conclusion.
Hey?
Like
because we say the Earth curves, that we're saying that's a conclusion.
It's a curve with a conclusion.
That's what he's trying to argue now. We're making the conclusion. So if I look outside and I see a car and I say that's a car, I'm coming to a conclusion.
We're coming to a conclusion based on our conclusion. Well, yeah.
Yeah, okay.
You're not allowed to do that.
Throw a straw man in there. Go on, throw another straw man.
I'm trying to start.
That's true. I don't think that's true.
I know you don't think it's true, but that's what's happening. And I'm just trying to tell you that that's what's happening.
Well, you're using the no defense.
Yeah,
the
nah.
I'm telling you, horizontal is perpendicular to vertical. It doesn't change where the vertical is. The vertical can be anywhere,
let's be
and
clear
it's going to be perpendicular to horizontal. If vertical is perpendicular to horizontal, and vertical diverges, then you're necessarily saying that horizontal bends. But you just said that it's straight.
Let's see if we can define the terms that we're using here. When you say vertical,
exactly.
What are you talking about? When I say vertical, I'm talking about a plumb bob.
Yeah.
I'm talking about the direction of gravity. That's what I'm talking about. That's vertical to me. What is vertical to you?
Well, hold on. Maybe this might be the root of it. When you say gravity, the direction of down, what does that mean to you? Does that mean the center
down.
of a presupposed
It means
ball?
down.
Towards the core.
Means,
okay, well, I mean,
ultimately,
down is down.
Ultimately,
down,
yes, that is toward the center of mass of the Earth, yes.
I don't know where you're at in the country, but down is the same for me as it is for you.
No, it's not.
Not really.
Down for both of us is pointing at the center of gravity of the Earth.
At each individual
down.
location.
Yeah, toward the center of the Earth.
Yeah.
Well, that's a presupposition.
No, that's not a presupposition. That's a
not really.
And how do you prove that by saying it? You just
as I said,
saying it. You're not proving anything.
As I said earlier, you can do reciprocal zenith angles and see it.
Yeah, with theodolite.
It's only been done about a bazillion times.
Yeah.
Every
I don't know how many people have done
it.
So you're saying vertical divergence?
It's just been done
absolutely.
so many ways.
Yeah, a few people have done that. Even Ruif done one, and he was elevated actually. He didn't do it at sea level, and he done a reciprocal zenith between 2 points.
Well, the better proof. Yeah, the better proof is if you can get a tall tower with a plumb bob to prove that tower's straight.
Yeah.
Then get another tower some distance away, that's say a few hundred meters, half a kilometre might be good.
Yeah.
Do exactly the same thing with the tower. Now, if you measure the distance from the base of the towers and then measure the distance from the top of the towers, you'll find that the top of the towers are further away.
Yeah.
Than the base of the towers, and that just shows that. And then to prove that, if you put towers 90 degrees in the same direction, like 90 degrees to the first tower, and do the same thing, and that's also the same distance apart, then you prove that there's a correlation between that the first tower wasn't out. So yeah,
that was such an important thing that it was taken into fact when the Twin Towers still stood. And they were further apart at their top than they were at the bottom.
Yeah, because as a skyscrapers get taller, which in those cases, usually you don't have to worry about it because obviously a skyscraper is individual, but because those were twins, and it's the same with the Burj, can't remember the tower.
Burj Khalifa, or no, not that.
Yeah, that's one.
Is that the one? Okay, yeah.
The twin tower that's got the two walkways between it. Same thing is that the walkways are actually different lengths, even though they're in the same tower. They're fractionally different lengths because they're at different heights up the tower.
Yeah.
But the taller the tower gets, then the further away the top of the towers get, even though the base is in the same spot. And it's easy. It's not. It's not like it's a we're making it up. It's just that's the reality. You
know? They've got a good racket because no matter what point you try and prove, they just say, "Oh, well, you're assuming this other point," and you go, "Well, we can show that by this," and then they just find something in there and they go, "Oh, well, you're assuming this," and you go, "Oh no, well, we proved that over here," and go, "Oh no, you're just assuming this," and they just lead it around in some twisted knot so that you can't ever prove or show evidence for anything because to do that you have to build on the assumptions of some other experiment, and there's always some other experiment.
What I
sort of like
LIGO. It's LIGO, not LIDDO. See, it's not LD distribution, whatever, right? So
it's LIGO.
And the hard thing is that they don't accept that the reason why people decided the Earth was not flat was that things didn't add up.
That's it.
Yeah, so when they started to have ships and they started disappearing over the horizon.
Well, that's why we had a crow's nest in them. Yeah, you can see further.
Yeah.
Why? I wonder why you can see further.
Why is that?
Yeah.
Why do we suddenly? And it's part of this myth idea that all the seafarers thought that they're going to sail off the edges. No, not the ones that actually went.
Yeah, maybe at first because they used to just stick to the coastlines a lot because they were too afraid to sail out any further.
Well, the Vikings didn't. They just headed off until they ran into land,
Yeah, North America, Canada area, somewhere over that way.
Yeah. So it didn't take them long to realise, and particularly on the equator, that they had to be curved because they could see different stars from one.
Well, that was before compasses. Yeah, they had to use the stars.
So they suddenly realised
the stars are mirrored. They're mirrored according to Lindsay.
Oh yeah, they're according to.
But
mirrored from south.
That's a big convex mirror.
Yeah, but they're mirrored opposite. So you see the same stars as we do, just mirrored.
Yeah, but he has almost a simulation idea that everybody has their own personal
dome.
torus field, though.
Yeah.
Remember? Yeah.
Personal dome. That's what I narrowed it down to.
Well, it's not a dome; it's a toroidal field. Remember, with Lindsay.
Okay, but they have their own arc of horizon. That's what is it? Their own.
Basically, yeah.
Domes are too
basic. Necessarily saying that horizontal bends.
No, I'm not.
Then how are you establishing a horizontal if verticals diverge?
Horizontal is only established at one point, not multiple points. 1 point and 1 point only.
How do you establish a horizontal at only 1 point?
With
if
you've got no level or theodolite.
At each one.
Auto level or theodolite. That's how.
Point doesn't have any information. It's just a location, a hypothetical location. It can be a physical spot that you designate as this point right here.
You don't understand that that an auto level or a theodolite is a pendulous sort of device. You don't understand that?
Okay. It's also optical, right?
It's optical, but it's a pendulous device. It's got a compensator built into it.
A compensator.
What did I say?
What's it compensating for?
It's compensating for gravity. Well, let me be a little more detailed about that.
Okay.
What it's compensating for is your misalignment of the base of it.
My misalignment.
When you set it up, you can only.
It might not be level ground.
Within typically about 15 arc minutes. About 15 arc minutes of level, and beyond that, the pendulous compensator in that auto level will automatically point toward the center of the Earth. It takes care of it for you.
Well, it points down.
Yep, exactly.
Yeah.
And that's your vertical. And the instrument is then the instrument then is perfectly perpendicular to that pendulum, that pendulous part of the auto level.
He's thinking.
I could pull up the pictures of the way the compensator works if you want. But
he's trying to think where to go with that.
I'd rather talk about LIGO.
All right. Well,
LIGO would be more fun to talk about.
I'd like to get on the same page on the geometrical principles involved, but we can talk about LIGO. What part of LIGO did you want to talk about?
Well, my question to you is very simple, and I've asked you this many times, and you don't ever seem to want to answer it. But are these or are these not the actual elevations that are reported to be?
Pull that up. What do you got?
You see it on my last.
What screen should I be?
Go ask a Fluff a direct question and never get an answer.
Yeah.
Well,
it's not showing on Discord.
It's not shown on Discord. Hang on a second. Let me see.
Not for me. I don't know if anybody else has seen it, but the live stream thing that you got, it's still got the cart.
Post the image in
Alright,
your
I'm
side
gonna
chat, Blue.
reshare.
That would have been easier
Okay. Let's
if
try
they're
that.
over on Discord.
Stream delay.
Yeah.
Well, you say
He's got to put it
actual
in
pad
Discord just
elevations.
for him to see it.
Yeah, as reported on the as-built drawings. Are those the pad elevations or not?
Oh, I don't know. What is this? This is Hanford?
Yeah.
Off of memory. I mean, like I said, I didn't really delve too deep into Hanford.
Well, I guess the real question is, do you question the elevation data provided to us on the as-built drawings for LIGO, either of the sites?
Do I question it?
Yeah.
What do you mean?
Do you say that those elevations are inaccurate for any reason? Yes or no?
Well, I mean, what they're based on, they're probably pretty accurate from what they're based on.
Well, they're based on mean sea level, but okay.
Well, they're based on WGS 80. Well, I don't know, WGS 84. That probably wasn't WGS 84 back then. It was probably, what was it?
Well, let's see.
It was WGS 84.
Let's see that.
Let's see, what's it say there?
It was the
That's what it
state.
says it's based on. This is the vertical
Does he
datum
even
is the
Does he
North
know
American
that
vertical datum 88,
Yeah.
and the benchmark that they use.
What's that, Dimple? I couldn't hear.
Oh, the thing was built in 88. WSG 84 was definitely 84 stands for the year. So yeah, definitely. But I doubt they would have used that anyway. I'm sure they used a grid system.
Don't tell Flarfs that.
Oh, what the WGS? That's just one of a myriad of coordinate system around the world.
Yeah, no, I meant that the 84 was for the year.
Oh, okay. Why not?
That's too much for a Flarf to understand.
Well,
yeah.
Funny enough, WSG 66. Guess what that means?
I've got no idea.
That it's 66 degrees off the axis.
WGS, okay. And that benchmark that they used is called McKinley. And McKinley can be found, I show it in this picture right here, the little red balloon there. There's the, and you can see LIGO down here in the little blue balloon. That's the center station at LIGO. So you can see the benchmark that they pulled all this from. It was only a couple of miles away from that vertex point.
And just for your viewers, because like I said, I didn't delve too deep into Hanford, but the Louisiana facility, those benchmarks, there were 3 listed from the NAVD 88, and those were a couple miles away from the actual site.
Yeah.
Also.
Yeah.
So
that will happen, and so they've got to transport those elevations over to the site, right?
Right.
They have to do that. So
do you think that was first order?
So here's what we got. And of course, there's a description of what NAVD 88 is.
Yeah.
Third or fourth order.
That tells you.
Well, while you have that up,
which one?
I'm asking you, like, do you have anything that shows or talks about how they transferred that datum to the actual site? Was it first order?
Yeah, I do have something. Let's see.
All right.
It was a new order.
Again, here's the. Well, before we get to that.
Yeah, I went through a bunch of these for the Louisiana site.
Yeah.
I don't have them.
There's the.
I'd have to dig through my computer to find them. I know I took some screenshots somewhere.
There's the NGS data site. NAVD 88 orthometric height is 563.9 at McKinley. You can see it listed up here, McKinley Station, Washington, Benton County, et cetera, et cetera. The ellipsoid height there is 150.229 meters, but the geoid height is minus 21.636, and that gives you've got to add that to the 150, and that gives you the orthometric height. Height.
How'd they get? Sorry.
You know what orthometric is, right?
Yeah, like a right angle.
No, orthometric height is the well. Let's see.
Just say you don't know.
There's a description of orthometric height for you that you can look at visually. Ellipsoid height is the height of the surface that you're talking about above the theoretical ellipsoid. Orthometric height, on the other hand, is the height above sea level of the surface. That's what orthometric height means. Okay. So I'll go back. So when we look at this, where they say the orthometric height of McKinley is 563.9 feet or 171.878, it's actually the ellipsoid height is the same as the ellipsoid height plus the correction for the geoid, which in this case is negative. So you end up adding 21.636 to 150.229 and get 171.878 meters. But
that was a new order from the Illuminati Masons.
That was what they were
using
right, John? As their datum.
Why do you think it changed from datum to date, or I guess what do you call it? You got the NAVD 88.
Yeah.
Before that, it was the NAVD. What was it? 78 or 74 or something like that. 72. I forget. Do you know what I'm talking about?
Yeah.
And then before that, it was like in the 60s or something. It might not have even been NAVD. It was something else.
Yeah. Those things have changed over time. Sure.
Yeah. Why do you think the distances are different?
The heights?
Like, yeah.
The ellipsoid, the heights of these things?
Yeah.
Well, for one thing, the ground moves. And it's particularly prone to do that out west. When you get out in the western part of the U.S.
You're saying that
before since 88.
Tectonic plate shift.
I mean, that
you're saying that there's movement.
Yeah.
That structure needs it to be pretty still, right?
Yeah.
I mean, in order to function the way that it says it functions.
You would hope so, but it can change.
I'd say they recalibrate it every time they use it, wouldn't they?
Probably, or at least on a scheduled amount, because I think it's constantly like running, or at least running, maybe not constantly, but running a lot, so that if an event happens, that they can pick it up. Yeah. I mean, we know, the average movement or whatever in a given year. So I mean, it's. And there's no place on Earth that is perfectly still. So you pick a place that isn't directly on a fault line, which Washington isn't. Now we have fault lines near us because obviously there's a big one that runs through California and it runs up, but it goes out into the ocean up near Washington or whatever. So and you do your best.
I thought he was talking about the datum, the different datums, as why has the datum changed? Like why in the 60s we used one, in the US they used one like datum, and then it changed, It's just the same as the grid systems. Is the more information and they become more accurate, so they find they've got to issue a new datum definition. So that's what is why did it change? Well, first of all, if you're asking that, then you know nothing about grid systems and datums. But secondly, it's just an accuracy thing, and that's why you nominate what datum you used when you set a level.
Well, that's going to be a big part too.
So that's why the datum is very specific which datum you use, so that if 20 years time someone goes to do another level and we're now using a different datum system, the difference between one datum and the other. So
right.
But basically, sea level changes, etc. Because the idea is to work out what mean sea level is, and that actually changes over time. So
sea level changes, the position of land masses changes, our accuracy changes. Yeah, exactly.
And so I heard that in that debate there where Mobius was saying, you can dig up his evidence in his hard drive, just the same as Drano said, my evidence is in my hard drive, but I got to dig it out. I mean, well, why not present that? For sake.
Why not have it?
Why didn't you have it ready, since you were coming to a discussion you knew was going to be on that?
My dog ate it.
How often do you see that when they say, you go to into a debate and they say, I've got such and such a video. Well, you're coming into the debate and you haven't got it ready.
Almost every Tuesday.
And how often do they say, you draw it up? And it's sort of like, but you're the one. Why am I drawing up your argument?
Well, you can find it with a quick Google search. It's your position. Why don't you find it with the quick Google search?
Brian's saying that passive and active vibration isolated systems are covered in one of the above links. That's what do you mean, one of the above links? Did he send a couple of links?
I only saw the one.
What was the other one, Brian?
I think more.
Oh, I've got it.
You got them both? Yeah, I see it.
Blue,
Yeah,
give me the other one.
yeah.
Yep.
Yeah, I think Blue and Mobius are talking about slightly different things. Mobius was talking about the transfer of the level from the station to the site, and then they've sort of somehow Blue's mixed up the tectonic activity in around LIGO would set different levels.
Well, we don't know where they're going with some of the crap that they come up with. The question.
So I think Mobius is trying to find some hole in how they set out the information. It's irrelevant as long as they get a level over from one point to a station nearby, then they use it. Now, even if they're wrong, as long as everything is relative to that one station, it doesn't matter.
But Flurfs love to find the irrelevant stuff to throw at us.
Did you grab that last link from Brian? It's the same one you just posted?
Yeah, it's the same one. So I posted it in that channel already.
There we go. I know it's going on a different tangent, but okay. Now we've got to figure out whereabouts it is in here. There's LIGO. Vibration isolation. There we go. Yeah, that's what we're reading.
Yeah. Flat Earthers making up their own holidays now? Is that a thing?
Yeah, he does that.
I don't know. Gary said, "Good Flat Earth Day, everyone." So
yeah, but I beat him on that one.
Hey, Gary, the rubber band man. Oh God, how can someone be so stupid? I tell you.
Hey, look, he's born that way.
Gary.
You can't help it if he was born that way.
Get those angles, Gary.
I almost think that it takes more effort to be
there. I trump Gary with that statement compared to his.
Yeah, there we go.
Yeah, so you can't beat that, Gary. We're not talking about Coriolis. You copying and pasting.
Get on topic.
Is he copy and pasting again?
Looks like it.
Yeah, come in here, Gary. We'll have a chat to you. We'll be nice. Well, I will be. I don't know about you two. 3.
I don't know about that. Gary. I'll try to be nice to Gary. I mean,
I have to be nice. I'm working. So.
Okay, so I'm not going to read all this.
But Terry, you're reading evidence. You've got evidence there, so you can't have that on screen.
See, active vibration isolation. LIGO's passive. Oh, this is going to be hard to read. LIGO's passive isolation systems are its last line of defense against unwanted vibrations. First line of defense against vibration is LIGO's active damping system. LIGO's quad suspensions are themselves mounted below active vibration seismic isolation systems, giving them the quietest possible environment for operation. There we go. I can't read anymore. That my eyes I'll have to make it bigger. Don't matter. But it's there.
I'm just wondering.
We're only talking now though about how LIGO was constructed, right? So you can
what it's based on, right? What
you could do.
These principles are based on.
Let's see if you understand this.
Yeah.
While it's always very useful and very for us all the way around to have a specific latitude and longitude and elevation in terms of elevation above some datum like mean sea level. While it's always very useful to do that, you realize that if your objective is just to survey that site locally, you could do little more than go out there and scratch an X in the ground with the boot of your heel of your boot and drive a stake up and say, okay, that's my datum. That's going to be 0. And I'm going to measure every elevation off that point. And it would work. You realize that, right?
I'm sorry.
Did that make sense?
Repeat that?
That's too complicated.
Okay, yeah, that sounded a bit complicated, that one.
The datum that was used in these benchmarks and so forth.
Knock a stick in the ground and measure a datum off that point.
For a lot of other reasons.
No, I don't know.
But in reality, if all you want to do is
lay basically what I was saying.
You could go out there and drive a stake up in the ground, put a nail in the top of it, and say, that's going to be my vertical reference. I'm going to reference everything to the top of that nail.
Right.
And that's going to be 0 elevation. I can do that. And it won't change anything, right?
Right. Just like the as-built drawings have what is it, 0 plus 100 or whatever is they start with?
Oh yeah, they've got an arbitrary point there at the vertex.
Yeah.
And they say, okay, that's 0. Now each point's got for sure, any point on there is going to have a latitude and a longitude and an elevation associated with it. But for convenience sake,
it's got to be straight, right?
For convenience sake, yeah, we're not gonna start listing those things. We're going to pick a point like that vertex and say, okay, that's 0, and we're going to measure from there.
Right. So I would agree that you can pick an arbitrary point and designate it as your 0 point.
Sure.
Your starting point, right?
Yep. That's one of the LIGO drawings for Hanford.
Yeah.
They look just like the ones that you know.
No, I know. I've done a lot of, like I said, I delved pretty deep into the Louisiana one, and then delve as deep into the Hanford. I dabbled a little bit. I'm a little bit familiar, but as far as knowing things like offhand, just
right, yeah,
from the hip.
Yeah, I wasn't trying to cross you up or anything, and we could go pull all the same information out of Livingston, and I'm very familiar
it really
with
doesn't matter because the principles are the same, right?
Yeah, they're exactly the same. There's no difference at all. Let me go to the next sheet here. This is one. Let's see. Got to find the little thing. There we go. Now you see something else. This next drawing is one of the drawings in both sets of drawings, whether it's Livingston or Hanford. And you'll see I've got 6 circles on there, right? Those circles are identifying GPS points. Let me show you. There it is, blown up. Okay. GPS points, which were called LIGO 1 through 6. 6 is the one that was way off up in out in the middle of the pasture, so to speak. But 1 through 5 are
like at a 45-degree angle from.
Yeah, they're up and down the arms. You see LIGO 5 here close to the.
No, LIGO 6. You said it's in the middle. I said like at a 45-degree angle, like from.
Yeah, I'll tell you what. Let me go back and I'll show you where it is. It's this one out here. That one.
So almost at a 45.
That's LIGO 6. Yeah, it's not. It's out there. It's just a geographic reference.
Right.
These other ones, though, the other 5 are up and down the lengths of the arms.
And these right here, these are for the horizontal alignment, right? Not the vertical alignment.
Well, they're vertical too. You see, they've got the elevations on those 5. They are the measured elevations, and those elevations, those were GPS coordinate points, and as it says in the note down here, high accuracy placed by Washington State Department of Transport, DOT, geographic surfaces. So they took the elevation at the datum over there at the benchmark at McKinley, and they transferred them to these points at the LIGO site. So that gave them known reference points that they could line up their GPS stuff with.
Right. So is that before or after they moved the dirt? That'd probably be before, right?
That's before, yeah.
Yeah.
Yeah, that would have been before. And then we get to one of the arms. Not sure which one this is. Well, yeah. There we go. You got a little key plan on each one of these. That's nice and handy to always have those. So it's this station down here at the vertex on the northwest arm, or what they would call arm 2, I think. And you see I just put the red line on there to show you that it's lining up with the vertex. It says that down here somewhere. But anyway, let me zoom in a little bit further on the next slide. And there you see that elevation at the vertex of 533.78 feet, right? And the note over here that delineates defines that top dotted line as the top of the concrete beam tube, top of the concrete slab for the beam tube.
Well, that's just the tube enclosure.
Yeah, that's the slab.
The top of the concrete slab beam tube enclosure. So is that the top of the
concrete slab, like it says?
Well, because it's encased in concrete, right? They've got the concrete covers over the tube.
Yeah. So but this is the slab itself, not the tube, not the enclosure.
So one is the beam tube and one's the tube enclosure? Or one's the slab and one's the tube enclosure?
This is just the slab.
Okay.
This is only these are only the elevations of the slab.
He can't follow very good, can he?
What you get?
He's not following very good.
Never.
He's tried to set him in a trap.
Yeah.
I can hear it.
Yeah.
Yeah.
I've already looked at all these before, and I knew that there's a datum points that where the where each, even though where each individual pier's worth, the slab has got a reference point on these diagrams. I already noticed all that.
It's Mobius trying to make a concrete argument and failing.
We'll do another
Probably.
jump. We'll try to do another jump and see if he gets into any other thing.
Well,
What's
I
he
picture
talking
the
about
Earth
now?
as a sphere. Yeah.
Well, like your profile picture. That's how you picture mean sea level, right? Like
Okay. Yeah.
a prescribed radius from a center.
Yeah. Okay.
Well, I mean, how do you get that
There we go.
from
What is Howie doing here at this time of night?
measuring from a horizontal?
How do I get sea level from measuring from a horizontal?
No. How do you get that image in your head from measuring from a zero? Right. We designated mean sea level. Bam, zero.
Yeah.
We've stuck a nail in the concrete. We're going to call that our zero datum, and we're going to go horizontally from that. We're going to measure up or down an elevation.
Hi, Howie. You sneaking in, are you? Nope. Can you hear me? Is Howie gone quiet?
I don't hear him.
He's lost his avatar too.
Broken mic.
He was working fine the other day over on Geo's.
Maybe it's Flurf Tech.
He's been on here before, so I don't know why he's lost his avatar. Used to have it.
Forgot to sign in, maybe.
Yeah.
Maybe Gary got it for him.
You might have to type somewhere, Howie, if you can't hear us. You using the right mic when you're logged in? He's not typing anything anywhere. He's not no, he's not. Put the internal chat if you can hear us. You probably didn't join with the right mic.
The mic is CGI.
Yeah.
Rhoda got it.
Oh, we'll play a little bit more, and then we'll see if we can find out what's happening with Howie. We don't even know if he can hear us because he hasn't responded anywhere. Internal chat, YouTube chat, no. Discord, DM, no, nothing. I got no correspondence. He's given us a silent treatment. Oh, you can hear. No, we can't hear you.
Ah, there we go.
Yeah, we can't hear you. You've joined with the wrong mic setting when you joined in. You might have to drop and come back and join with the right mic. With the audio device you connect with. He can't find the dang setting. That's when you first join in, it comes up on your screen. Join with audio, whatever.
Audio.
Yeah.
Yeah.
Well, drop. Well,
Rhoda got it.
You can either go to your settings in here and reconnect it in the mic settings down the bottom. Go through that way, unless you're on your phone. Okay, we'll play this for.
Yeah, there's a little up arrow.
He's having
From
technical
that horizontal
difficulties.
to determine what we want to be straight, right?
We're going to measure up and down from that point. Up and down from that point to obtain orthometric heights of every point along that.
What do you mean orthometric?
Well, maybe orthometric wouldn't be the best choice in that case, but an elevation differential. All right, let's just call it that.
Okay.
Well, we're going to call it 0.0, and then we're going to go up and down that pad, and we're going to say, okay,
dang, he's right above damn in settings.
Negatively by however much, or positively by however much, and that's what we're going to do. We're going to use points of. We're going to be referenced to that point that we said is 0. Now that's 0 elevation, right? And we're going to use that as the reference all the way along.
Okay, so like that blue line that you got there.
Yeah.
On that diagram, you're starting at 0 at the vertical. Let's just say the vertical, versus the feet, the elevation feet.
Yeah. If you want that to be 0, then you can.
If we're going to get through this, I might have to do another jump.
Or I'm sorry, the horizontal.
See if he's still.
Oh yeah, there's no way.
It's just going to be the same diff. Yeah. So I can guarantee it. Basically, he's going to misrepresent what
justifying
sea level is
and I'm saying
datum. Yeah.
Have a water level that's say 2.5 miles long, and you go all the way out to 13,100. You would measure that water level.
Well, you should back that up a little bit.
4.5 foot change.
So we can get the whole water level thing.
Sloping vertical or slanted vertical.
You don't know how to get a perpendicular to a line. Should I explain how you do that?
Well, if you look at your graph here, the gray lines that go left to right, if we call those horizontal, and the gray lines that go up and down, if we call those verticals, then the ones to the far left are the same as the ones to the far right. They're all perpendicular, all parallel.
There we go. There's his original thumbnail.
Yay! Can we hear him?
I don't know. Waiting. So you shouldn't have been away so long, Howie, and you wouldn't have had these problems. Should have dropped in every now and again, and you would have kept your settings up to date.
It needs those cans with the strings on the end.
Yeah, that's it.
You're talking
about cans with the string.
A graph. You're not talking about reality.
I'm talking.
In reality,
how do you have a horizontal
each of those
plane
elevations in
at
reality,
only 1 point?
In reality, each of those elevations is a different sphere.
You say that, and I'm asking you, in reality, how do you have a horizontal plane at only 1 point?
You're not seriously asking me how you have a tangent to a circle. Really?
Yeah.
I didn't say anything about a tangent. I said a horizontal plane.
That is a tangent to a circle.
So you're saying that a
horizontal plane is a tangent to the circle at a point. Yes, that's what I'm saying.
How do you justify that statement?
I didn't draw all over the screen. Just ended
a
up.
horizontal plane is a horizontal plane perpendicular to
Did you
vertical.
just draw all over the
screen?
screen?
Justify that statement.
Oh, okay, all right.
You don't. How I justify that statement? Third grade math. That's how.
That you say. I just wanted to hear you say it.
How do you justify?
Who's fiddling with the annotate thing?
Going against
what is your justification for saying that's not how it works?
Well, a horizontal plane is made up of at least. Hold on a second. You asked me to justify it. I'm justifying it. And
so
I'm
you
saying
can draw.
Yeah,
draw. Oh, it's Howie, you bugger.
3 coplanar points.
You don't need to say
those
3 coplanar points.
Howie's drawing all over the
coplanar points exists a plane which is perpendicular to planes that, which is.
Luckily, that doesn't look like it's going out to
it doesn't matter
YouTube.
wording. The way I word
lucky
something doesn't
not.
change how it is.
No, it's not.
So just relax.
Okay then.
A plane exists of 3 coplanar points.
Even though we're sharing it in here, we
to
just can see what he's
will
doing.
all be parallel.
How do I rub it out?
Horizontal is a plane.
That's not an appropriate question to be asking on here, Terry.
We both established that it doesn't bend.
Here we go.
It doesn't curve.
I fixed it.
You argued back and forth that it doesn't curve. So we're both in agreement that it doesn't curve.
I'm trying to get rid of me pen.
The
Still got it
horizontal
in
doesn't
my
curve?
hand.
Yeah.
Yeah, it doesn't.
Okay. So a plane, which is made up of 3 coplanar
How
points,
do I stop it?
is
Harry.
not a plane
What?
at any individual point.
What'd I do?
It's a plane because it's at least 3 coplanar
Oh,
points. And within that 3
Everything.
coplanar points,
Okay.
every location on that
He's actually-
plane has a perpendicular to it.
I'm
Yes,
actually
I agree
listening
with
to
that. I
the
agree with that.
Vertical
the
is perpendicular to
conversation.
horizontal.
I agree with that. Hold
Hey,
on a second.
You were trying to say
But
that
Pause for a sec,
wait a
Terry.
minute.
you were trying to say
Sorry, I don't know if Blue's going to get onto this, but he keeps referring to 3 coplanar points, but he's assuming that his points are coplanar. And yes, 3 coplanar points will be in the same plane, but how does he know his points are coplanar? And that's the trouble he's got.
because he
gonna
assumes flatness.
Well, he's going to claim that the other points are coplanar, but how does he know that? How does he check that?
Assumed
And
flatness.
he's assumed flatness. So he's doing exactly the same as he's saying Blue's doing. He's saying, oh, Blue's assuming a curved Earth, and he's doing exactly the same as assuming it's a flat plane. And I said, well, the reality is that's why you assume it's perpendicular to that horizontal point, and then you can go and prove, okay, are the other points coplanar? And that will prove whether they're curved or whether the surface is curved or not. But he's assuming they're coplanar rather than proving they're coplanar. So yeah, I'm sure Blue will get into that, but that's where this guy's completely off the track.
Yeah, with people like this, you don't try to overcomplicate your explanation. Otherwise, they'll
No.
just either jump around
No.
too much, and then they'll end up.
But that's the
confused.
easy thing. He's going to say he's caught Blue in a trap. But
Yeah,
all Blue needs to say is that, how do you know your points are coplanar?
yeah.
How can you prove
That's
it?
what you said.
You're just assuming they are. Yeah. Go on. Play.
Donkey. I read that.
that vertical.
What?
Three coplanar. You got 3 points, and they identify
Yeah, I
a
swear to
plane.
God,
You don't
I
need to
feel
say.
like I gotta
You don't
point
really need to say 3 coplanar points. That's redundant. But
It
okay.
is redundant.
We have
but
we have
just
a
for
plane.
clarity,
We have a
because you said
plane,
that I'm
and we
geometrically
can have
illiterate.
and we can have that to that plane. We can have an infinite number of lines that are normal to the plane. Let's use that word, perpendicular to the plane in all directions.
Wait.
Normal. Is that
Why
not
are you
true?
changing terms?
Huh? I won't
Why-
change
why are
terms.
you
Okay.
now you're
Perpendicular
bringing
to the
up.
plane.
Well,
Okay.
first of all, I tried
Were
to
you
say
happy?
horizontal, and you said
What are you
it's
happy
a
with?
tangent.
What are you happy
Then I
with?
said it's vertical, and now you're saying it's
you're
a
not
normal.
So you're just going to fund me. Okay.
No, I'm answering your question. You asked me a question. I'm answering your question. Why are you going to interrupt me
Yeah,
while
which
I'm answering
question?
the question that you asked?
Which question you're answering? The answer to what?
Well, you're rumpusing me for one thing.
Yeah,
but
exactly.
What the point I was trying to get to is, I'll go along with you that we could have an infinite number of verticals. What you're using a lot of terms interchangeably. Do you like vertical or perpendicular?
I hate it when
or
flirts
normal?
do
Which
that.
one of those terms would you prefer? I
Put
use?
words in a
To
sentence
me,
that
they're all
with
meaning the same
different
thing when
meanings.
we're talking about this plane and lines piercing the plane. Okay, we could call them verticals. We could call them perpendiculars, or we could call them normal.
plane.
So which one of those terms do you like the best? I mean, I'll use it. Okay.
Yeah, pick one.
Because here's my question: regardless of what you call it, how many of those verticals that you're talking about can be tangent, can be at the point of tangency of that plane to a circle, to a sphere? How many?
Ask that again.
How many verticals?
You confused him with the
How many
question now.
verticals in that plane that you're talking about that has all these
Oh,
verticals?
we're
that
getting
are all
sound.
perpendicular to the plane. How many of them simultaneously?
And someone's sort of sounding.
Yeah, that's how he.
Yeah,
What?
I've got it figured out. Now I've got to get my headset back up.
Sounds like it's raining over there.
You were talking okay when you were in Discord there last time I was hearing you.
Well, that's what it was. I had a Discord call open, and I didn't realize it. And so evidently it had my mic tied up. I hung that call up, and then it disconnected my headset altogether. But let me see what I can do here.
Yeah, I did notice you were down in there. I should have mentioned that. You're not.
Now, how about now?
Oh, that's a lot better. That's better than some
Awesome.
people's.
Good deal. Thank you.
Yeah. You been all over the
G'day,
place?
Howie.
You been all over the place in Discord today? Because did I see you in Bev's, or you weren't in Bev's?
No, I didn't go. I don't ever go to Bev's.
Oh, you
I
don't
don't
go
like
to
it
Bev's.
over there.
Yeah.
But no, I mean, I'll go over there and look around, but I don't go in voice chat.
Yeah, I went in there just streaming it from here. I was over there for a few minutes, and then they all disappeared. Probably they didn't want me to record them. And then I ducked down
Yeah.
to Bev's, and we listened in there for a minute, and then we've been playing blues video. So not
Yeah,
much.
they were talking about it. And of course, Ezzy and Raquel were shouting, touting victory. But I was like, yeah, whatever.
Yeah, that's what I was hearing too. Yeah,
Victory on what? They didn't win anything.
Yeah,
They never win anything.
This is not my scheduled day for streaming, Howie, but I might do this now and again. Actually, stream near this time of day in my morning, which should be still nearly midnight for you guys. So that's not too bad. UK time, no, it's only 4:20 in the morning over there, so they miss out.
Yeah, you had streamed some on my Sunday evenings before, and then you just quit doing it. And that's about the only time I'll be around. I'll see that you're on early of a morning, but I'll be doing my morning routine and whatnot.
Yeah. Blue drops in. He says it's about 7 o'clock. I think it is his morning time. So he's just up. So I catch Blue.
His 7 when I'm out west is my 4.
Yeah.
It's 4 a.m. where I'm at when it's 7 at Blues.
What's wrong, John?
You're another West Coaster, Howard, like me.
Well, I'm actually a Tennessean. I live right down the road from Blue, but
okay.
But I run out west during the week. Yeah.
Oh,
yeah.
okay.
I'm a couple of 100 miles from Blue.
Oh, you're right next door, basically.
Yeah. Yep, I'm going to get over there and visit him one of these days.
Cool.
There. Oh, back to this.
Simultaneously can be at the point of tangency of that plane to a circle or a sphere.
Point of tangency?
Mm-hmm. The point where that plane touches a sphere, how many verticals can come from that point?
Infinite.
An infinite. Oh, okay. Thank you. So you can have an infinite number of verticals all through that one point.
No, you can have an infinite number of verticals on that perpendicular to that plane.
But only one of them that passes through the point of tangency of that plane to a sphere.
No. Vertical has nothing to do with that circle or that sphere. Vertical's not a radial.
I'm trying to move along a little bit.
Well, are you saying the vertical is a
little
radial?
more advanced? Yeah, that's what I'm saying.
That's what you're saying?
I'm saying that the plane that we're talking about is tangent to an elevation spheroid, if you want to think of it that way, at one and only one point. And there's only one vertical that can pass through that point. One and only one.
Okay, so...
and it's headed in the direction of the center of the sphere.
100 feet away from that one vertical.
Yep. That plane is no longer tangent, is it?
No, I'm asking you where a vertical would be. Because if I got 3 points making up a plane, each one of those points would be perpendicular to vertical.
We've already established this, Mobius. Every point, every vertical you draw on that plane is perpendicular to that plane. But only one of those verticals can be perpendicular at the point of tangency of that plane to the sphere.
Okay, why are you introducing these terms?
That's a better way of putting it here.
Yeah, I understood that.
Why would you introduce that?
Is that too? Okay.
It's not complicated. I'm just wondering why.
I'm not even a surveyor, and I understood it.
Yeah, exactly.
Horizontal line.
Yeah, and you haven't established. You haven't established the words tangent to a sphere. You haven't established that group of
well, you want to know the meaning of a word now.
Math, Mobius. Come on.
I don't need a lesson in math. I need a
let's
lesson
get the
in
dictionary
how to
out.
rectify these thoughts. Like, it boggles my mind how you put the cart before the horse.
I don't think so.
Yeah, you do.
I don't think so.
And everybody sees it. It's just amazing.
Oh, I think everybody is clearly seeing what's going on here. Yeah.
Everybody on your side, I'm sure, thinks that I'm a complete idiot and that I'm.
No, we don't think you're an idiot. We just think you're
good stuff.
being a
I'm
bit
sure you got all
difficult.
kinds of colorful insults ready for your little circle jerk later. But
I mean,
I'm really wondering, like, how
whatever
say
word
that
he
a
wants to use,
plane,
I'm fine with.
which is of 3 coplanar points, is perpendicular to the same.
I think we might have to break the crayons out
perpendicular at all
for him.
3 points, but you're bringing
Yeah,
up this
just make sure
tangent
that
to a
there's no
sphere
Marines
as
in the
if
room.
that, like how do you justify that? Like bringing those terms into it without first identifying that you've got a perpendicular relationship between one plane and other lines passing through it perpendicular. I just don't understand how you're like skipping forward so
He's
far
trying to imagine this
without
on a
first
flat Earth
establishing certain basic fundamentals.
type of example.
It's crazy to me.
That's what he's doing.
Yeah. He's assuming flat Earth.
But
I know you don't. That's what's mind-boggling. Like you're
And
not
he's
a dumb
assuming
guy. I
that
mean, you're an
those
engineer. You've been a
horizontal
professional in
lines
your
at
life.
each tangent are
I
going
just don't
to
understand how you can
line up. Yeah, on a flat
not
Earth,
see
if you draw a straight
what
line.
you're doing.
well, I don't know exactly how to respond to that, Mobius.
Blue sounds
I really
defeated.
don't. The Earth that I live on
It's just so much.
in a blade spheroid.
Blue,
In
this is
an
why you don't
imaginary
argue
plane,
with
because
idiots.
all planes are imaginary.
Drag you down to their level
Can
and
be,
beat you with experience.
Can be tangent to some point. Every plane in the
Flips don't
universe,
have
if we moved it over
experience.
here, could be tangent to one and only one point.
They have
on the
experience in
sphere.
being flirts.
And that means that only one of the verticals, the normals to that plane, would pass through that point of tangency. That's my point. That's all.
I guess I just don't see the connection
And
between, a horizontal being a reference from which you measure elevation from vertically to vertical only being at the point that you're at. Like, how can you measure a slope from horizontal 10 feet away if that vertical isn't perpendicular to the vertical where you're at, or isn't parallel with the vertical that you're at, isn't perpendicular to the horizontal that you're using to measure the elevation difference. It just doesn't make any sense. It's not square.
The fact you can't work that is why I'd never surveyed.
You're right.
It's
I
not
don't
square.
think I'd hire.
Like,
I don't think I'd hire him to do any
the word
surveying or anything.
correct.
No.
You can only survey on a flat surface. That's the only. Apparently, that's the only way you can do anything to flirts is if it's not flat, you just have to throw up your hands and walk away.
How do you get a vertical with the horizontal, but how do you get the horizontal with the vertical? Okay.
I'm confused.
Yeah.
Else.
Okay.
It is like it stems from rectangular, rectilinear. These things. It means
What?
right.
Rectum.
Like correct.
What?
Right.
Where
Right
you could have a lot of rects
square.
in that.
Like these things are built into not only our language but fundamental principles of life. And I don't know. It's just weird that you.
I suppose I've got
square this
What's
up.
weird?
I suppose I've got an equivalent issue with the way you guys think, which makes absolutely no sense to me.
I'm sure that there's a clear disconnect. It's just hard to put my thumb on it.
Yeah, we can.
Well, it starts with this idea of
Yeah.
Well, I think
I've got some
thanks
ideas.
to our friend Bev, he proved that with his auto level and Blackpool Tower.
Yeah.
Very nicely done.
Yay,
your
go Bev.
definition of pizza
Yeah.
is pretty loose.
Thanks, Bev.
But
Yeah,
whatever.
thanks, Bev.
Well, okay, then let's say this. He observed a drop from horizontal with his photograph.
Let's say
No, he
that
didn't. No, he
you
didn't.
observe
No,
what you interpret
didn't.
as what you think it is. How about
Well, you
that would
haven't
be
given
more
me
accurate.
something else. You don't have anything else to give me.
I just, if we can keep it honest, that would be great. I think
Well,
that
that
would
is
be more
honest.
accurate.
That is honest.
Okay, well, saying that I'm right because I'm right isn't very honest. I'm
All I
just
know
saying,
is
I don't think anybody.
all I
I
know
don't-
is that Bev showed us a picture, and clearly a building in the distance has dropped by 100 feet. Now,
Yeah, explain
you
that
tell
one.
me why that happened.
Yeah,
Because
why?
it matches a curvature of 8 inches per mile squared exactly.
Look,
Mm.
Blue
How did
Oak,
that happen?
I'm not of the mind that this just comes out of thin air. I'm sure that there are things that people see and observe, and they interpret these observations as something, and then they they build this model based on these observations, off of these interpretations from these observations, and then everything that they interpret after that that points to that model, they say is correct, and everything that points outside of that model, they disregard and discard, and they try to rework and all this other stuff. And so, I mean, it's been a long time coming. This like complex, sophisticated model.
Yeah, but the one difference is floaters presume the flat Earth first, and then argue the globe.
Yeah, but they don't even have a model to base it on.
I've
been asking for one.
Yeah, I was gonna say, flat earthers assume flatness. Stop.
Yeah, that's it.
Everybody else does measurements and tests and repeats and builds on previous knowledge and everything. Like yes, we've gotten here through thousands of years of discoveries and tests and verifications.
RT96 says, see and observe? Well, do you observe what you see? Or do you see what you observe?
You can observe something without seeing it.
It's an observation.
Yeah, because you can use detectors to make observations, so you can technically not see them. But I think if you see something, it is by definition an observation as well.
Model, I don't.
I think it's actually a very simple model.
I don't think it just came out from nowhere.
I think it's a very simple model.
Well, yeah, because you've grown up believing all this.
I think it's a perfectly acceptable, perfectly usable model. What I like about it is the simplicity of it. It very simply and very accurately predicts exactly what we observe in nature. On the other hand, we try to take what you guys do and make any sense out of it, and it's just a mishmash of bullshit to try to make it do anything.
Exactly.
When you say you guys, what do you mean? Because I'm just talking about measuring a vertical change in elevation from a horizontal reference.
Okay.
What do you mean, you guys?
Have you noticed this great trend?
I mean, everybody
trend to keep trying to say, "Oh, we're not flat earthers."
So everybody that says that, everybody that measures elevation from a horizontal reference vertically, everybody that says that is my side of the fence.
I suppose. If you want to say it that way, but no. The point is these elevations that LIGO provided in as-built drawings do not plot a straight line, and you still have no explanation for why that is.
I've tried to discuss it with you. You got defensive.
You still have no explanation. Well, I'm waiting. Give me an explanation. Why does that blue line curve?
Because it's based on a hypothetical model.
Then you're saying that the tube at LIGO is curving.
No, I'm saying that the values given the elevation values are based on a hypothetical model. Of course, they're going to represent that hypothetical model. I'm not saying anything about the tube, the concrete, the laser beam, any of that. I don't know. I've never actually visited the facility.
It's the actual measurement.
What about those elevations is based on a model, Mobius?
I will tell you that the values that are based on a model are going to represent that model.
How do measurements? How are these measurements based on a model?
The actual measurements.
What?
How are these measurements? These measured elevations? How is that based on a model? Other than if you're going to try to claim that the sea level elevation is based on the geoid. If you want to say that, okay, I'll go along with it. But how does the difference in those elevations? How are they based on a model? How are they based on a model?
I'm trying to answer you. Sorry, I didn't know you were going to ask me 3 times in a row. How is that blue line based on a model?
Yeah. What model is it based on?
I don't know. It's based on a reference geoid. I don't know, GPS, whatever model that they use in their programming.
All right, fine. The starting elevation.
WGS 84. I mean, those are very complex mathematical programs.
Then you're simply saying the starting elevation is wrong. But now, what about the rest of them?
I'm not saying that the starting.
You're saying that the
starting elevation could be whatever.
Question.
We could arbitrarily designate the starting elevation.
Okay. Now we arbitrarily designate a starting elevation, and we make measurements of the elevation of that pad, referencing
that could be any elevation.
How is that based on any model?
That could be 2 meters, 2 inches, 2 feet.
How could that possibly be based on a model? I don't
5
understand.
feet.
This is very simple.
Doesn't matter.
Right. Well, I'm asking. Well, all right. How is that based on any model? Well, it's representing that model.
It's representing that model.
Those values come from
measurements.
Measurements with what? Measurements from horizontal?
with measurements with whatever tool they were using to make elevation measurements, and that could have been.
And that's the key.
All of those things that we've
using?
talked about. It could have been a water level. It could have been a dumpy level. It could have been an auto level. Could have been a digital auto level. Could have been a theodolite. Could have been a GPS system. Could have been any one of those things, and they would all return the same set of elevations. All of them.
You say that, but what tools did they use?
Hey, you say that.
I'm saying that the
doesn't matter. Why does it matter?
It does matter.
It doesn't matter. It doesn't make a damn
matter.
one way or the other, Mobius. You're just squirming trying to find a way out, but you're caught in this trap, buddy.
You say things.
There's no way out for you.
All right, buddy. Look, I'm trying to ask you if
all right,
this
guy,
based from a horizontal reference. You don't know. I'm asking you, what tools did they use? You're saying it doesn't matter. And I asked you, well, if I use the
No, he
water
didn't
level
say it doesn't
from
matter.
here to here, are you saying that that water level is going to drop from horizontal? Then you got all crazy and upset. I don't know how you want to have this conversation. Okay, then answer.
Answer what?
Does the water level, when I go from one place to another with the water level, does that water level, the level of that water, is it above or below the horizontal?
I'll answer it this way. If you took your water level out there and you set it up at the elevation of 533.5, whatever that upper one is, and you have a water level that's, say, 2.5 miles long, and you go all the way out to 13,100, you would measure, that water level would show you a 4.5-foot change in elevation of that pad. That's what I'm saying.
Well, first of all, I wouldn't take it all that way. I wouldn't need to, because I'd want to make sure that everything in between was level. And that's not 1,300, it's 13,000. But
what?
Regardless.
I misspoke.
Huh?
13,000. Yes, there will be a 4-foot change in the elevation, regardless of how you do it.
So you're saying that there would be a 4-foot drop from our zero, we'll call that our horizontal distance, 0 to 13,000.
Yes. There'll be a
4-foot drop in my water?
Yeah.
And you know this how?
That's what they measured, Mobius.
Who measured?
Jacobs Engineering.
Wait.
Caltech,
You said with the water level. I'm asking you who measured that with the water level.
Nobody measured it with the water level. You're the one who brought up the water level. I'm answering your question about what would happen with the water level.
And I'm asking you how you.
Nobody but a window-licking idiot would go out on a job site like this and pull out a water level. That is ridiculous, Mobius.
I didn't say it wasn't ridiculous. We're talking hypothetically. I would take a water level.
How many construction sites have you ever been on where somebody pulled out a water level to try to level a pad 2 miles long?
So he tried to turn it around and make Blue the instigator of bringing up the water level.
Yeah.
and then pick on him.
They like doing that.
Well,
go down the water level.
Yeah, but you said water level. Yeah, I said water level, but I didn't bring it up.
How many construction sites have you ever
That's
been
a
on?
ridiculous question. That's not what I'm saying.
Yeah, it is what you're saying.
It is not what I'm saying. I'll say it again. It's not what I'm saying.
Okay, what are you saying?
It's not what you're saying because you say that's not what you're saying.
Do you want to address what I'm
That's
saying?
what you said.
Yeah, what do you say? What do you say?
Not make up some stupid shit to try to make me look dumb.
Oh, I don't
know.
do that.
Blue doesn't have to do anything for that.
Then let me talk.
It's automatic.
So you're questioning
things that I'm saying. I'm not saying that anybody's ever done that.
You are questioning whether or not there's a 4-foot elevation change. That's what you're questioning, right?
I'm asking you how you know that.
Because that's what the drawings report, and I take I'll take their word for it. Absent any evidence to the contrary, I'll go along with what is presented on that set of as-built drawings. Now you may choose to say that's wrong. I've got to be able to verify it. I need some testimony. I need to go to court. I need this. I need that. I don't need that. All I need,
what I'm saying.
All I need is a set of signed drawings from a professional engineer that says these are the elevations. That's good enough for me.
All right. So if you're at the 0, right, of our horizontal distance, and you take a water level from 0 to 13,000.
Why are you bringing up the water level?
Again, yeah, why is he bringing up the water level?
Because they did that at LIGO.
I'm saying that because that's what the elevations show. Yes, I'm saying that's what will happen because that's what the elevations show.
So I'm asking you, if I take it in 100-foot increments all the way up to 13,000,
it's still going to drop 4 feet.
It's going to drop from horizontal?
Yes.
It's going to drop from level 4 feet. Those are
Which
elevations.
is lower.
Those are elevations.
Actually, Terry.
Level or
just pause for a second.
Yeah.
What he's trying to infer, and Blue's not picking up on it, or not yet anyway, if they went out with an order level or something or other, and then measured every 100 meters, transferred that, and then measured next 100 meters, next 100 meters.
Oh yeah, that
they
one.
would not
Yeah,
get that.
yeah, I know the one you're talking
That's
about.
not the result they get.
No.
That's the trouble. Is they're not going to get the.
Yeah.
They need to get. Then that's the problem. Is they don't understand that. You're assuming that it's all the same plane.
Yeah.
So then if you did that, you would not get that result. So
yeah, the curvature isn't linear, so you're not going to
Yeah.
get. So yes, if you move every 100 feet, yes, you'll only get 4 feet of drop. But if you measured 200 feet, you're not going to get 8 feet of drop.
Yeah, so he's gonna if he went out and did what he said he's going to do, he would not get the same result.
Yeah.
But what Blue needs to point out is it's got nothing to do with that. It's just the distance from the pad to the tube.
Yeah.
And that's the difference in level we're talking about. And why does that difference get bigger as you go down the tube?
Yeah. Why is the tube higher off the ground at one end than the other?
Yeah. If it's either the tube is curving upwards, or the tube is straight and the Earth is curving downwards. It's simple as that. It's either one or the other.
Yeah.
Yep.
And since they believe the tube is straight because they've got a nice laser level in there, then it must be the Earth curving. Anyway, that's where I think Blue's getting trapped.
Yeah. If I'm looking straight out, if I'm looking horizontally, if I establish a horizontal, would level be above it or below it?
Oh my God. You know
Yeah.
the model
What?
as well as I do. Don't ask
But you keep
ridiculous
saying
questions.
that level, it would drop more from level.
These are elevations. Those are levels. Elevations. See what it says?
From level, from your
Yeah, I see
tangent
it.
point.
I'm
Pad
looking at it right
elevation, not pad horizontal. Pad elevation.
Mhm.
Those are elevations.
So I'm asking you, I'll ask again, because I've asked it probably 6 times already. But if I'm looking out horizontally from an instrument, is level going to be above that crosshairs or below the crosshairs?
Well, as Bill showed us, level is going to be below the crosshairs.
Okay, so you're saying that the level drops below horizontal, right?
It always
I just
does.
want to be clear. Huh?
Yeah,
It
because you're
always
level
does,
with
yes.
the Earth.
Yes.
It
I like
must.
how you put the qualifiers in there like that. Always does. Well, you say it does,
Okay,
and
it
I'll
does.
agree that you always say it does, but does. you
Okay,
know.
it
Anyways,
does.
so-
Well, all right, I retract always. It does, Mobius. How's that? You like that better?
It's not different. Anyways,
Oh, now.
So-
now I answered it wrong, right? Okay, thank you.
so
Wow.
the water level, the level will drop away from the horizontal. That's what you're saying.
Yes, it does.
So there's no,
Not even happy when they
Hump.
get what they want.
Hump.
there's no rise
No,
in
It's
elevation.
not a camel.
of course
The
not.
water level.
No.
What? No, that's not
No.
how it works.
I agree. It wouldn't.
What
I don't
what
think
is
it's
it
always-
with flat
Horizontal
earthers
is
and the
is
hump?
is a tangent
Yeah.
at that point.
They've got a hump
curve
in
always
their
has to drop
brain.
away from that tangent point. Always.
I know you like
That's
to
geometry.
intermix the two terms, horizontal and tangent, and I know that is like
Plebs do. They always do.
in your model.
Yeah.
But it always draws me back to a plane being made up of at least 3 coplanar points.
Mr. Rock,
And
the plane,
each
the
point
plane.
has a perpendicularity to it, right? There's a perpendicular relationship within that entire plane. How can you determine
Yes.
where vertical
But they're tangent.
is if vertical is only at one point of that horizontal plane?
You have to know
The tangent point.
tangency of the plane. That's all. That's
Okay.
nothing.
So speaking of simple, if we can go back
Speaking of
to
simple.
And a water level, by the way, doesn't
Straight
establish
wall.
the plane. By the way.
let's say
Now you
We're
shouldn't
water
talk
level,
about
just a moment.
yourself
Let's
that
be-
way.
Let's be clear about something too. A water
That's-
level cannot establish a plane.
What?
With just 2 points.
people do it all the time. What do you?
With just 2.
what are you
No,
talking
no, no, just pay attention. Just
You
with
move
2
it.
points, you've got 2 endpoints of a water level. That's the water level we're talking about. Just those 2 points.
Yeah,
That does
you
not
move it.
establish. That does not establish a plane. That could establish a line, if at best,
You move.
and an infinite number of planes that rotate around that line. Now you move the water level to another point, and yes, okay, if you take the first point you were at and move the water level to another point, now you have 3 points that will establish a plane.
Mhm.
But if you move that water level again, you have just generated another plane, a different plane, not one that is parallel to the one that you just made.
If you move it again.
Yeah.
Move what?
Yeah, that's what you're saying.
Move your water level.
If you just move it along.
Okay, so
like
you have
can't
one
do
point
that.
that's stationary. You
Okay.
fix it to a post,
Got
right?
it.
That water level is right there. You've got your other end of the tube.
Okay.
You set it up. They're even. You make your mark.
Yep.
You put your thumb at the end of the tube so that there's no like air disturbances and stuff like that. You get a quicker, more accurate read.
Pause it real
after
quick.
you move that
You
end
put his
that you
thumb
got
in
your
his ear.
thumb on to another location, another
What
post.
are we going to pause that for?
So somebody needs to make a water level for flares that is three points in like a triangle instead of in a line. That way they can establish their plane.
You take your thumb off, it bounces a little bit, it settles, you make your mark. You put your thumb on there, you walk to another post. You can build a deck with 4 posts. A deck, a horizontal.
Here comes the deck again. The deck.
You'd only need one water level set up to build a deck. You wouldn't need to move it. Oh, unless you're moving it to the other corner if you want to get it to do it that way.
Level.
You're not building
Deck.
a deck here.
Nah.
Using this technique.
Yes, I agree with that. You can.
Okay, so you can establish a horizontal plane
But
with a
you've
water
established-
level.
You've established at least 2 different horizontal planes doing that.
4 points.
You've
all
established at least
on the same
2.
plane.
No, 2
Yeah.
different. You've established at least 2 different planes when you do
It's
that.
one deck.
It's a deck. It's only a deck, Mobius. Do you know how big
One
the Earth
deck.
is?
It's one deck.
Has anybody told you how big the Earth is?
Do you know how big the
One
deck
deck.
is?
Yeah.
Yeah, how big's your deck, Mobius?
Principles. Here.
Absolutely.
Yeah, somebody asked Mobius how big his deck is. I would have loved to have been on the live stream. I would have been blurting that out if I could have.
I don't know why you want to go into the imagination
It's a deck.
when we're talking
I
about a
got-
deck.
okay.
You're saying 2 planes. I'm saying it's one deck.
All right, let's make the deck about 10 miles on each side. Can we do
Let's
that?
just
Well,
make
that's a
it.
big
Let's just make
deck.
it whatever. I'm talking about the basic principles
Okay,
involved
I
in
am too.
making it.
I am too.
And where are your fundamentals based on?
I am too. Let's talk about this. Let's talk
Are your
about the 10
fundamentals based in imaginary?
Let's talk about this
or
10
are
mile
your,
by
are your
10 mile
fundamentals
deck.
based on practical application?
Well,
Yeah,
based on
let's
practical
build a
application
10-mile
and everything
deck.
We can observe in
So
nature.
so show me a 10 mile wide, 10 mile long deck. Show me one anywhere. Point to it on Google Earth. I'll look it up right now.
We're gonna have plumbing issues with that.
I asked you to be practical, Lou.
I'm trying to be practical. I've shown you.
So why are you
shown you.
asking me to
shown
imagine a
you.
10 mile long deck?
Well, why are we going down this road? I've already shown you.
Because I'm trying to establish.
I've already
fundamental
shown you.
You
the
brought up
drop-
he brought up the deck, and now he's going to re-argue back to Blue about the deck when he brought the deck up in the first place.
Yeah.
He's been doing
Yeah.
that with everything. Brings something up, and then when Blue uses it against him, no, wait,
Yeah,
bring that
yeah,
up.
exactly.
from horizontal using Bev's photograph. What's the problem with that?
Drop.
Yes, absolutely
You,
did. 100
you,
feet.
you explained your
100
interpretation.
feet of it.
You didn't show me shit.
Then give
you
me
explained your
another interpretation. Tell me another
I'm asking you to
interpretation.
stick. I'm asking you to stick with basic principles.
I'm not going to
You
go
can't do
anywhere
that.
else. Listen, until you explain to me, give me another explanation for why Bev's photograph shows what it shows, and we're not going any further until you do that.
What is this a cop out? Because I'm not Bev. You were on Bev or over at the Discord talking to Bev the other day. I was not in that conversation. I listened to it. I was able to hear it, but I wasn't part of that conversation.
I showed you a picture that clearly shows a drop from horizontal. Now, I want your explanation for why that happens. If it
I'm
is
gonna
not
ex-
Earth
I'm-
curvature,
Why not
what
answer
is
the
doing
bloody
it?
question?
I'm going to say this again. I've repeated it over and over again already, but I'll say it one more time. And if you're not happy with it, then if you want to leave, that's up to you. You explained your interpretation of an observation. Period. End of story. I don't know why you came up with that interpretation. It's not me to It's not on me to determine an interpretation that you have. I'm not going to argue with your interpretation because
Okay.
I'm not trying to argue opinions about shit.
Give me another one then.
I'm trying to talk about basic fundamental principles.
All right,
Again,
so give me another explanation
Okay,
for
so
why
this water
something in
level,
the distance drops 100 feet. Just tell me why. Why would I be able to look through? And it's not just that picture. It's lots and lots and lots of them. But why can we look at an object in the distance and clearly it is below this horizontal that you talk about? Why can we do that? Why do we always see that?
Why don't you ask George why he's got a picture of a level above the crosshairs?
Because he was trying to show that. That's why. He was trying to show why you don't make those kinds of observations at sunset. That's why.
So, okay, well, I don't know what to tell you. That explains everything. There's really nothing else to say. I mean,
that was an entire video.
You're telling me,
how does that
explain
everything?
It can't happen because, you know, somebody went out and made a video about how this is why you don't do this. Well, no shit. You don't take long distance measurements over water. How can you establish a horizontal over long distances over water?
But this isn't over water.
You're saying that's not what you're...
He can't explain
I'm saying that George proved that that's, and I'm using that word very strictly, proved that you don't do that, right?
Yeah, George proved that there are certain times of the day when you don't need to be taking observations.
Like any time of the day, those kind of observations are unreliable for accuracy. I mean, come on, Blue, you're an engineer.
Well, Mobius, when you do a video to try to show people...
I missed all that because I had to answer the telephone.
Oh no!
So what did I miss? I don't want to rewind it.
Blue's just trying to force Mobius to give an explanation of why there's a drop in Bev's picture.
Oh, the tower,
and he just won't do it.
He won't go there.
He just won't do it.
Yeah.
Where are we up to? We'll do another jump, see if he gets into anything. Oh, here we go.
I like 3 hours in and we still haven't made any progress.
Yeah, 3 hours 48 we're up to.
Amazing.
We'll bring that back
I mean,
a bit.
look at the picture he's got up on screen there, right? Like he's trying to argue that this picture proves the flat Earth, where Blue's saying, "Look, Bev's taken this picture to prove the globe yet again."
There's that big chunk at the bottom missing.
Okay, we'll go from there.
Tell me if you're seeing Blackpool or
This is
not.
the video Blue made a while back.
I may have to stop and reshare.
I'm still seeing the LIGO Hanford
Okay.
graph.
Let's see. Stop streaming. And now let me go back again to this one. Here we go. And now you should be seeing Blackpool Tower. Let me get over to the picture in question. This one.
Oh, hey, this is that same presentation that you used, right?
Yeah.
Oh, can you, I don't know if it's forward or backward, but real quick, can I just see if you have it on this still? There's an image where it shows I don't know, some instrument, and it shows the horizontal reference.
Hang on. That one?
No. Maybe the next one.
Well, let's go back one more.
That one's on reciprocal.
That one?
Over there.
No, it's like a regular something.
That one?
Oh yeah, that one. That one to the left right there.
Okay.
You see where it says principle of differential leveling?
Yep.
Help me understand how you process this in your mind, because I'm reading it. I'm seeing it says differential leveling provides a means of accurately measuring height differences between points.
Well, that's something that you could use in principle for building a house on a hill. If you want to get the foundations.
Yeah, that's short distance, like where you know the elevation is different in two locations, and you're trying to figure out.
Well, I did this with the water level here, when I explained before about doing it from one point to another, because I knew the land was on a slight slope, and I needed to know that on the left side of that image, I needed to know the elevation of what the house was, the piers, where it was going to come to from the right-hand side. So I needed to know that.
Yeah, that has nothing to do with curvature and
no.
You know, the drop that you see.
No, I was using it as a tool for elevation differences. That's all I was doing.
Some tens of meters apart. A level is set up on a tripod and leveled so that the line of sight is horizontal.
Yeah.
Yeah.
In each of those leveling rods are plumb
at that point.
Right.
And perpendicular to that horizontal line.
Yeah.
which is established by the level.
Yeah.
Okay. All right. I just
So
wanted to
what's
be
your
clear on
problem?
that. We can go back to that picture if you want.
And
Well, because he's
and
gonna
what they
try and
picked.
claim that
And of course,
that is the same as like what's going on with LIGO, and it's not. That's where he's trying to lead with that.
oh, okay.
for tens of meters, you would never detect. You'd never be able to really detect any deviation from vertical between two rods that close together.
Never be able
Of
to
course.
detect it. Okay, got it.
Of course,
Let's
you
go back to
wouldn't.
that picture.
And they go ahead and explain all of that, but let's see. I wanted to get to something.
Well, you already said that you would never be able to detect it, so that's fine.
But that's a follow on to it where they talk about.
Is that the part that they would never be able to detect, or is that something else?
Yeah, people talked about this because they exaggerate the drawing, so that in actuality, if that was to scale,
That's not to scale.
this auto level would be thousands of miles away from that rod. Okay.
I mean, that
Yeah,
would be
Fliffers
ridiculous.
love little drawings
Literally
like that
thousands, but it's
because
just a
they
depiction,
think
but
that's reality.
What's interesting is
So
for side
which
lengths,
part is the
this part
actual?
this part's the part that's interesting.
Yeah.
For a sight level of 100 meters, the effect is only 1 millimeter. As with collimation era, the effect is eliminated by using equal sight lengths for foresights and backsights. That's how differential leveling works. And that's why we do it.
For what?
And that's why we do it.
What was it? 1 millimeter over 100 meters?
Yeah. That's all Earth curve would do over 100 meters is a millimeter or less.
So how did they come up with that number?
How did they come up with that? Well, you can calculate it, number one, but you can measure it too.
Well, that's what I'm asking, how they measured. Obviously, you can calculate it, right?
Yeah. But you could easily measure it.
Prescribed, with prescribed values.
What you guys could actually do.
Talk about basics.
What you guys could actually do with Bez's test, with his realizing Euclid bullshit, you could do the same thing.
You can mute that measurement. Time, right?
Yeah, I know. I haven't done it though.
No, I know, but I feel like when I'm trying to say something, you start talking again, and then it's just both of us talking over each other. So instead of, allowing me to speak, you can always mute me and say your piece.
No, I don't want to do that.
So that what you're saying will be clear for all the listeners. Did you want to go back to that? I thought we were talking about that picture still.
You want to go back to that?
Well, I wanted to ask you how they measure it. That 1 meter or 1 millimeter over 100 meters, like you said that they calculate. I said, yeah, within prescribed values. Obviously, you can calculate whatever within prescribed values.
No, not with prescribed values.
The value in
you
the first place? Like,
take the values and you.
How do they measure that 1
Yeah,
millimeter?
then you calculate it.
Meter difference.
Well,
yes, if I make up random numbers, I can make a calculation, but that's not what we do.
We've told you guys, I don't know, a few thousand times now, that it would be quite easy for Bev to do this with his realizing Euclid test. You could do this. You could use a water level, and you could use a theodolite, and you could line the water. You could put a tap in the center of it, and you could actually measure this. You actually can.
What, 1 millimeter?
Or you could actually do it with a single water level without a tap in it.
It says
you could see that difference.
Reading. Can you blow it up a little bit? It looks kind of blurry. I don't know. Just to the right there where it says refraction.
Oh, refraction. Okay.
Yeah. That's over there.
See where it says it's got the dotted line and then it's got the actual reading?
Yeah.
So the actual reading, is that what you're seeing through the scope?
Yeah.
Then how do you know where that dotted line goes?
That dotted line is the horizontal that's been established by the auto level itself.
But the auto level is reading where it says the actual reading.
Mm-hmm.
And the desired reading is, the elevation, the equal elevation from the instrument, it looks like right there, right?
That's because of refraction. Refraction
right.
raises, actually helps you guys out.
So I'm asking you, how do you determine where that dotted line is so that you know that difference from the dotted line to the actual reading, so that you know that your actual reading is lower than the horizontal established at the instrument?
How do you know where
you don't need to.
How do you know where the dotted line is?
Yeah.
That's established at the level itself.
So, but if you're looking out through the level itself,
mm-hmm.
Are you seeing where the dotted line touches that
see over
stick,
here?
or are you seeing where it says actual read?
You see here.
Depends on
That's
the
not over 100
refraction.
meters, so the other one was 100 meters.
This is over 100 meters.
Where's the dotted line in that one?
It's this line right here. That's your actual reading.
It's without.
You'll actually
refraction.
see that. You really would want to. You want to see this, which would be the same elevation above that surface, but you don't.
So S is 100 meters there. What about the other picture? It said S. Was it? No, it didn't say S. Where did
Doesn't say anything.
What's it say there? So what's that say? What's the difference there?
Same.
The variable density of the Earth's atmosphere causes. You keep moving that thing.
Okay, I'm sorry.
Variable density of the Earth's atmosphere causes a bending of the ray from the staff to the level. The effect is illustrated in the sketch below. So how do you know where horizontal is if it's somewhere above the actual read, like what you're reading?
How do you know what horizontal is? It's that line. It's the same line. This line, actual reading.
Well, it's depicted differently.
Over
Like the
here
same
it's
thing is depicted differently in the two
yeah,
images.
Yeah, it's depicted differently because it's
So how do you know that you're?
because it's
how do you know that
depicting
you're getting
refraction.
But how do you
Because
know
of
on the
refraction.
stick? How do you know on the stick, like if it's accurate or not? Because your actual read could be different than the horizontal, or it could
It
be
is
the
going
same.
to be. Yeah, it
Or
is
it could
going
be
to
the
be
same.
because it is going to be because of refraction.
Well, the other picture depicted it as the same as the horizontal.
Well,
Your
I'm
actual
sorry.
read.
I'm sorry that these thoughtless bastards decided to break it up
No.
into three sections for you, but they did.
They're explaining it in different detail, and he's confused by that.
Differential leveling eliminates the curvature
Step
problem.
one.
It
Yeah,
also
step
when we
two.
add in refraction.
As well as collimation errors.
It's like saying when you get a piece of IKEA furniture, you just get shown the picture of the furniture, not all the steps it takes to build the piece of furniture.
Or saying that step one doesn't look like what you're trying to build. Well,
Yeah.
why doesn't step one look like what I'm trying to build? Because you're not there yet.
Yeah. Well, you can start off with step 10.
Try.
Is that what that is
Equal
up there on
foresights.
the top left, the collimation error?
That's the collimation error, yeah. And if you do
So-
equal foresights and backsights, you eliminate collimation error.
Is that with the theodolite, or is that with the
That's
auto level?
just an auto level, or it could be it could be either one. Wouldn't really matter.
So
would it?
what's that say? Over 50 meters, the effect is 5 millimeters. If the sight lengths for backsight and foresight are equal, the linear effect is the same for both readings. Oh, that's a big difference over 50 meters. 5 millimeters.
Well,
So
that's
you're going to be 5 millimeters off from
it's
horizontal.
they're giving you an example, Mobius.
Would you be
hopefully-
reading above
hopefully-
horizontal or below horizontal?
It could be either way, couldn't it? It's collimation error. That could be above or below, either way, couldn't it?
That would be really confusing. Like, how do you know which one's the horizontal?
It's just it's just an example that they give you, and they count count on the.
I'm just
idea
asking,
that
like in real
maybe
world.
you've got a
example,
little experience to go along with it, but if you don't, for a typical collimation error of 20 seconds, over a sight length of 50 meters, the effect is 5 millimeters. They're just making an example for you. What if the collimation error is 0? Then there's no error.
But how would you know if it's 0 or not?
Because you sighted.
How would you know if it's 0 or not? I got to think about that.
Because you're trained in the
but this is
field
one of the
and you
reasons why I
know
do-
how to
why,
check for it.
Why guys do differential leveling.
No,
When you do
I
that,
understand.
you don't have to worry about it.
I understand that, and like I said earlier, this is what I was getting at. You obviously understand how differential leveling works in the process. So asking me to explain it step by step is just ridiculous. But anyway, you want to go back to your picture? I don't know. Are you
Yeah.
done
Go
with
back to
these?
the picture. There we go.
Yeah, optical
There's the picture.
difference, not geometric. Yeah.
No,
was
Bill
thinking
objected
that.
because this picture, this came from Shaky, by the way. I didn't put that in there, but
Oh, Chaiki is awesome. He
did.
actually has a lot of really great pictures. Did you see his horizontal his parallel horizontal picture?
no, I don't think so.
Yeah, he's got a great example of parallel horizontals, which incidentally also show verticals perpendicular at every point along those parallel horizontals. It's really spectacular. You should. Well, did you leave on the level, or are you still there?
Somehow I
I know you
doubt
left
that.
Geo's, right? I guess
I'm still
you
over
had some
there.
drama or something.
I'm still
Anyway.
I'm still in Biz for the moment, but I'll probably be leaving. That's the picture that we're talking about, and that's the question I've been asking you. You can see You can see through the auto level there's a horizontal crosshair. I've got that white line stuck on top of it, but it's right there. You can see it right at about the top of Bev's head. And there's a point on the tower, on the actual Black Pool Tower itself, which I used actually. If you go into Google Earth, you can actually get some elevations. I realize that that's not the most accurate way of doing it, and I'm looking for an actual drawing of the tower. But
you know what? I don't have it handy right here, but I did put some models in Blender with Google Earth values of various things. It was pretty interesting.
Yeah, I wouldn't count on those elevations being any closer than maybe 5 meters, but something like that. But they're probably that close. At any rate, and that makes sense because the top of this 440 feet above sea level makes sense because the top of that flagpole up there is 519. So you can work out all these ratios and say, well, okay, that's about 440. And the top of this building is also very easy to pull off, which is the roof of this thing over here. Is also easy to pull off. And the crosshair is sitting right on the roof of the building, which is about 100 feet above sea level. Now, clearly, it sits right on the beach, basically. Down here is the beach level. You could say Bev's elevation is somewhere in there. I don't know where exactly. But still, that crosshair is parked 100 feet above sea level, more or less. How can that be?
How can the tower be 400 feet above sea level?
How can the roof of that building be 100 feet above?
No!
Be above 100 feet above sea level, but this auto level is showing level to be right at the top of that roof. How can that be?
Duck, dodge, dive.
This is why murders happen.
Bev's feet are at the bottom stadia, and his head is at the middle stadia, or at the crosshairs, and then the top stadia. I mean, it shows him being 400 feet.
Huh?
It's a image. It's a flat image.
What do you mean? You're
going to give
400
feet. Values to something that.
No,
4 hours in and we're still at this.
Bev's feet are at the lower stadia.
Yeah, Blue said he needed to go and take some drugs after this.
I don't know how tall he is. I know he's not 300
I
feet.
believe him.
Of course not.
Man deserves
We need to know
some.
what Bev's height is, and the distance is roughly half of the stadia distance.
I'd say Bev's 5 foot.
So it's roughly
he couldn't be
half of
tall.
that. Let's say from that stadia
Probably like
tick there
5,
up to the
7.
center, up to the
you give
line
me
here,
credit for
because
being
that's right at the
taller.
top of his head. Let's say that distance is 5 feet.
Stands next to stuff all the time. He's what, 1.6 meters? Something like that?
Multiply 5 feet times
Yeah,
100.
I'm
that's 500 feet,
1.89
multiply
or
times 2,
somewhere up there.
because you're only using half of the interval. That's 1,000 feet. Bev was about 1,000 feet away.
From what?
From the instrument. That's how you use stadia. That's how it works.
To measure the distance.
Yeah, it's a stadiometric distance measurement.
Yeah. I did that with my auto level. It was kind of weird because it gave, I took a tape measure to double check, and it was off at a fairly short distance, which was surprising because I thought that it would be more accurate at a shorter distance. But
it just shows you don't know what you're doing.
Exactly.
This seemed to make sense.
I was going to say,
340
what was your methodology?
I'm just saying that.
Either that or
here we go. 340 feet.
That's why they have the stadia things up
which is
there.
the horizontal to that upper stadia tick. That distance at the tower is 340 feet.
Here's my contention about
times
this.
100 times 2.
Okay, go ahead. Like I said, you can mute me anytime.
Times 100 times 2. That's 68,000 divided by 5280 is 12.9 miles. Bev said his auto level was set up at about 13 miles away, so it absolutely works.
Yeah, I'm not saying that that it doesn't
Oh
work.
no, I'm not
saying that it
6'3".
does work. I'm just saying
I'm
that
just a
my
tad over
contention
6.
is that sometimes it works. Sometimes
I
it
could be
doesn't work.
shrinking. I'm
Sometimes
getting
it's
old,
accurate,
John.
Sometimes it's not accurate.
Well,
I noticed how he
these
said
things are
that,
used all the
but
time.
So what are you looking at here that I should be in awe about?
Well, what it shows you is that the building has dropped by something like 95
I like that
feet.
he keeps ignoring that fact.
Assuming
Yeah,
that the-
exactly.
Yeah, it had to. Assuming that
How did
assuming that the
Well, he's
auto
got the
level
crosshairs
is
lined
sitting at
up.
about a 5 foot elevation.
Right.
And its center line of its crosshair in that
It's right
over that
there.
distance is now up at 100-foot elevation. That means
I thought
that
you were
this
just measuring the distance.
that means that that point
Point of
on
the
the tower
tower.
has dropped 95 feet.
God.
How did that happen? Why
Are you
is
saying
this?
that?
Why
Are
is
you
this
saying that you
horizontal?
have?
Why is this horizontal line not down there 5 feet off this beach level?
Wait a minute. Are you saying that this is an established horizontal?
That's what an auto level
Yes.
Oh my
It's an auto
God.
does. It
level.
establishes a
You can look
horizontal
at it, but it's
plane of
not
reference.
horizontal.
It's a horizontal plane of reference.
Did you say
So
level?
that was a question I asked Bill. Did you miss it? Did you fail to set the auto level up properly?
It's like using the
Is it not
tower
adjusted
as the
correctly?
stick.
Is that the explanation?
I wouldn't be able to speak for
If
Bev,
you
but I
had a
can see
stick
Bev's
out that
not
far
at the
away.
auto level in that picture.
Yeah.
Yeah, he's not. That's right. Somebody else is making the picture.
And,
But my question is,
I mean,
whoever
I'm
set it
just
up here,
saying-
that's the real question.
You could stick big letters all up that tower, and then line it up with each corresponding letter at whatever feet altitude the measurements would be.
Yeah.
Whoever set the fucking thing up, did they set it up correctly or not? If it's not, if it's not
You're
set up
asking me about
properly,
a picture
then yeah.
that I wasn't even there, and you're asking me what Bev did. Well, Bev's in the picture.
I didn't do it, so it's not my fault.
And you're using
And it doesn't matter if Bev did it or Joe Blow did it. We're looking at the image and the results of what we see from the image.
But you weren't there, so you can't prove it, right?
Oh shit!
Yeah, you were no, he wasn't there, so it's not his fault.
I've never seen Bev in real life. He doesn't exist.
Oh, okay.
This is proof or something, or I'm sorry, evidence.
That's evidence that of Earth curvature. Yes, it is. Absolutely. Absolutely.
And so far, the only evidence that I heard is that it's evidence of how tall that tower is, and how far away.
Yeah, and
far
what
away
at
you
what
are
point
from
of
the
that
tower.
tower, and that point of the line.
Keeps it
Yeah,
good.
he can't see it.
He's avoiding it like it's the plague.
Yeah.
Well, no, I can't say that. Flurfs don't believe in germ theory, so they don't avoid the plague.
I can't see the forest for the trees.
Why is that line lining up with something that's 100 feet above sea level, and I'm standing at about, I don't know, what we reckon we're about 6 foot off the ground?
What are you talking about, Terry? That tower is 440 feet tall.
Okay.
He's talking about the
using
building
Stadia
there, though.
as
The
a-
building's 100 feet above sea.
Yeah. Below the tower.
Distance.
Yeah.
You're not using the Stadia.
No.
as an elevation.
Hang on a second.
Or
Hang on.
as a
Speak like
Hold the
Morbius.
phone. I'm not
Yeah,
doing
go
that at all. I'm not doing that at all. I'm just showing you.
So where's the
that-
horizontal?
I'm just showing you that the Stadia marks comport with and agree with what Bev said his known distance away was. That's all. That's not part
That's
of
it?
it. That's just a way to show you
Get-
that the auto level is.
Yeah, Harry?
Yeah, guess what the drop is at 12 miles? 96 feet.
That's pretty damn close.
Yeah, it is.
Yeah.
Is accurately representing what it's seeing off in the distance in terms of its ability to give you a stadiometric distance.
Right.
That's right.
That would be like a horizontal distance.
What message did
from-
you
horizontal
retract,
distance.
John?
But the
Right.
point is this: that's what we see. That's what you ought to see. Why don't?
Oh,
we
it
see?
was about that middle line.
Do you agree
being,
that the auto level is sitting on a
sea
beach?
level?
Well, it looks like it's in sand. I would assume
Okay.
that it's at the beach.
Yeah.
There's
You
the
agree?
ocean right there. It's an ocean side.
Yeah, they're pretty
park.
close to sea
Yeah,
level
you
where
agree
they're
there's an
standing.
ocean that's running parallel to Bev here, all up this left side where I don't know where it is, but there's the
Parallel.
ocean. There's the ocean.
Yep.
Okay.
Yep.
And the auto level is only 5 feet above that above this beach. So
I don't
call it
know.
whatever you want to call it. I mean, how
I
you
mean, the
want to
thing
say
could be
it is.
sitting on the ground. I don't know how tall the auto level is just
Okay,
by looking at
all
this
right,
picture.
yeah. Hey,
If you've got extra information, then please share it. So far, I'm not hearing any information as far as the auto level, like how it's set up, if it's even establishing a horizontal. You can look through an auto level without it being level. It's not like it turns black, right? It's not digital or anything.
well, Bev didn't contest any of this, so I don't know. Maybe
Did he
we'll go with him.
confirm any of it?
Did he confirm any of it? Yeah, absolutely.
What did he confirm? That he's in the picture?
Confirmed he was 13 miles away from the tower.
What would be the whole point of
So he
confirmed
the?
that,
confirmed the distance that you
What
can
was the
tell
whole
with
point of
the
the
Stadia
auto
model.
level if you
Yeah.
didn't set it up right?
Okay. What's that got to do with? any
Can you
curvature.
Yeah,
not
we
see-
assume he had it set
You
up
can't see
right.
the top of that building, and you can't
I can see
understand
the
what the
top of the
problem is, huh? If that thing is
Why do you
establishing a
spell it out?
horizontal, if that thing is establishing a horizontal plane of reference,
It's a big if. I mean, your whole argument depends on that if. So,
well, okay,
do
all
you
have
have an
so
answer to it?
I see where this goes. All right, no problem.
I'm just trying to ask you to be
I
honest.
see where this goes. I'm asking you to be honest, for God's sakes.
I am honestly
You're
telling you,
looking
I
at a
cannot
picture.
confirm nor
You're
deny
looking at a
if that auto level
picture.
is horizontal.
You're looking at
If
a
you want me to
picture.
lie, I don't know what you're asking me.
Okay, let's make this assumption.
I wonder
then.
when if we'll ever
Let's
be
assume
honest.
the auto level is adjusted properly. Let's say that the auto level actually has been set up the way it should be.
Oh my God.
What would
So
in
now we're
that
going to
case?
assume so that you can get your way?
In that case, what would that picture tell you? Let's see how honest you're willing to be.
In what case?
If the auto level is set up correctly, what would that picture tell you about the tower in the distance?
Yeah, why is the crosshair so high,
Well, it
high
wouldn't
up
tell
on
me
top of the
anything.
building?
'Cause, I mean,
Where's the
can't
rest of
measure
it?
You can't even see the rod. You can barely make out that he's got anything in his hand.
Hey, he's not going to answer.
No.
You can't see the rod, but you can see the
You're
building.
trying to equate
The rod
these
is not
crosshairs
visible.
line up under the assumption that the
What
auto
building?
level is set horizontally.
Okay, so your claim is the auto level is not set up properly. Your claim
No,
is
my claim
that the elevations
is
of
that I don't
LIGO
know.
can't be
Why
trusted.
don't you get
your
my
claim
fucking
is
claim right?
you don't have a fucking clue what
Why
you're
don't
talking
you get
about.
my claim
That's
right
what your
before
claim
you tell
really
me what
is,
my
right?
claim is? If you don't want to play honest, then just let me know.
Hey, you've been nothing but dishonest since you got in here, Mobius. Don't
How
start
so?
that
By
bullshit
telling the
with me.
truth?
You're not telling the truth. There's
You're
nothing
telling
truthful
me
about
that
it.
you're telling me that I know
I asked
how
you a
that auto
specific
level is set
question.
up?
I asked you a specific
Oh my God, Blue,
hypothetical,
come on,
and
dude.
you won't even answer it.
I hope you
You're
got a
not
better
even
argument
honest
than
enough
this.
to answer that, Mobius.
I hope you
I
got a
said
better
make the
argument
assumption
than
that the auto. I'll try it again.
I hope you
Make
got a
the
better
assumption that the
argument
auto level is set up correctly. Make
You
that
don't have to get
assumption,
all
and
upset.
then tell me what that picture would tell you. And you're not even
Would
honest
tell me?
enough to say that.
You want me to tell you what
You
that
won't even
picture
do that.
would tell me?
Yeah.
Under the assumption?
Are you not capable
Well,
of assuming anything, Mobius?
I prefer
You assume
not
that I'm
to,
wrong.
honestly.
You don't have any problem assuming that. Why can't you
want me to be
assume that the
honest?
auto level is level? Huh?
You want me to be honest?
Yeah.
I have a problem relying on assumptions. I'm not going to make any claims based on an assumption. That's just fucking stupid.
Yeah.
If you want
He's
me
not gonna
to,
answer.
if you're demanding that I make a claim based on an assumption, just so
I'm not
that you
asking
can
you
say,
to make a claim.
I'm right.
I'm asking you to
I
tell
don't-
me what
I
that
don't
would
think that's
tell you.
honest.
Okay.
Well, if you want to keep being dishonest, that's up to you. I don't
Look,
care.
stop it, Mobius.
Dishonest.
I'm not
Well,
being
well.
dishonest. You're the one being dishonest.
You're telling me to,
Now,
to
look,
rely on an
I have asked
assumption
you.
to
I've
make
asked you a
an
simple
interpretation.
question. If
telling me to
if
make
the
an
assumption,
interpretation
I've
based
asked
on
you
an
to make an
assumption.
assumption
Oh
and
my
then tell
God.
me what that would tell you. Can you not do that? I realize you're caught here.
I'm not caught with
Oh
anything.
yeah.
How am I going to give you any?
They
You're
can
right in
only
the
do
corner.
that if it supports them.
Yeah, exactly.
And it's
Yeah,
based
yeah.
on
If it
an-
supports them, they're open to doing that all the time.
Yeah,
Otherwise,
what do you do when you trap something in the corner and it
Desperate to
an
find a way out, and it's not
interpretation
going to happen. I'm
off
not
of
letting
an
you out of the
assumption.
corner.
Are you hearing me?
Yeah, I'm hearing you.
Are you hearing me ask you how I'm going to give you any information from an interpretation based on an assumption? I'm asking you honestly. Do you expect some real information from that?
I expect an honest opinion. I expect an honest answer, and you're
Are
not
we
capable
arguing
of doing
opinions? Is that what we're doing? We're
You're not
talking
get-
about opinions?
that. I'm asking you to tell me what this picture
God,
would
I thought-
tell you
I thought
if the auto level is level.
Sorry,
You
Blue,
haven't
I had
proven
higher
that
hopes
it's
for
not.
this conversation, man.
I did too, Mobius. But you've
I
done
did
nothing but
not
run
know-
from the question from the beginning.
deflect.
did
Are
not
the
know
elevations at
Keeps
LIGO
deflecting
accurate
all
or
the
are they
time.
not?
Require me to imagine shit that isn't real so that I can make assumptions based on it.
Are you can't answer even the simplest of questions with any honesty whatsoever, Mobius. Are the elevations at LIGO accurate or not? You refuse to answer that.
If Santa is real,
if the
I
auto level,
might get presents this Christmas.
if the
I
auto
don't
level,
know.
if the auto level is set up properly, and I would make the assumption it is because Bev claims to have a certificate. I would claim that you are being dishonest by not telling me what that picture tells you. That's what I would claim.
Well, I know what you would claim, and I know why you would claim it.
I don't care what you don't know what I'm claiming.
I know exactly what you're claiming. You're claiming that this picture tells you some information. And you've got all these calculations next to it. Look at all these numbers, all these different calculations you got next to it. You've put a lot of thought and effort into this picture. I mean, my God.
A lot of thought. Took me about 3 minutes.
I don't care how long it took you. You
Say
put
about
effort
5
into
minutes.
this. I mean,
he said a lot of thought.
That's not much effort at all.
It took a couple of minutes. Well, that's not a lot of thought.
This is me winning.
I like the effort it took for Bev to go out and set an order level.
Is it?
Yeah. Yes, it is.
Your picture with no
failed.
information.
He probably did this
miserably.
while doing something
well,
else.
You got to tell your boss to stop posting pictures that aren't correct.
Boss.
Yeah, Bev.
Bev isn't my boss.
Your mentor.
He's not my mentor. We're friends online. I don't know what kind of thing you got going on over
Well, he went over to Bev's and was bragging.
Okay, so I don't think there's any point in going a lot further with this, Mobius. You're not going to be honest about what you're looking at. You're not going to give me a straight answer about anything. You're just going to play for the rest of the afternoon. And I've got better things to do with my time.
Me too. I wasn't planning on talking about some picture that you want to, hang your hat on. I thought we were going to talk about LIGO, but I just wanted to get some.
Talking about LIGO.
Well, this is related to LIGO.
I wanted to get some basic, understanding, some common ground on basic fundamentals before we ventured out into making.
Oh, he wants to learn about it before he can make an opinion about it.
But whatever.
Nobody's calling
it. Is what it is.
Are you calling this a wild? You still calling this a wild flame?
No.
You're still saying that blue line is a wild flame?
No.
You're still questioning the accuracy of those elevations? Are you?
What I'm saying is that you are claiming that the fact that these elevation values, you're claiming that aren't based on.
I like RT 96's Doc. If this X-ray shows a fractured leg, does that mean my leg is broken? Doctor, I won't make any assumptions.
Hypothetical reference model. I'm claiming that they are based on a hypothetical reference model because
do you want to presuppose that you even have a leg?
They're based on.
You were talking about a benchmark.
No, I'm talking about I'm talking about the elevation data.
The elevations are measured on the site, Mobius. They're not calculated, and they're not based on anything other than that starting elevation, the project elevation. They're not
calculated?
Huh?
What do you mean they're not calculated?
That blue line represents actual measured elevations, Mobius.
But measured how? You don't know how they were measured.
I gave you all the ways that they could have been measured. Which one they selected, I don't know. But you can do that any way you like. You could do it with a water level. That would be pretty stupid, but you could do it that way. You could do it with an auto level. You could do it with an auto level if you wanted to. That would likewise be pretty stupid. I would choose a theodolite.
So no chord.
I would choose a theodolite.
Before you run off, I want to be clear. So no chord.
I'm not running anywhere,
right?
buddy.
Okay, good. So no chord line then, right?
What chord line? We're not talking about a chord line. These are elevations.
From one end to the other end, from 0 to 13,000 feet. If you took a water level and drew a straight line with that water level, it wouldn't be a chord cutting through a hump of water?
In this particular case, no, it wouldn't.
What would it be doing?
It would be a perfectly straight line.
With an elevation drop at one end.
That pad would be a perfectly straight line.
A chord is
not a chord, not a chord. A perfectly straight line.
I'm sorry, are you saying that a chord in geometry is not a straight line?
No, I'm not saying that.
Okay, so a straight line then?
Yes.
A chord.
Not all straight lines are chords.
No, but all chords are
straight.
Thank
you, Blue.
All straight lines are chords.
No, but all chords are straight.
You're saying that all chords are straight lines and all straight lines are chords.
For the fourth time,
that's what you're saying.
All chords are straight is what I'm saying.
Well, yes,
why do you reverse what I'm saying to make it sound like something that I'm not saying? I'm clearly saying that all chords are straight, and you keep saying, so you're saying something totally opposite of what I'm saying. It's a weird tactic, Blue. You do it all the time.
Yeah, no, you seem to be confused here.
I don't know if you do it on purpose, if you were brought up that way or what, but it's just weird.
In this case, it is not cutting through any part of the earth because that thing is flat, straight.
What is this? The line between the 2 points?
The pad itself.
Oh, I thought we were talking about if we took a water level from 0.0 to 13,000 feet, if it would be a chord.
And I answered that 5 fucking times already.
You said
it wouldn't
be a chord.
So what about Pontchartrain? I thought Pontchartrain, from one end of the Pontchartrain to the
other
other,
you're going to bring up Pontchartrain now.
Chord with like 90-some feet of water above it.
Pontchartrain's not a straight line. Pontchartrain is following the curvature of the earth. Pontchartrain.
So if I took a water level,
Pontchartrain Pontchartrain is an arc.
So
it is
from
an
one
arc
point to the
segment,
other.
Yeah, it's not
24
built
feet,
like the
24
LIGO.
miles long, and a cord line is applicable in that case, because Pontchartrain is not straight. LIGO's pad is.
So let's examine this for a second, if you want.
Mm.
Would that be all right?
Examine what?
Well, let's examine the differences here, because it's been brought up before. I'm sure your listeners would like to hear.
That's all right.
I'm waiting.
Don't you want to demolish me on this?
I'm waiting. Go ahead.
All right. So if I took a water level from one end of Pontchartrain to the other end of Pontchartrain Bridge,
yeah.
Would that be a straight line from point to point?
If you only have 2 points and you connect them, the shortest distance would be a straight line, yes.
Okay. So in between those 2 points, would the bridge and the water in between be above that straight line or below that straight line?
Above that straight line. And they are, and the GPS data shows it.
Great. So there's a rise from that point.
From the cord line.
Right, to the middle of that bridge.
Mm-hmm.
So you're at the middle of that bridge. What'd you say? It was like 90 feet?
Yeah, 90 feet.
Okay.
Call it that. Close enough.
From New Orleans, it goes from New Orleans, right? Is it New Orleans or what's the town right there on the south side?
What difference does it make what the town is?
And then it goes to Melville?
Yeah.
On the north?
Yeah.
So at the New Orleans side, we've got a straight line from point to point, which would be 90 feet from the surface in the middle. So would you say that the surface, the water in between, goes up or down from that cord?
You said it was
I've
up.
already answered that.
You already answered it, yeah.
It goes up, right? Just
I
so you
already
don't have
answered
to
it,
repeat
Mobius.
yourself?
I'm not going to repeat it. I've answered it once.
You're not even going to give me a simple yes?
Pay attention.
Or
Write
no?
it down next time. Yes,
Okay.
it goes up. Write it down,
yes, it
okay?
goes up.
Don't ask
I did.
me.
I drew an arrow and everything.
Write it down.
Okay.
Make sure to write it down.
Yeah, take
Right,
notes,
so-
Mobius.
From point to point,
You can't trust them to take
water
notes.
goes up. It doesn't drop
Mhm.
down.
Yeah, that's right. Compared to that cord line, yes.
I thought earlier you said that the water would continuously drop down away from the line.
That's not a
Between-
horizontal, is it?
No.
between the
cord
two.
line.
Well, a water level
Oh,
establishes
my.
a horizontal.
That's not a horizontal from the tangent.
Water level establishes 2 points.
God,
of
we're
equal
talking
elevation,
two different
Mobius.
things.
Yeah, exactly.
So if I have two ends of a water level,
If my line is
and I
below the water,
separate
the
those
water
two
is
ends.
above it.
Yeah.
If my line is above the
at
water,
what
the
distance
water
are
is
they
below
establishing
it.
a horizontal, and at what distance are they?
But that's
not
too simple for
establishing a
them.
horizontal?
That's a ridiculous question. Think of a better
Well,
question.
Well, I would say that it always establishes a horizontal. I know you disagree with me, so I'm asking you to point out where you disagree. Like, what's the
Because
point
the
at which you
horizontal is
disagree
only
with
at the
what I said?
tangent.
I haven't agreed with anything you said.
Earlier,
Other than if you
level
connect
is
the
not
two ends of a
used
water level
to
with
establish
the
a
shortest distance
horizontal.
between them,
Right.
you will have a straight line. That's all. And on the surface of the Earth, it won't be on the surface. It will be a cord.
well, when
It
we
will
were
be
talking
cutting
about
through the
LIGO,
Earth. It will be cutting through the Earth. And if you
When we were
measure the
talking-
height of the water along that cord line, you will
No,
see
it
that it
won't. You
rises
brought up
all
bloody
over the
Lake
center,
Positron.
and then it drops down
Jeez.
again until you get to the other end of it.
how long is
That's what
Pontchartrain?
will
What is
happen.
that? 26 miles?
24 miles.
24 miles.
And it rises about 90 feet. Now
How
you
long
can
is LIGO?
Now we can compare the same thing at LIGO, let's say.
4 miles?
at
For
2.5
people so
miles.
obsessed with
2.5
straight
miles.
lines,
So
they
LIGO's
Yeah,
about
exactly.
now
sure
LIGO's
do
about
have a
10th or
hard time
so.
following them.
Something like that.
Yeah.
So a tenth of the distance, the water level would drop below that
LIGO is
that
LIGO is not a cord line.
Yeah, exactly.
LIGO would be more like a tangent line.
Wait a minute.
And both ends will be above if you made it if you constructed it that way.
Imagine if
Both
Lake
ends of LIGO
Positron was built
be at a
from
higher
a
elevation.
tangent point
So- Yes,
it
horizontal.
on
How
my
high
piece of
it'd
paper
be?
in front of me right here, I got
Up
a
the other
profile
end.
picture
You get
of
to the other
Pontchartrain
side of the bridge and
with
it just
2
be a
points at
drop
either end.
off.
One end is up, and I've got a straight line in between them,
Yep.
and then I've got an arc
Yep.
with 90 feet rise in elevation in the middle.
Mhm.
And then underneath that, I've got a drawing of LIGO of 2.5 miles. It's a straight line. And then I've got a water level at this point and a water level at this point. Sorry, at either end. I know you can't see what I'm drawing. And I take that water level.
He's trying to draw.
And I take it from one point to the other point. And you said earlier that that water level would drop 4 feet from that horizontal.
You're mixing things up again, Mobius. This is just being dishonest and disingenuous. The 4 foot change. You're trying to compare a 4 foot change in elevation with that chord line at Pontchartrain. That's ridiculous.
Yeah,
well, at Pontchartrain,
absolutely
the water level would go above. Like if I took that water level at halfway, let's say I went at, I don't know, 12 miles.
Have you noticed the shape of the curve?
If I went at 12 miles with the water level, right? Where would that line be?
Huh?
The horizontal line established with the water level, where would that line be if I went 12 miles on Pontchartrain?
That'd be classed as a chord line, wouldn't it? If you did it that way.
I don't know what you're asking. That question is broken. Try it again.
Well, earlier I took my water level from New Orleans to Melville, which is 24 miles. If I took that same water level from New Orleans to Midway between, which is about 12 miles, right? Half of 24, simple math. Where would that line be between the two ends of the water level?
Between the two ends of the water level. Jesus Christ. How stupid can you be?
So you're going to answer my question with part of the question?
You just said you put the... you just said you moved it.
You get two ends of the water level and you got it, and you're comparing the two ends. Where's the line going to be? Is it going to be between the two water levels?
Yeah.
No, it's off
zigzag.
There's a hump.
Oh,
two ends of the water level 12 miles apart. Now you want to ask where the ends of the water level would be. Jesus God.
That's your question. Where the line.
The line would be between the two ends of the water level, would it not?
Are you
saying you not
it's no longer
you don't even
horizontal?
understand your own question.
Are you saying that it's no longer horizontal?
I never said it was horizontal to begin with.
So you're saying that
he doesn't understand his own question.
We're talking about chord lines. Now you've got a new chord line. This time, now we've got a new chord line that's only 12 miles long. Why don't you ask me how high the
Somebody
water
get out
would be
paint.
at the center of that
We need
line
to start drawing pictures.
above it?
Yeah.
I'll wait till you're done thrashing.
I'd say about 21 feet.
So earlier you said that a water level establishes a horizontal, or do you?
I did not. Stop lying.
Okay. I thought that you said it. My bad. If you didn't say it, then fine. We will go on with you saying that it does not establish a horizontal.
It does not establish a horizontal.
So a water level, according to you,
I will say it
is
one more
not
time.
a tool to establish a horizontal plane of reference.
It is
I just want to make sure.
I'm going to say it again so that let me be very clear about this. A water level is not
very clear.
Very clear. So clear that even you will be able to understand this.
Even
Pay
me,
attention.
great.
Write this down. A water level.
Write it word for word.
Write it down word for word. A water level is a device. Got it? Water level is a device.
It's a device
that establishes
2
points.
2 points
of equal elevation. Got it.
Right. Now, how could he go wrong with writing that down word for word?
That's blue. Right. Okay. So 2 points of equal elevation. What would you say that line is between those 2 points?
A tangent.
Tiny.
Would you say it's a tangent?
A
Would you
string.
say it's a chord? Would you say that it's a horizontal? Would you say that it's vertical?
It depends on where it
label
is
would you
and what it's
attribute
pointed
to
at.
that statement.
You're asking me what I would call the line between those 2 points on that water.
If you're building a
of
deck
water level.
using a water level,
okay,
because it establishes
2 points.
How big do you want your deck?
Equal elevation, right?
Yeah, right.
So if you're using
Bring in
that
some nice shrubbery
terminology that you just described, what a water level does to build a deck, what would you say that deck is? Would you say that deck is horizontal? Would you say that it's tangent?
I'd say
Would you
that
that
deck,
it's
that
level?
deck is a deck, and we don't usually get into geodesy when we're talking about a deck. That's
if
what
I
would
if
say.
I if I built a deck with a bunch of posts.
The deck one more time.
like in the center of this,
Yeah, but Ted,
deck, and I took that water level to each post, anywhere in that vicinity of that deck.
Yeah.
Right. Anywhere within that parameter.
You seem to be hung up on decks here, but okay. Keep going.
Well, because it's a horizontal. It's something that you can build in reality with a water level.
Well,
I'm just asking you.
What does that have to do with the flat Earth? Or the globe? I don't know.
We don't seem to want to be talking about that anymore for some reason.
What, the 5.3
But I can
or
only think in
5.8
5-foot
meters above
increments.
the sea level?
Yeah, that's what it's supposed to do.
Consistently?
That is level.
Except for like the humps and stuff?
Yeah, that's what.
Or you can think of a deck.
Yeah, I agree. And even elevation is level.
Yeah. It's the definition of level. Unfortunately, when you draw that chord line between the two ends of it, the center of it is 90 feet above the chord line.
Why would I draw a chord line between the 2 points?
To see the curvature of the Earth, of course.
Well, wait. I would draw a chord line
You would
between
assume
2 points.
Assume a chord line.
So that
can you understand assuming that the way we do things in reality? I mean, real grown-up people. You can
Are you
assume
saying that grown-up people
you could
assume things?
You could assume that you could assume or imagine, if you want to use that word, or envision a line drawn.
He's not talking to a grown-up though, is he?
We're not going to do it in reality, obviously. But can you not see that there's a hypothetical, at least theoretical line connecting those the 2 points of that ends of that water level?
Let me be very clear.
Yes or no?
I never disagreed that it's not hypothetical.
Okay.
Or theoretical. I've always maintained that your assumptions are hypothetical. So I'm not disagreeing with you.
My assumptions are.
What did that mean?
Hypothetical. In terms of what? I said the elevation of the bridge is level.
You need me to assume curvature so that I can draw a chord between 2 points.
No. You claim
okay.
that you claim there's no difference.
Maybe I heard you wrong.
Yeah, maybe so. You're claiming that there's no
I
difference.
think he's been
between
getting
horizontal
wrong the whole time.
Horizontal is level is horizontal.
And I'm still trying to understand where
That's what you claim.
find that different.
Because level is not horizontal.
In the measurements.
And what is your justification for that statement?
Well, let's just use Lake Pontchartrain Bridge. That's as good as any.
Okay.
Use that. Use that. Measurements that we make on Pontchartrain Bridge clearly show that it is not a straight line. It is an arc segment. In fact,
right, because it measures 5.8 meters above the sea level.
It is an arc segment of a circle, which is 6,400,000 thereabouts meters, the radius of it. But I don't think you understand how GPS works.
I know what the model is.
That's getting off into something that you probably don't want to go into.
No, I don't mind. If you want to talk about GPS and all that technical stuff,
something else you don't know anything about.
On a hypothetical model, it has to be.
Yet it returns that elevation. It returns that elevation perfectly, doesn't it?
It returns that elevation that's on that model.
No, the elevation you measure in reality. When you go out there and measure how high the bridge is above the damn water in Pontchartrain, it is consistently 5.8 meters all the way across, is it not? Except where the humps are.
Yeah. I mean, I've never been to Pontchartrain, but I would assume that, yeah, okay, you can stand off of the side there and put a tape measuring down, and on any given day you will get.
Why is everything with a tape measure?
Measurement, maybe not 5.8
because he only builds
sea level
sticks.
rises and lowers and stuff like that, right? Tides, shit.
That's as far as I think it can go, is a tape measure length.
So if you went on one day, you would most likely
or a piece of string
distance from the rail
to
the sea level.
Yeah, how long is a
the
piece of
length of
string?
time it takes to drive 24 miles. I don't think the sea level's going to change very much.
You remember when Brian wanted to use the fishing line to?
Oh yeah, that. Yeah, good luck with that one. You know how much breaking strain wire that you'd have to have that didn't have any sag in it?
Yeah, it's very consistent. That's the elevation, the true elevation that GPS returns.
Oh, okay.
But here's the problem: the only way GPS can give you that elevation is by first taking the XYZ data, GPS data, for each point that it's measuring, and subtracting from that the height of the ellipsoid, and then correcting it for the geoid height at that point. Then and only then do you get the actual elevation of the bridge above the water.
The actual elevation.
Yeah, the elevation you could get taking your tape measure out there and sticking it down to the water.
Yeah. At what point did Jesse who did this with his GPS. At what point did Jesse stop along the bridge to verify that? Did he ever? I don't know.
Well, I don't
I
think
never
so.
heard about him stopping and checking.
Oh, I don't think he did, and I don't really think there's any reason for him to want to. So what if it was off a
Except
foot?
to verify the
So what-
information that he's
so what if
receiving
it was
from
off-
his GPS unit.
so what
that
if it
might
was
be
off a
a
foot?
reason.
Well,
I
it
don't
was.
know.
Well,
You know, science.
Yeah.
You got to weigh your variables.
Yeah, right.
He's got to stop in the
I'm just
bridge
saying,
and taking a measurement.
measure twice,
Okay,
cut
this
once,
is
right?
not the
Blue?
traffic.
Well, I know how you guys do it, Mobius. You measure with a
Except if
micrometer,
that
mark it
tool
with a
is,
crayon,
you
and
know,
cut it by
known to
hatchet.
be
That's what you do.
That's
in
and you were
good
gonna get into
measurement.
some really colorful insults.
I know he pulled off to the middle sections there to park one time to do something.
Don't
I
ask
know
ridiculous
what he
questions
did, I
like that.
can't
Of course,
remember.
Jesse didn't stop out there in the middle of traffic on that damn bridge to drop a tape measure down to the friggin' water. What in the hell would
Yeah, I know he
even
didn't
think
do
of something
that.
like that? Who cares if the elevation is off a foot or 2 feet? You've got a 90-foot sagitta in the middle of that thing. You're
Okay,
not going to.
I'm just-
You're not going to
just so
get
that
rid
we're
of the
clear.
problem. You're not going to run from your problem by trying to make a measurement of the height of the damn water. That's crazy.
I don't have a problem. I'm glad that we were able to clarify that Jesse did not, because that would be a stupid thing to do.
Of course,
Stop
it would be.
anywhere along there to verify that the unit he was using was giving him an accurate
Wait,
measurement.
he just said that he should have done it, and now
Well, it
he's
could
saying
vary,
that it would
right?
be stupid.
Especially if there's waves. I mean, how are you gonna measure
Didn't
that?
Bev
That's why
want
it's
us to
that's
point
why
out
it's
all
all
How the hell do you think he's going to do that?
contradictions?
That's why it's put into a.
What would he
Bev, I
stop
found one.
and measure?
That's
Please
why
tell
it's
me that.
put into a computer model.
What would he stop and measure? Let's say he stops in the middle of the bridge. Now, what do you want him to do? Measure to what? With what?
I don't want him to do anything. I don't care if he does
You're
anything.
asking why
I'm
he
just
didn't do
asking
it.
you what he did.
You're asking why he didn't do
And you
it. Tell me what
confirmed that he
was.
didn't
Tell me
do.
what he should have done.
He didn't check his variables.
I talk to him
That's
all the
fine.
time. What do you want
What's
us to
his
do the next time
variable?
we do
He
this?
didn't
What would you
wiggle
like
his
us to
variable?
do? Hmm?
Oh, I don't care what he does. He can verify his readings, or he doesn't have to. He can just go on, whatever.
Well, we know for a fact that on average that bridge is around 5.8 meters above the surface, the water surface. We know that.
Whatever. That's
And it,
not
and it
really
consistently
relevant, but
and it
that's
consistently
fine.
measured that all the way across. Only now when you go back to the original data, the XYZ data, that's what I use, and you plot those positions in free space. Then the curve reveals itself. Then you see that those points are not collinear. They form an arc with a sagitta of about 90 feet. So please tell me how GPS managed to get the right
Even Jesse reverse engineered the GPS data and done a 3D model of what the data was, and lo and behold, it was a Lake Positron bridge with a curve in it and everything. Wow, that's amazing.
That's got data in it. You know,
Yeah.
cliffs don't have data. We know that, right?
Or they can't even imagine it.
consistently all the way across that bridge, but still shows us a 90-foot sagitta when you use the XYZ data.
What do you mean the right elevation?
The correct elevation, I'll even back off and say the approximately correct elevation of the surface of the road above the water. It doesn't bounce around from 5.8 to 12.3.
Did you know what
to
approximate
22
means,
to minus
Mobius?
4. It is always between 5.5 and 5.9.
Why
Something
would
like
Not
that.
the
It's
left
built into the
data,
computation
but
in
the
the
right
program.
data.
It is
Why would it
receiving
bounce
satellite data. It is receiving data from satellites and calculating a position in free space in XYZ coordinates. And only when you take the ellipsoid away from those points and correct it for the geoid, do you get the elevations that are approximately what you expect above sea level.
So let me just get this straight. So you're saying that these are correct elevations, even though it would be stupid for Jesse to stop in the middle of traffic in that bridge to verify that the data that he's receiving in his GPS unit is what his real-time measurement is?
He knew before he left the shoreline what the
That's
reported
fucking convenient.
what the reported elevation of. In fact, I think I could probably pull that up right now.
Yeah, that
From other
is
sources.
recorded.
How
that
high
data.
above the lake level?
It's all
is the
there.
surface of
That's
that
convenient.
bridge? I bet
Yes,
we
it's
could find it from
convenient that
another
we
source.
have information written
Now,
down that
want
you
him to
can look
stop
up
out there.
ahead of
There are
time.
places on the
Yeah.
bridge you can
No, I'm
stop.
not asking him to stop.
But you're questioning why he didn't stop to verify something.
No, I'm not asking why he didn't.
And you can't
I'm
even
just
tell
asking
me.
if he did or
You
not.
can't even tell me how he would have done that.
Slow down,
What are you
Scooter.
supposed
I'm
to
just
do?
asking if he did or not. I'm
What
not
are you supposed to
asking
do?
him to
What do you
anything.
think you ought to do? Stick a tape measure down there and let it waggle around in the water? Is that what you're asking?
No.
Is that what you
No.
think would have been a good?
Nope.
You think that would have verified something or the other? What is it you think, or do you know what you think?
Good
question.
I don't think it is. No.
Are you
All right.
thrashing?
We know the answer.
All right.
I was asking if he did or not. I didn't ask him if he would. I didn't ask him, would you please? I didn't ask you if you would ask him to. I didn't ask him, why didn't you? I didn't ask him for you anything. I asked you if he did or not. And you confirmed that he didn't. That's all.
Okay.
You don't need to continue thrashing over it. It's just a yes or no. He didn't. Let's move on. Right. So what would you like to say about it? This 90-foot.
What would I like to say about it? It's there. It's measured. It's measurable. We can
So
get
there's
that.
a 90-foot measurable difference in elevation from the 2 points of that water level?
No.
So from the imaginary chord line that I'm drawing, assuming that there's curve, that's when I get the
No,
90
you
foot
don't assume there's curve.
difference. Got it.
That's what happens.
So the water in a water level does or does not drop away from the horizontal.
Now we're back to horizontals again.
We haven't left. This is all about
I nearly
establishing
choked on
first
me
principles,
cuppa.
basic stuff.
Yeah,
If
I
we can't-
agree with
if
you.
we
It's pretty
can't-
basic.
If we can't agree on these basic principles, I mean, we're not going to see eye to eye on
Well,
anything. So
how far into the
if you don't want
discussion
me
are
to
we
agree
again?
with you, and
I'm
you're not willing
right
to
up
agree
near
with
the
me,
end of it now.
I don't know why.
It's like
you
we're
have
going
me.
full, like we're going around in
Well, you're the
circles.
one who asked for it.
I asked for what?
You asked for this.
Yeah.
This wasn't my idea. This was yours. Now go ahead and lie
Oh, was
about
it?
that. Yeah. You're the one that challenged me about LIGO. That was your challenge.
Do you want to
I may or
rewind
may
the
not have
stream?
challenged you about LIGO, but
No.
I didn't want to have a conversation where we weren't trying to communicate with each other.
Good. Let's communicate.
Okay.
Are the elevations
I'm trying
are
to
the
find
elevations
common
at
ground.
LIGO are the elevations at LIGO accurate or not? Are you disputing that? Because if you are, the conversation has to end at that point.
Okay, I'll tell you this one more time. I've said this I don't know how many times, maybe in different ways, but the elevation data, the values are based off a hypothetical reference model. Those
And that is a lie.
values,
Yeah.
that is not a lie.
It is a lie. That's an absolute
Then
lie.
take up that argument with LIGO, because I got that information from researching LIGO, researching GPS. Where do they get these values from? How do they determine these values? And it's based on hypothetical reference models. Look up geoid in the dictionary. Look up Wikipedia. I'm not lying.
Yes, you are lying. You're misrepresenting
Oh
and lying.
God.
What am I misrepresenting, Blue?
Those elevation measurements are not based on a geoid, only in the sense that the benchmark elevation is based on that. But the rest of the elevation
No,
is taken
sir,
on site,
I'm not
with
rewinding
reference
it.
to a
On site
geoid.
with what?
Huh?
On
I've
site
told
with
you.
what
Either
tool?
I would say it was a theodolite or a GPS system. One of
No,
these
sir,
two.
if I can't deal with that.
So either a theodolite, or is it theodolite? Sorry. Or GPS, or is it both?
One of the two, or both. I don't know. I wasn't there.
You don't know. You weren't there.
That's right.
Okay.
Doesn't matter.
So why are you telling
And
me
is
that
it
the
written
values
down
that are
anywhere
on
what they
Hasbells
did use?
are what they are in reality
Because why would it matter?
on Earth, not on a reference model?
It was a
It is not a
construction
reference
site.
model.
It wasn't
They're not
a
making a model of
scientific
anything.
test.
They are measuring elevations with respect
This
to
was
a
planned
benchmark.
out. This was planned out prior to it being built, right?
Well, yeah, it had to be.
They had to set up all these measures prior to starting.
They had to set
right?
those. They had to figure out what the elevations needed to be in order
Right.
to make that pad straight.
They went in with a plan, not just an idea, right? So they planned this.
Of course.
Meticulously planned.
Of course.
How
you don't
they're
think they-
going to create.
You don't think
a
they
straight
accidentally
line-
did that?
A straight line
Mhm.
on a curved reference. How are you going to
Not
do
a reference.
that?
Not a curved
It is a
reference. Not a
It is
curved reference.
Are you-
Mobius, I don't think
Not
you
a
know
curved
it. I
reference?
really don't think you need to continue with this.
So you're saying that it's not a reference?
I can make a straight line on a basketball.
My God.
Are you telling me
Yeah.
I can't?
You went from saying it's not a hypothetical reference to now
I
it's
don't
not
know how
even a
many
reference?
times I showed the flush that one.
You
a
sure you
straight
want to stick
line.
with that, Blue?
You sure you want to stay here?
I mean, you know, it's
Stay
going to
where?
lift
Here.
off the
You-
surface
continue
You
on.
of
invited
the
me here
basketball, obviously.
because you were afraid to go
because,
anywhere
like,
else.
I'm not afraid
I'm
to go
over here.
anywhere, Mobius.
Well,
I
I'm
was
here.
at Bill's place.
If you want to kick me out, you can kick me out. That's up to
I
you.
know
It's
that's
your
what you'd
place.
like, but I'm not going to do it.
Then I'm not saying I want to leave.
I think that's what
if I
you're
want to leave, I'll
trying.
tell you.
I think that's what
leave.
you've been trying to do is trigger me all along, and it's not going to work.
Oh,
Maybe you've probably figured that out by now.
I think you're pretty sensitive, and
Yeah, they had to.
anything that's
Yeah, the guys at LIGO
is-
the guys at LIGO absolutely had to figure out what the elevations needed to be in order to account for the curvature of our Earth. If that
And
is
how do
plain
you
enough
think
for you.
how do you think that they started with that whole process? Do you think that they assumed it was flat?
No, what do you mean? Assuming it was flat. You know the Earth is curved. We know the Earth is curved. It's not a question.
I know it's got lots of curves. It's beautiful.
It's not a question. We know it has a curvature to it, and if we're going to use elevations,
It's got lots of curvature to it.
If
Like
we're going to use elevations, we're going to have to account for that over 2.5 miles.
Yeah, and that elevation is based on a vertical change from a horizontal reference.
No, it is not.
Look at, you just showed me a bunch of pictures and stuff that shows that that's what elevation is.
Well, just a moment.
God, Blue.
Just
It's
a
like
moment.
you're arguing with me for the sake of arguing. It's like,
the elevation.
do you even know what you're talking about anymore?
What are you trying to do? I do not know what you're trying to get to, Mobius. I have no idea. Elevation is defined as points of equal gravitational potential. Points that are equally an equal distance in essence, an equal distance away from the center of the Earth. That's what elevation is. It will deviate from a horizontal tangent at any point. Yes, it does that.
You said it's equal. Now you're saying it's deviating?
Say what?
I think you need to take a break.
No, I think you don't seem to understand.
Equal a distance above the curve,
I can't understand
which means
gibberish.
it will deviate from
You're saying that
horizontal.
it's equal potential, equal distance
Yes,
from the center of
Flirts
something,
can't
and then you say
3D.
that it deviates from horizontal.
And it deviates from a
They
horizontal
can't follow.
tangent, which I define as from a horizontal, which I define as a tangent at any point. If you take the start, take any point you like, and make a tangent line at that point, and level deviates from it. The further away you go, the more it deviates. And that deviation is about 8 inches per mile squared. And when you take the LIGO elevation data and correct it for 8 inches per mile squared, you get a perfectly straight line. I've been showing that for hours now. Now, that's what was done. You can bitch about it all you want to, but that's what happened. And the fact of the matter is that tube is known to be straight. Now, the only thing you've got is to say, well, maybe they did it with adjusters.
So the tube is straight, but they didn't use a horizontal reference to make sure that it was straight, right? Because it's sloping. So they used the slope to go off from that slope to make it have different elevations.
Yeah.
So that it's not an even elevation.
Yeah, the elevations do not plot a straight line.
Yes, because
Well,
on
why
a
didn't they just
curve,
build it horizontal?
you have to. Oh God!
I can't answer why they picked the point they picked for a tangent plane. I don't know.
Well, I mean,
why.
you asked me earlier why they went through all this trouble. I mean, how are you expecting me to answer that?
What was your question?
Just now?
Yeah.
I said, why didn't they build it horizontal?
Well, if you take a look at the elevations at Hanford, for instance,
Horizontal doesn't mean level.
If you take a look at how the ground, not where they did the work, but the ground around it, that might be a clue for you.
What's that?
Yeah, the ground's not
that's
even.
The terrain slopes. Same at Livingston. Look at Livingston.
The terrain slopes?
Look at Livingston. Yes, it does. Look at Livingston. The terrain along that one arm that's almost level, not quite. There's one of them that's almost level, but that terrain is level all the way across there. But when you go to the other, when you go to the other arm, the terrain drops away pretty significantly.
Yeah, I mean, it's just a 4-foot difference, right?
Yeah, so it's a 4-foot elevation change. Yes.
You're saying they don't have 4 feet of dirt?
Why would they?
I'm just asking. Like, it just doesn't seem like why go through all that crazy?
They just built the pad a bit higher. That's
sure
all.
that this thing, why not just build it horizontal? Just it seems
because
like
the terrain was sloping. Because the terrain was sloping.
But now they're using a horizontal to determine how much slope to drop it.
The terrain was sloping.
So that they can drop it even further from level, even though level is supposedly below horizontal.
It's actually higher in the center.
What? It's higher in the center?
Yeah.
Higher than what?
Well, I'm sorry. The elevations are actually higher on each end than they are in the center.
according to this thing that you got up on the screen, all the elevations are higher than the one at 13,000 feet. 2.5 miles away from the vertex. So what do you mean it's higher in the center?
What I mean is there's a 1 foot deviation at the center point of these tubes from a straight line. It's about 1 foot.
Where's
The
that
lowest
picture? That one.
elevation
That one.
in
If
this
you look
thing,
at,
the lowest elevation in this thing is at 13,000 feet.
yeah, slopes
Yeah.
up to 533, and from there the next arm slopes on up to 538.
So that one, even that one's not horizontal?
No, it's not.
Neither of them are horizontal?
Neither one of them.
Well, why do you suppose they did that?
Yeah.
How many
Especially when
times?
the,
Okay, get your
is it
pencil
'cause of
out
the
and
mirrors?
get your pencil out, and we'll write it down again.
is it because of the mirrors?
He's gonna do-
You keep falling into
That was the
into
way
a trap.
the terrain
Blue.
laid out.
Falling into a
I
trap.
mean, it's a complex system of
Yeah.
pendulum mirrors.
They are
within
both
the thing,
horizontal.
right? I mean, there's at least 6
ground is not.
pendulum
Yeah.
Okay.
systems. Right? There's
It
Well,
doesn't
they,
matter.
at the
they
end,
I
one
think
at the
the idea is
midstation,
that they aren't
and one at the,
horizontal. They aren't
at the
along
center,
the tangent
splitter.
plane.
And then at the other
Um,
midstation,
No, but
and
he's
at the
using
other
it
splitter,
horizontal.
there's, well, not 6,
And that's where
5,
it's falling.
but then you've
Getting
got
blue
the,
into a
Yeah.
trap.
Yeah.
the
Yeah.
accumulator or whatever they
Because
call
he's
it,
using
the
horizontal
detector,
for a different
and then you've
meaning
got
than
the
what
source.
we know it
And the
is.
source, that's
Yeah.
a whole series
Yeah,
of
because
mirrors all
blue is
set up.
using horizontal as the tangent plane,
Yeah.
and
Yeah,
and,
yeah.
and it's
Well, that's
yeah,
what
and
the,
He
it's
had built
and
it.
it,
drawn the scale up there at the top
yeah,
is what
Yeah.
a
it's
what
off
the
the
LIGO,
the tangential
tube we've
plane
been
a bit
looking at,
because of terrain or
the
whatever,
arm
but it's
we've been
still a
looking at.
straight line.
That's what that looks like when you
Yeah.
draw it, an elevation view of it to scale. Obviously, you can't see shit
18.6.
because it's only 4 feet in diameter, but it's 13,000 feet long. Now, I exploded both ends in the center point of it just to show you. On the left-hand end, I've drawn a plumb line, and the plumb line is at an angle of about 90.0175 degrees to the center line of that tube, or to the I dimensioned it to the wall, but the center line would be the same angle. If you draw and I've drawn a little box down there representing the mirror itself. If the mirror were actually, surface of the mirror were actually parallel to that plumb line, the red line is would be a line which is normal to or perpendicular to that plumb line, and it would intersect the tube about halfway down.
Well, I mean,
Instead,
we went over this earlier.
all they have to do is adjust the mirror slightly. A 0.0175 degree adjustment to bring the surface of the mirror normal to the center line of the tube, and that's what they've done. That's what they had to do. You've got a 4 foot elevation change. Yeah, you got to. You got a 4 foot elevation change. Huh?
You got any literature on that?
Yeah, I got it someplace.
All right.
I'm not gonna look for it right now.
Not what they had to do, but what they did do.
No, that's what you have to do if you want it to work. If you don't
No,
want
I'm
the
saying,
laser
do you
hitting
have
the
any
side of the
literature
tube.
on what they did do, not what you say they have to do? Obviously, right here, you've got literature right in front of my face that what they had to do. I'm asking you if you have anything on what they actually did do.
Of course.
Oh, okay.
That's what it really looks like.
Is that?
Are you guys still trying to maintain the tubes are horizontal? Level?
Well,
are you still trying to maintain that?
I know that vertical, which is plumb, is perpendicular to horizontal.
Yeah. Do you think the mirrors
point.
have to hang where the face of the mirror is plumb? Can you not envision a way that the mirror can be suspended so that it's got a 0.0175 degree tilt to it?
Wait, are we arguing about what we can envision possibilities, or are we talking
I'm
about?
just asking you. I'm just asking
what
you.
is-
I'm just asking you. Do you think it's possible to have a mirror situated like that so that it's slightly tilted to adjust for the alignment?
Well, I mean, if it's sloping down 4 feet.
Have you ever seen? Yeah.
Are you saying that the mirror is plumb?
No, it's not.
Okay, because it's sloping down, right? 4 feet it slopes. You said.
Yeah, it slopes 4 feet. It's suspended like a plumb bob, but that doesn't mean that the surface of the mirror has to be perpendicular or parallel with vertical, does it?
So because it's
the sides
pendular mass.
The sides of your plumb bob are not parallel with that string above it, are they?
I'm sorry, what?
You got a plumb bob? You know what a plumb bob
Yeah.
is? Okay.
Yeah.
Are the sides?
I got a few different types.
Yeah. Does it look like a a conical looking thing?
I actually saw one that looked like a horn hood ornament.
Yeah. Okay. Is it? But let's think about one that's like a conical looking one. You know, sort of a standard one.
Carrot
One of
one.
those you can buy next to the.
Yeah, like the
CPF.
standard brass ones.
Yeah,
that you see.
standard brass ones. Are the sides of that thing parallel with the line that it's hanging from?
Didn't you say it's conical?
Yeah.
Yeah. So
obviously not parallel, right?
Statement.
So
Yeah.
a pendulous.
Are you
mass,
saying that those?
So
are
the
you saying that
size,
those
so the
mirrors are
size of
conical?
so the size of a pendulous mass don't necessarily have to be parallel to the suspension system, do they?
Well, if it's hitting a laser and bouncing a laser back, it's got to be perfectly perpendicular to that laser.
That's all.
Yeah.
That's all. So it'd be quite easy to adjust the mirror to be perpendicular to the laser, right? Obviously.
Easy?
Yeah.
I don't know, because in their literature, they say that the final alignment wasn't based on the theoretical alignment. They had to like do it differently.
Mm-hmm. Yeah, they actually use the laser itself.
Yeah. And it's just weird that they set it up according to the theoretical alignment, and it wasn't right. But you know, it's just what their literature says. That I mean, this is their documents, not like their high school handout pamphlets. They're actual white paper type shit.
Yep. All right, we'll go back to that. It would appear to me that those guys working for those little tiny companies like Chicago Bridge and Iron went to a hell of a lot of trouble to put a big curve elevation wise in those pads for no good damn reason. I can't think of why they would have done that. Certainly would have been a lot easier just to pour it level, wouldn't it?
Are you saying that I'm saying that it's curved?
No,
is that what you're saying?
No, I'm saying the
that would be
elevation data.
Stupid.
Elevation data clearly shows it's curved, regardless of what you say.
Right. I just want to make sure that you're
Either
not trying to
it's
say
curved
that
or
I'm
the
saying
ground's
that
curved.
It's curved.
There is
No,
a
I'm just
curve.
saying that the elevation data itself shows it's curved, and it
Well, the
appears,
elevation data was based on
it
a
appears to me,
hypothetical reference
and
model.
it's not,
So
and
obviously
it's not,
it's
and
gonna,
that's a lie. And I'm
so
not
it's not a
listening to
lie.
it. It is a lie.
It's not a lie.
It is
Said
an
that
outright
like 5
misrepresentation
times now.
and a lie.
Yeah.
That
Based stuff in
elevation,
data.
Keep going around in circles. I don't know why.
that elevation data is not based on anything theoretical. Those are measurements made in the field.
Prove it.
I don't think
all.
I need to prove it.
I know you don't.
I have
But
no
you're going to sit
reason
there
to
and
want
say
to.
that you're right, regardless.
You have no proof that I'm wrong.
I have proof
You
that
have
it's based
absolutely
on a
no proof.
hypothetical reference model.
No, you don't.
All
you've
the
got is a
literature
benchmark.
says that.
All you've got is a benchmark.
All the literature says that.
Okay, put it up on the screen. I'm ready. Show it
Let
to
me
me.
see. Let me open up another
Yeah.
window.
Give us something.
Oh, I'm sure that.
Go on,
I'm sure
Mobius.
if you're talking about the
We'll wait.
About the way the pad has
How much longer is this?
pad elevation.
Not that much longer.
Yes,
We're on the tail end of it now.
You keep saying that.
Based on the
Well,
curvature.
I'm showing you.
Based on
Look,
curvature,
we're at
yes, absolutely it is.
446,
No doubt about that.
and the whole stream went for
With those
You mean the hypothetical
505.
reference geoid, right?
No, I'm talking about the
Okay,
curvature
so like
of the
another
Earth.
20 minutes.
The rate of curvature
Curvature
of
of
the
what?
Earth.
And probably another 30 minutes, and I'll
8
finish
inches
up.
per mile squared. That
You mean
curvature.
the difference from horizontal?
That curvature. 8 inches per mile squared.
The difference from horizontal.
Yeah, that's drop from horizontal, but it applies also.
Well, in some cases it's a drop from horizontal, and in some cases it's a rise from horizontal.
No.
Uh,
No.
Yeah, that's elevation. Elevation
No.
goes both ways.
John Rapp said it's Groundhog Day. Yeah, it's like that.
That's
Let's do another reset.
While you look for that,
we
I'll be back.
actually
in a second.
refer to it as a.
Oh, hold on a second. If you're taking a break, I need a
Fair-
break.
It said not that much longer. 10 hours later, almost done. Well, if this was my live stream day,
Are you
I could
taking a
just
break?
keep going till later.
I think you took a break. I need a restroom break.
That's the trouble. It doesn't. You can actually call it the same thing. They're not. A rise in elevation and a drop in elevation is still measured the same way. So you just have a positive or a negative.
Yeah.
That's when you're reporting it. You don't have a separate column. If you're reporting the information, you don't have a separate column to show you that it's a rise or a fall. You just put a plus or a minus in front of it. So you just call it a level difference. Or a difference in elevation.
I think he left.
Maybe.
Okay. Because it's sloping down,
yeah.
right?
They said they were taking a
I don't
break.
think I need to prove it.
Yes.
I know you don't.
Oh God, did you go backwards?
I have.
You've got as a benchmark.
Don't do that.
Yeah, I heard him
all
say
the literature says
what
that.
they were doing.
Open up.
He just wants to.
Earth, yes.
He's a
Curvature of the
bit
Earth,
worried
absolutely,
about missing
yes.
out on stuff, weren't you?
Right.
No, I'm talking about the curvature. 8 inches, but it. While you look for that, I'll be back in a second.
Oh, hold on a second. If you're taking a break, I need a break.
Blue's taking a break.
Blue's taking a break. Yep.
Okay, so we just have to skip forward to get to the end bit.
Another popular one.
All the Chinese drink is that green stuff. It's pretty good.
I like it. So where were we? What were we doing? I was looking for something that said
Flare reset.
Yeah.
You're going to show me something that says they took Earth curvature into account. Don't bother. I agree. Yes, they did. If that's where you're going with it.
Here,
Of course
if
it
you
says
type in Google, anybody can do this. The dictionary, Oxford Languages.
Yep.
Geoid. The hypothetical shape of the Earth, coinciding with mean sea level and its imagined extension.
So they established the datum.
Or over, in parentheses, land areas.
That's right.
I'm not disagreeing with that. Why do you argue with me when that's what I say and you say that's wrong, and now you're saying that's right?
No,
you're quoting something.
That
is correct.
I read it directly.
But you're saying these elevations, that all these elevations taken are directly based. The absolute value is based on that geoid. Yes.
Which is a hypothetical shape.
But Mobius, one more time. Let's see if you can follow me this time.
And whatever it's imagined extension.
Okay, let's take that away. What if we take it away completely?
Take what away? Take away the definition of geoid?
You want to listen for a second, and I'll tell you. I think 529 point whatever it is was the low end. I know it was. All right, let's subtract that geoid value at that point from all the rest of these elevations. How will that change this picture?
Wait, what?
What was the question?
Eliminate the geoid, the actual absolute value of the geoid, which is 529 point whatever, at that low end. Eliminate that totally. Just call it 0. Subtract that exact number from every one of the other elevations, and how will that change this picture?
Well, you'll just take the same exact.
Oh, we've got an image of that.
And
I hope you've got that one, Blue.
Where that 533.5 or whatever you said.
Oh, you got to show him, Blue. Hope you got it. I have seen it.
Yeah. So what did the geoid do? It only established it only established 1 point, one reference point, and they tell you in the drawings what they use for the project datum. Want me to find that for you?
Are you talking about the 3 benchmarks that were offsite?
No.
Or are you talking about the ones that they use on the those right there?
Wait a minute.
No, you just had it. The ones you circled in red?
No, that's not what I'm talking about. I'm talking about the
NAVD 88 benchmarks.
Get back there in a second. You see that? Vertex 0 elevation. This is the project datum, 537.29 feet.
Yeah.
That's the project datum. Beyond that one number, that one time, there are no more references to the geoid made in any of these measurements. Just that absolute datum point. That's all.
Why would they need to keep referencing it at every point along?
They don't.
It's built into the design. It's
What do you
built
mean?
into it.
What do you mean they have to keep referencing? What are you talking about?
You're saying that it only references.
You mean it's built in?
That's consistent throughout the project, everywhere. That's the project datum.
I know they're still using the same reference model.
It's just an elevation, Mobius. It's 1 point. It's 1 point.
Dude, the computation that's involved in the programming itself is based on a reference model, on a Cartesian coordinate system, XYZ coordinate system with the presupposed center.
This is to do with elevation, not location.
I don't know what you're arguing against.
I don't know what you're arguing against. I have no idea.
Yeah.
You keep saying that these measured elevations are based on a model. No, they're measured elevations.
Your diagram with the curving thing,
That
Huh?
curve.
Yeah.
What?
That's a hypothetical curve based
No,
on
sir.
that model. The thing the
That's
arc
measured.
straight.
Those are actual measured elevations.
Yeah.
Based on what? On a
Based
curve.
on actual measurements.
Let's
and
take
yes,
this.
and yes, that curve.
533.5.
And yes,
there
that
at the top,
curve.
it's 0. Sorry.
Yeah. And yes, that curve was built into it. Yes, it had to be in order for it to end up straight.
Let me know when I can talk.
Okay, go ahead.
If we take it 0 point on the station feet, and we've got 533.5, whatever, let's say 5.5. If we build that into a model that's curving, then all those elevations would be off of that model.
Off of that one number, yes.
Right. So if the ground itself, if they leveled the ground and they used a horizontal reference, it would be straight. But they're using a curved reference, so the values that it shows will be curved.
That's ridiculous.
Yeah.
It's not. It's what you're showing me. It's
Absolutely
what's
ridiculous.
happening. Work it out, Blue. Just
it's ridiculous. Your level of misunderstanding is astounding.
Great. That's not you working it out or explaining how I'm wrong.
I think I've done that about 15 times already. There's no real point in going through it again. I have.
I haven't heard anything that's substantial yet, except for I'm right because I'm right. I mean, that's the level of
Mobius. That's what you're doing.
How?
That's all you're doing.
I'm taking the information that's out there, which says that these elevation values are based on a hypothetical model. I'm taking that information and working out how that curve can be represented on this graph while still having a straight structure in reality. And the way that I do that is using basic first principles, geometric fundamentals, and knowing that an elevation drop or rise in vertical is from a horizontal plane of reference. It's perpendicular to that horizontal. You're telling me that if somebody goes out there, you're telling me that if somebody goes out there and uses whatever tool that they can muster to establish a horizontal, that dotted line that isn't the actual read. I'm talking about the horizontal. Whoever's establishing the horizontal frame of reference or reference plane, they're going to get a drop if they want to slope downward. They're going to get a rise if they want to slope upward. They're going to get a curve if they want to differentiate the values to represent a curve. People build things in real life. A driveway that slopes down and has curve to it. Those are things that are done in real life, in reality, right? With a straight line
on a ball
elevation profile, you can see these things and they match reality. This right here,
build a driveway halfway around the world.
That's not how the thing is. If it's straight, it's not curving like that. So this curve is a representation of the hypothetical reference model that they used to come up with these values, so that you can
starting to kind of sound like Witsit
on this graph.
Yeah, he's trying to argue more than anything else.
Mobius. And that's where I thought you would go with this. That's exactly what I thought you would do, because you have nothing. Because you really don't have any place else to go, do you? That's the only thing you can say. I understand. That's okay.
That's all I've been saying.
That is okay.
Show me how I'm wrong.
I have shown you how you're wrong time and time again, Mobius. These are
Where
actually
have you shown me,
these are actual as-built elevations, and you're questioning them. Okay, that was the answer.
I'm not arguing with what's in black and white.
I'll tell you what we could have done.
I'm not disagreeing with what's in black and white.
Shut the fuck up for a second. We could have avoided the last 4 hours of bullshit.
You're right about what I'm disagreeing with.
We could have avoided this last 4 hours of bullshit if you would have just answered the question that I ask you time and time and time again, which is, do you contest the elevation data on the as-built drawings? And you weren't honest enough to do that.
What are you talking about? I answered you.
You would never tell me that you agreed or disagreed with those elevation points. Those elevation
I told you I
measurements.
don't contest them. They're based on a hypothetical reference model. Of course, they're going to represent the hypothetical reference model. I'm not contesting what's in black and white, Blue.
You're not saying are you honestly now going to say that you're not contesting those? While
I've
at the same time,
I've never contested
while
them.
at the same time saying, while at the same time saying that it's based on a
Just
hypothetical
contested
model. Are you saying that any of these pad elevations are actually just a model? That nobody
is that
actually
what your
went
hard-on's
out.
about?
That
Do
actually,
you really
that
think
nobody
that I'm
actually went out.
contesting?
That nobody
Was it
actually
black
went
and
out there and measured those elevations. Is that what you're
Oh
saying?
God, I didn't
Or
know
not?
that you were hyped up about something that is fabricated in your imagination. I never disagreed with anything that was in black and white.
Okay, fine. In that case, those elevations plot a curved line on a graph like this. But when you include curvature of the Earth, it is a straight line. That's the only point I've made. That's the only point I've tried to make.
When you include what curvature of the Earth? The ones represented by this graph?
Not the ones represented by this graph. Curvature was taken into account when the elevations were established. Yet it forms a straight line, and you can't deny
You mean
that.
the single benchmark?
Yeah, a single benchmark. That's all is needed.
And you weren't there. You weren't there to determine how they measured these different elevation values.
I've told you several ways they could have been measured.
I know you've told me several ways they could have been. That's not what I said. I said you don't know because you weren't there how they did it exactly.
I'll bring up you weren't there.
Hypothesize which method they might have used.
Yeah, you weren't there.
Would they give different answers?
I don't know. Would they?
No, they don't.
So from a horizontal reference, you're saying that wouldn't be different?
Get off the horizontal reference and
why do you need me to get off a horizontal?
Lose that argument. It doesn't work for you.
Why do you need me?
We've been through that time and time again.
Why does this conversation require me to get off of the thing that my whole
don't
position
get all excited
rests on?
now. Don't get all triggered.
I'm just asking you why you need me to get off of it.
Don't get all triggered. Come on.
This isn't triggered.
Maybe we ought to go back and talk about driveways or something you got some experience in. I don't know.
This isn't triggered, Blue.
This is you're clearly upset. I'm sorry about that, but the facts are the facts. That's the shape of the thing in terms of elevations.
If you think this is upset,
the actual shape is straight.
You must get scared by bunny rabbits. I swear. You think this is upset?
You're clearly upset, Mobius. Come on, give me a break.
What's clear about it? I'm not upset. So why would you perceive me being upset?
Oh, just the tone of the voice in your voice and the way you're over talking me all the time. That's one good clue. But anyway,
first of all, I don't know. Sorry, I was in the middle of
all right, go ahead.
saying something. You said I was over talking you, yet. So, like I said, I was going to say is I don't know if sometimes there's delay or anything like that, but I notice that you talk over me a lot too. So I'm not gonna nitpick and bicker about it. We can move on. Fair enough or no?
All right. Well, the fact of the matter is, still remains that those elevations are measured. Now, they were established, without a doubt, by considering the curvature of the Earth. If you're going to try to eliminate that and make the pad straight, how would you do that without considering the curvature of the Earth? Clearly, that's a requirement, and to try to say otherwise is just stupid. Of course, they did, but it can be confirmed. I'm not done yet. I'm still talking. But it can be confirmed by the as-built measurements of the elevations, and that is what those plot, that curve. And when you take into account Earth curvature, it forms a straight line. And what we know in addition to that is that the tube sitting on top of it is perfectly straight in free space. So that's the end of that. There's nothing else to say about it. Thanks for coming. I'm going to give you the last word, and then we're going to end this.
Oh. All right. Well, you disagree that the data on this graph here, the elevation values, are derived from or based on a hypothetical reference model. I contend that they are. You disagree. You say that a water level does not establish a horizontal plane of reference. I disagree. I think every example in history from the beginning of time would agree with me, or demonstrate that that's accurate, but you disagree. I don't know. I wanted to try to find some agreement between us, but I would appreciate if you would refrain from saying stupid shit like I am a chicken, would not come here to talk to you. I have no problem talking to you, Blue. I don't think that you're entirely a bad guy. I don't want to, besides the trivial, colorful insults.
He hasn't
they
got really
dish
any
out all the
parting
time.
words, has he?
Sometimes I think they're pretty funny, but really wrong and inappropriate a lot of times. But whatever.
I
You're
think we'll
you.
leave it there then. We don't have to
That's
listen
fine.
to this. Listen to any rambling on the
Thanks for having me over. I guess that's it. Not really much to say.
All right. I would love to be able to go back and shout out all the super chats, but I think I've probably lost them by now. If you're one of the very kind people that gave to the cause, so to speak, thank you so much. I really appreciate it. But I didn't want to interrupt what was going on just to go through that stuff. So I hope hopefully everybody will understand. And with that, I think it's time for everybody to take a break, and we'll see when we're going to do the next stream. Thanks again, Mobius. I'm going to end this thing at this point. Good night, everybody.
Thank you.
Well done, Blue.
Yeah.
Well done. As good as you can do.
I don't know how many circles I was going around. I was getting dizzy.
You got caught in the vortex there, Terry.
Yeah, sounds like it. I'll get rid of that. I don't need all these tabs open now. Oh, I wanted to read out.
Terry.
I wanted to read out that before we finish because I kept showing it earlier. This challenge. So, did we know anything about this challenge? For Bev?
So I was looking at it. I think it is from Mandelbrot to Bev, and he posted it on Toon's server.
Okay.
So.
But there's still a challenge to Bev.
Yeah.
Okay. Bev will adopt the flat Earth position for the debate. Topographically is not relevant, so don't bring it up. The date will be titled Flat Earth versus Round Earth. It should be Globe Earth, not Round Earth. Which model best comports with reality? Both speakers will start the debate presenting evidence. They got evidence for their model. Well, that cancels one of the things out. The debate will be on a non-sequitur show hosted by Steve McRae. Wow. The debate will be moderated by someone of Bev's choice and somebody of my choice. Bev agrees to follow these terms and understands he will not receive the $500 if he fails to do so. If Bev follows these terms, he's guaranteed $500 no matter the outcome of the debate.
Good fun for Bev. You should just turn up.
The problem is that he fails at rule 2 where he has to supply a model.
Yeah.
Well, he doesn't have to be a good model, so yeah, he should be able to get away with that, I would think.
Oh, there you go. Yeah, just make something up.
Yeah, bring a snow globe. Yeah, there's my model.
The Lego model. Lego. We find.
No. Well, a model is anything. So
yeah.
The basic model is to say that that's the auto level determines the shape of the world. You know.
You can get a hobby shop and get a model of a car if he wants.
Yeah. So I think you can get around that one.
Or you could get a female model.
Mannequin.
We've been going for nearly 5 hours, you guys.
Yeah. Oh, thanks, Terry.
And you're supposed to be
hilarious.
And you're Turtle. You're supposed to be working. So I hope you got some work done.
I am working. You want to see what I'm working at?
Are you doing some graphics or something?
Hang on, let me see if I can put it on.
When are you going to get time to help me with my graphics that I need for the show?
This is pretty. This one's a little bit boring because it's just an internal link road. But
well, I've got an airport. We could all be sitting in the waiting lounge at the airport.
Yeah.
That one we had before. That'd be cool.
I've designed an airport already.
Yeah.
So, what do I need to share? I need to share on link. I'm just trying to find our Zoom button. There he is. Share screen.
Maybe you can do a flat Earth model.
Oh, actually, he was going to try to have a go. Try. I emphasize the word try for Lindsay's model.
Okay.
For Lindsay's model.
Oh my God, that'd be so difficult.
Oh no.
So you can see what I'm working on at the moment.
Okay.
Road.
Road, yeah.
So it's designing. They need me to design the road, and so I'm working on this. I've got to present a couple of different options for the.
What? No roundabouts?
Way. No, they want traffic lights here.
Okay.
So I'm looking at two different options. One with a perpendicular crossing and a and at the moment I'm just being exciting and putting all these parking bays in. And, but
nice
because I'm programming it a little, so
okay.
I'll show you. Let me run this is 12D. So sorry, because I'm sort of half in between sharing, I just need to click out to here and close that. I'm trying to bring up the rest of it because I have multiple screens. I'm only showing you one screen.
Yeah,
so
that's okay.
The thing I'm looking for is actually on another screen and I can't find it.
Oh.
It's there somewhere.
It's over there.
I don't know. It's there somewhere. Hang on a sec. I'm gonna unshare just for a sec.
Yeah, you sort yourself out. I'll say some
I'll come back.
goodbyes out in the chat for the peanuts.
You do that.
Yeah, Terry. Thanks for having me. I'm gonna drop.
Yeah. Thanks for coming, Harry. It's been a long time between drinks that you've turned up.
Yes, sir, it has. Yes, sir, it has. But I'll see you tomorrow, I'm sure.
Yeah. I'll be around.
All right. All right. Good night, fellas.
Good night, mate.
Good night. All right.
Yeah, I'll bump into Howie over on Geos or Gems.
Yeah.
Rakia stuck up for me over on Bev's there earlier. Yeah, but Bev spoke to me before, so Bev should know who I was.
Yeah, I don't think he seemed to have a problem. I think it was just they didn't know you were doing it. So.
Yeah.
Well, I did speak.
I
did go in there and speak my piece, so that way I'm not.
Yeah, when they heard it. Yeah.
Yeah, trying to.
They're not hiding.
Well, no, they seen me sitting there because I posted the link to the stream, so that way they could see that I was doing a live stream, and then I was in there.
Okay.
Oh, okay.
And then I happened to be in there, so somebody's actually put two and two together.
And realised.
Good night, Surf.
Night? Is it nighttime somewhere?
Yes.
Must be on the wrong side of the world. It's nighttime, I think.
Yeah.
No. Right side of the world. Left side of the world.
Where did the sun go then? When the sun set, where did it go? On your side?
It's a Pac-Man sun.
It
just pops out the other side.
It went west.
Go west, young man. Go west.
It's set in final location.
This is how we sort of do this sort of stuff. So I have to program all this code here, which programs how the road's got to be built.
Mm-hmm.
We run that. Tells it how to do the whole lot. So I'll tell it which strings to put in. Down here, I've just written this little snippet to put in all the bays. Mm-hmm. So that snippet's like another piece of code which tells it's got about 10 lines of code which tells it how to
put in the parking bays. Okay.
Yeah, so then I only have to have one line and then I just tell it, okay, put a bay there, put a bay there, put a bay there, put a bay there.
Okay.
These are all relatives. So I start at one point and then each of these bays is relative to that first point. So if I move that point, then the bays will move with it. So in this case, the point's relative to a pedestrian crossing that they're going to put in here.
So, there is one.
There
is one problem, Timble.
Go on.
Where's the cars?
Oh, that's a different thing. I see cars. Hang on. I'm going to unshare.
Have you done a car yet?
Not on here because I'm building the
Oh.
road. I haven't finished the
yeah,
road
right.
yet, so
Oh,
I
okay.
can't. So I can't show you cars. But when we do stuff with cars,
Yeah.
I'll pull one up.
Yeah, we're just trying to finish up. That's all. I'm just sort of just randomizing what you're doing.
No, I'll be very quick. I hope.
Yeah. That's why we seen the road thing. We surely a lot of us out here know how to do coding. I know a little bit about it, but not a lot, but enough to get me out of trouble.
I'm a programmer myself.
Yeah. No, I've done a little bit years ago.
That's obviously an internal macro language for that program. But, it actually, I think they build it off for. I'm not sure if I keep trying to get them to write it in Python, but I have a feeling they build it in C++, and then they have their another language which they wrote on top of that as well.
Okay.
I'd like them to write it in Python because it'll make it a bit more powerful than what it is. But anyway, we'll get there eventually.
Yeah, get there.
Now, what was I saying?
I've got to shut
John, I think the fun is about to set here. I think that's what's happening.
I better close all my tabs too. We don't need all them open. I don't know how
drink all the tab.
No, I had high IQ research.
So let me share again. Checking where I was.
Good morning, Clive, and good night. Good evening here. Jeez, look at the time's gone.
Yeah.
So you're asking about cars. This is another part of what I'm doing.
I've seen your airplanes. Now I'm seeing cars.
This is when we're doing traffic modeling to make sure something works.
So planes,
planes. I'll actually do a simulation.
Yeah.
Of the model. So this is actually simulating the
traffic flow,
amount of cars expected.
Yeah.
The actual volumes of cars expected, and then work out how the cars are going to actually run.
What if there's a traffic accident? Do we see police and ambulance turn up?
Yes, I was going to say, dude, you model for rush hour.
Yeah, so we're designing. We actually do. This is a very simple model, but yes, if we're doing something in Sydney and they want to work out, well, what happens if there is an accident? Where does the traffic end up going?
That's it.
We can have this entire model work out, and the cars to say, "Oh, I can't go through here, so I'll go this way," and you can see where the new congestion points.
And when you get a bottleneck too, like that'd be a problem if you don't end up with a bottleneck.
I was going to say, I know where the traffic goes. It goes nowhere.
That's right.
For hours.
Well, that means your roads aren't very well planned then.
Probably not.
This is planning stage, so therefore everything works. I won't pull it up because it'll take me a while to find it. But yes, I can show you models of when it doesn't work.
Nice.
We'll save that. We'll save that for another night. You can present something like that.
But yeah,
did you use the flat Earth model to create those roads?
It is flat actually, but yeah, I didn't take into account the curvature of the Earth for this particular model, no, because funnily enough, it's not big enough to worry about.
So we've seen
John wants to.
What? How do you factor in driver incompetence and stupidity?
Yeah.
Put a flirt there.
We do actually, but we didn't see it because it's built into the algorithms.
Right now, what I was asking before, I've seen planes, but where's the trains? Because we've got automobiles.
I haven't designed a rail line. I have designed around rail lines. I've designed rail crossings, but I haven't actually designed a rail line.
Okay.
Oh, actually, no, that's technically I have. I have done, but it was a straight rail line, so that doesn't really count because there's a lot of design in a straight rail line.
No.
Terry just wants planes, trains, and automobiles.
No, that's right. That's where I was getting
at. Okay. Well, next I'll put together a little planes, trains, and automobiles thing for you.
Yeah, I know. It's just a novelty of it.
Yeah.
All right then.
Flat train line?
Do that.
Yeah, it's flat.
Okay.
and they converge.
Of course they do.
Right. Yeah, I don't want to say the P word. Oh, thanks, Donkey.
Yes.
Thanks, Turtle. Thanks, my mum.
Okay, guys.
And Howie's already gone.
See you later.
John
I guess thank
Clive
you.
was here, Surf, Armageddon's Fire was here. Colin was here. Geez, was a few here, 96.
Gary showed up.
Yeah, Gary showed up. Yeah, it was amazing. Zebulon again there. Who else was out there? Roden was there, no last name. Oh, it's a few people. Oh, Brian Stevens turned up. John Rapps turned up. There was a few other people that turned up too, wasn't there? Wasn't it? Was it Dora? Didn't she say? I can't remember now. Oh, AT Productions, Jared.
Yeah.
Who else?
There's a lot. I didn't get to see that because I wasn't listening most of it.
Jinx you. Still going up. Oh, NA. They dropped in to say g'day. Yeah, I bump into a lot of people this time of day that I don't normally see. Wow.
Yeah.
You get all of us that are sleeping during your normal stream.
I was going to say, yeah, you're picking up the people in the bit more of the US market.
Oh yeah, John Rapp says don't do automobile videos. I got struck for plane than trains. Good one, John.
Yeah, be careful on that one.
Don't you guys remember the plane and the planes and trains? I do. I remember.
I think I started watching you during the train strike that you got. When Alan was helping you out.
No, I thought it was the plane one.
Was it the plane one? I don't know. It was the second of the two.
It was one of them, yeah. Yeah,
I think
how long was it for? 3 months and then another 3 months or something.
Yeah.
Well, they've changed all that now. You don't get the same thing now. The setup's different. All right then. Good night, panel. Good night, Peanuts.
All right. See you guys.
Good night, Peanuts.